Check one, two, two. One, two, two. Check. Sound check. Test one, two. Check one, two. Check one, two, two.
ಅವತ್ತಿಂದ ಕುಂಟತಾನ ಇದೆ.
ಅವತ್ತಿಂದ ಅಲ್ಲ? ಇಲ್ಲ, ಇನ್ನು ಬಂದಿಲ್ಲ. ಸುಮ್ಮನೆ ಮಾತಾಡೋದಂತಿಲ್ಲ. ಅದೀದಾ
Elrigu Namaskara. Good morning, ladies and gentlemen. Again, the request what I made like yesterday morning, I would request kindly come to the front. Yeah. So that friends and delegates coming in late will occupy the seats at the back. I would also request our friends from Active to kindly guide the people who are outside to come inside. Well, ladies and gentlemen, the Honorable Minister Shri Rajiv Chandrasekhar is here, the Chairman of the Steering Committee of Semicon India. Good morning and welcome to all of you. Namaskara. We are on day 3 of Semicon India 2022, Catalyzing India's semiconductor ecosystem. And before we start the presentations and addresses by the keynote speakers, I would request all of you to kindly sit back and we'll watch the video first and then the other things will unfold. Video, please.
As we rapidly embrace new age technology, semiconductors have become the new building blocks of a smarter world. With the presence of nearly all of the top 25 semiconductor design companies, India is engaging with the brightest minds in the field to create the most innovative skill hub for semiconductors. Blessed with a rich demographic dividend of a young population and a median age of 29 years, India, under Prime Minister Shri Narendra Modi, is emerging as a global skills hub, focusing on nurturing and training the talent pool for its fast-growing talent economy and the world. In the last few years, India has also delivered successful indigenous technology programs of digital payments and digital identity authentication, connected to the lives of over 1 billion people. The quick adoption of high-end technology-based devices and growing consumer demand for electronic devices have seen a surge in the semiconductor demand and innovation. With an outlay of $10 billion to create a robust and sustainable semiconductor and display ecosystem, the government's Semicon India program has also laid a roadmap to develop and train talent. Nearly 2.5% of the total outlay of Semicon India program is allocated to the R&D, skill development and training requirements. Skill development and training is an essential requirement for generating industry-ready manpower specialized in semiconductor and display fabrication facilities. Special manpower development program is being implemented for Silicon to Startup, SMDP S2S at 100 academic institutions to generate 85,000 industry-ready manpower specialized in VLSI, chip, SoC design and manufacturing. The India's Semiconductor Mission's Design-Linked Incentive Scheme, DLI, to support design firms, aims to augment PM Modi's vision of the next decade being India's techade by nurturing 100 domestic semiconductor companies for ICs, chipsets, SoCs, systems and IP cores. It will facilitate the growth of not less than 20 such companies to achieve a turnover of over INR 1,500 crore in the next 5 years. Partnering with the best and the brightest global semiconductor leaders, India is already on its way to becoming the next global hub for electronic system design and manufacturing.
Well, ladies and gentlemen, on day 3, the opening session is about the economics of semiconductors and next wave of innovations. And the topic about the keynote is the innovation in semiconductor and system design with EDA, IP, and AI. We have with us Dr. Anirudh Devgan joining us virtually, who has served as President and CEO of Cadence Design Systems from 2017 to 2021. And he oversees all business groups, research and development, sales, field engineering, customer support, strategy, marketing, and so on. You can watch some more details on the screen. So I would request all of you to give a round of applause physically. And also, I'm pretty sure the virtual audiences all over the world would also be clapping in unison. And let's welcome Shri Anirudh Devgan. Good morning, sir. It's all yours.
Well, hello everyone. It's a pleasure to be here. I want to thank Minister Rajiv Chandrasekhar, Minister Ashwini Vaishnav, members of the government of India, also members of the press, and also my industry colleagues. It's great to be here. This is an important event and an important milestone for growth of the India semiconductor ecosystem. And this is a very important topic personally for me, of course, given my own background, but also for Cadence. You know, we are a global company, but we have a strong presence in India. As you may know, we have about 3,000 employees in India in 4 major locations. And we have been there for several years from the very beginning. And it's a critical part of the company. And we span all aspects of our operation in India, including R&D, including sales, customer support, application engineering, finance, IT. And it's really good to see this initiative, and we would like to see what more we can do to help. Okay. On that, I would like to start my presentation. And just to give you some perspective from what we see, and you are aware of the mega trends that are happening in the industry, but just to highlight a few key things that will set the stage of a few more specific things I would like to discuss later on. Okay. So as we work with customers throughout the world in different markets, there is one common trend that is emerging, which is this 3 essential components of electronic systems. So the innermost component is the silicon component, and then the system component, and then the data and AI around that. And a great example of that is the electric car. The actual, as you drive down, the actual navigation data, the traffic, the pedestrian, and then the car within that, which is the actual mechanical, physical system with software, with hardware, with electronics, and then the silicon chips that drives the car, whether it is navigation or AI or infotainment. So this kind of trend is pervasive in all verticals. Of course, automotive is one example. As you know, it's true for mobile, it's true for data center, it's true for personal electronics, true for aero and defense, true for emerging verticals like healthcare and personalized medicine. So this kind of merging of these 3 layers is an important trend going forward. The data layer, the system and software layer, and the silicon layer. And what's happening as a result is a lot of system companies and data companies are designing their own silicon, as you know, and a lot of silicon companies, especially the bigger ones, are becoming more and more platform and system companies. Okay. To give you example, in terms of our own business, about 45% of our revenue right now is from system companies. And the good news is that both the semiconductor companies are growing and the system companies are growing. So it's a good kind of tailwind for the entire industry. And there are multiple reasons why, these data-driven or domain-specific silicon will continue to grow. And when I was talking to different customers throughout the world, the three big reasons that we see is one is, of course, value. If you do something specific to an end application, a lot of times the power or the performance can be much better. Okay. The second reason, a lot of times, is schedule. There is certain cadence of release of products, and you have to align your entire stack to that schedule. And third reason, which I think becomes increasingly important, is volume. If there is enough volume, then the economics work out to do your own silicon, to customize the solution for the end application. And that's something that has really increased in the last few years with more and more high volume applications and high value applications. And at the same time, the general purpose semiconductors get more and more powerful, whether it's memory or CPUs or analog mixed signals or sensors. And that's a great trend going forward. And for us also, we are essentially a software company, computational software, CS plus math applied to EDA. EDA has a history of doing this kind of mathematical software for decades. And so our main focus is EDA and IP. But increasingly, we have products in system design and analysis. Actually, more than 1,000 people in Cadence are working on system design and analysis products. And we have a lot of projects on AI and data analytics. We have more than 40 projects that permeate through the entire product portfolio. So this is great. I think this is the golden era for both semiconductors and electronic systems. But the key thing is that we have to look at the semiconductors not just by themselves, but in the context of the vertical end markets. And as you know, there are multiple generational drivers that is driving the growth of semiconductors. It's widely predicted to double semiconductor revenue in the next 5 years to about $1 trillion. And one thing that is different I see compared to maybe 10 or 15 years ago is because of these multiple drivers, whether it's 5G or hyperscale computing or AI, ML, there is less cyclicality. There is less cyclicality to the semiconductor demand. It used to be much more cyclical, and I think it is becoming less and less cyclical and more growth oriented, which is a great environment to invest in. So I think it's a perfect time for India and the Indian government to put even more investment in this important sector. And as you know these numbers better than me, the overall India market is expected to grow even faster than the global semiconductor market, driven by multiple growth segments. And I won't be surprised that it grows even faster than this. So in the end, semiconductors are pervasive, the consumption is pervasive, and India with such a strong growing economy and human capital, there will be more and more consumption of semiconductors in India. Okay. So as we expand, and we have worked with multiple industries and countries throughout the world, and we would love to do much more, and we have a long history of working in India, of course. We would like to do a lot more going forward. But it's always good to see, if you want to expand, what are the strengths that are there in India, and it's always good to build on your strengths. So this pretty well, but just from our standpoint, of course, there is massive transformation. India is a growing market, and also digital transformation over the last few years in India is truly impressive. So that sets the stage for a very, very good growth mindset for the next 5, 10, 20 years. And it's also very encouraging to see the government initiative to drive semiconductor leadership. Because in any situation, especially in India, in a growing economy, there are a lot of demands on capital. There are a lot of demands on areas that the government can invest in. And it's very good to see that they have chosen semiconductor as one of their important areas of focus. The third thing is, of course, talent. It's a remarkable talent in India, remarkable universities, And of course, I personally I'm educated in India, and I have very fond memories of my time at IIT Delhi. Actually, just the other day, I was talking to a couple of senior people at IIT Delhi, and it's remarkable to see the faculty they've hired and the projects they're working on. And that's true in multiple places. Actually, Cadence at this moment, we have partnerships with more than 300 universities in India. So it's a really, and as was mentioned, I think a couple of days ago, 20% of semiconductor talent, worldwide talent, is based in India. Now, I think what would be even better is to have more research in the universities and with the research institutions at the higher levels of undergrad and at postgraduate level. I think in terms of basic engineering, it's world class, and I think there could be more effort spent in the research in end products and markets in Indian universities. And lastly, as you know, there are multiple companies, multinational companies with very strong presence, of course, including Cadence. And I'm sure there are a lot of customers and ecosystem partners in the audience, and we thank their support of Cadence through the years. Now, a particular few things that I think could be interesting potential areas of focus. Now, this is not meant to be a complete list, and I'm sure there are other things that are pretty important too, and these things need to be modified to the particular needs. But from our viewpoint, these 4 things, I think, can have a big part, and we would also like to, help in any way we can in these initiatives. Okay. So first thing, I think that, there's a famous quote in ice hockey that, skate to where the puck is going. And it definitely in terms of semiconductors and semiconductor manufacturing, the future is 3D IC. I mean, it is combined, is heterogeneous manufacturing, combination of chiplets on advanced packaging to drive much better system performance. So both, Moore's law and more than more together in 3D IC. And this is a very exciting trend, and of course, I'm sure you know a lot of things about it already. And we see this pervasive in multiple end markets. And we ourselves are investing heavily in 3D IC. And of course, we work with the most advanced node digital designs, with the most advanced memory designs, analog mixed signal designs. But I think this is a trend that's irreversible, and we are still in the early stages of it. And even as we work with most of the advanced foundries in the world, 3D IC is a critical determinant of success going forward. Okay. The second thing I would like to highlight is India is very strong already in semiconductor design excellence. And I saw that there will be more focus on semiconductor manufacturing, which is fabulous. But it's good to double down on one's strengths in any case. So I think building on the strength of semiconductor design and software excellence that already exist in India, I think AI can turbocharge that and make that 20% of semiconductor talent be 200% of as effective of semiconductor talent. So there's a lot of opportunities of combining AI and semiconductor design to really differentiate going forward. And AI to me is of course interesting, but is even more powerful combined with a vertical and application. Because AI is a data-driven approach, so it is good as a horizontal technology, but the real power is when it becomes domain specific and applied to a particular application. And a great application for AI, I believe, is semiconductor design. The third thing I would like to highlight is cloud. And we have invested heavily in the cloud in the last 4 or 5 years. and to really democratize the access of EDA technologies and IPs to make design easier to do. And I think India has a great opportunity to be cloud first, to really make it much more easier for everybody to access these things. And just like India skipped the landlines and went straight to cell phones, their advantage of when you come to a new area to use the latest technology to leapfrog. And I think cloud, I'll talk more about it, is a great opportunity. And last thing is, I would like to say, like I mentioned earlier, there's a huge opportunity to invest in universities, invest in the startup ecosystem. Now, we are doing some of it ourselves, but it will be great to partner with the government, partner with our ecosystem partners, make sure all the latest technologies are available to the universities. We will provide our software and IP to really turbocharge, because the real opportunity is with indigenous company, with local company, not just, of course, we love all our customers, but we would love to see more local companies in India. So even though we have a huge R&D presence and employee presence, it will be fabulous to see more local ecosystem and whatever we can do to help have more startups, more university research, more products coming out of India. Now, just a couple of slides on 3D IC. I mean, I'm sure you are well aware of it, and I think this is a mega trend. This is a mega trend as Moore's law still has several generations to go in terms of classical Dennard scaling. Classical scaling of transistors. Most of our R&D work right now is at 2 nanometer and below. Most of a lot of our design activity with customers is at 3 nanometer and 5 nanometer. So I think that still has 8 to 10 years of scaling that will happen in a pure, node standpoint. But at the same time, 3D IC can provide a different axis of scaling, also different axis of integration of RF technologies, of analog, of memory. And I think this is truly exciting trend in the industry. And advanced packaging becomes a key component of that, along with, of course, expertise in silicon manufacturing, advanced node development. But packaging becomes equally important going forward. And this whole emergence of chiplets and chiplet-based design, which can be integrated on advanced packages. And we expect the chiplet market to grow even better. And there are a lot of opportunities that come with that. How well packaging and analog and digital design can be done together. IP standards for chiplets to communicate with each other. Compute subsystems and what architectures and multiple architectures are possible there. So this is truly an exciting area, and this is an area that we are also as Cadence investing heavily. So are all our major foundry partners and a lot of the major customers. The other thing I want to talk briefly about is the use of AI in design. Okay. And we have a long history of putting in more and more automation in the design processes, things like digital design, synthesis, place and route, analog design. But what EDA has traditionally focused on is, given a set of inputs, running a design well and producing a set of outputs, but focused on a single run, because there was no mathematical way to carry a knowledge from one run to the next. So typically when our user or designer will run our software, they run the tool, maybe it takes 1 or 2 days, and then they analyze the output and the design parameters, and they run it again, based on their intuition and experience, and then they run it again. So, and that takes, maybe 3 to 6 months to get a output. And this is the state-of-the-art way of doing it. And of course, the quality of the tool is critical, and the quality of the engineer and the experience of the engineer is critical in this. Okay. Because traditionally to do it in an exhaustive way would be impossible because the design itself, the parameters can have millions of combinations. Okay. Now, if you look at numerical methods to do this, typical kind of search of optimization space is done by gradient-based methods. This is classical optimization. But gradient-based methods are not possible for such complex things, like synthesis and place and route, or running simulation of really complicated things. So in the past, there has been no numerical or mathematical ways of doing it. But now with reinforcement learning and more ML-based ways, there is actually a mathematical way to search this space, to run different combinations of whether it is design options or tool options to get the best PPA, which is power, performance, and area. And the results are actually quite phenomenal. Okay. And I'll show you some of that later. And this can really turbocharge the effectiveness of the engineer. Instead of one engineer doing one block or two blocks, one engineer can potentially do 5 blocks. The productivity can go up by 5x, and the performance of the design can also improve. And we have done this now at multiple nodes, with multiple customers in several end markets. But I still think this is the beginning of application of AI to the design process. Now, this is one application that is in digital design. There are applications in PCB design, in analog design, in design verification. But I do believe that whichever company or country or organization can more effectively use AI will further differentiate itself in the design of semiconductors. The third thing I would like to highlight is cloud. Of course, we all know cloud, and I think it gives the massive democratization of access to the ability to do design. And at this point, the working with the foundry partners and working with the cloud providers, we have enabled to a point that all you need is a web browser on a thin client. It could be a laptop or a desktop, anywhere in the world, to access these design systems on the cloud. And they could be set up in multiple environments. It could be set up, the cloud is customer managed, that is, managed by the end customer. It could be managed by us. We also provide, SaaS kind of hosted solutions, or it could be managed by an independent entity. We work with one major country in which they subsidize the setting up of these clouds so that the startup ecosystem and some of the smaller companies could get access to tools, IP, and even hardware to do this design more easily. And we can get into more detail if you want. This is just an example of some of our platforms. Working with TSMC, I actually started working with TSMC, more than 5 years ago on the cloud. And then, now with Samsung, with Intel, with all our foundry partners, and also with the major cloud providers. So we started with AWS, but now Azure, Google, IBM, and it's really good to see all the cloud providers being also interested in semiconductor design and system design. Now, we also have hardware platforms. These are used to do software bring up, like Palladium. And we have our own cloud, in which sometimes the customers will buy the Palladium by themselves. Sometimes they want access on the cloud. So we have our own data centers in which we offer Palladium on a cloud as a service. So again, various models are possible. And of course, we have a lot of customers using these products already in India. And if there is a way to set them up so that it's much easier to use, we would love to do that. And the other thing, of course, is working with the ecosystem, with the universities. And like I mentioned earlier, we have a long history. We're working with more than 300 universities, with several BTech programs, several VLSI finishing schools. and we would love to do more. You know, especially like I was talking to the other day about if we can set up, you know, certain incubation centers or centers of excellence working with top universities, working with the government, you know, we can provide our software, our expertise, you know, our cloud access to really enable more and more innovation in systems and semiconductors. And as you may know already, we are already very active with the India startup ecosystem. And it's good to see that there's more and more startups in India, and we do offer certain innovative business models, you know, throughout the world, and definitely in India, because startups, you know, what starts small now can be big later and can be huge after that. So, you know, in high tech, it's very critical to promote startups, and that's something we would love to do more with the ecosystem. So thanks again for your time. I just want to say it's truly exciting for me personally and for Cadence to be involved in this event. And you know, these are just some suggestions, and you know that we see in terms of where the industry is going. That I think that can be great for India, that can be great for Cadence, that can be great for our customers. You know, things like differentiating with 3D IC, which is truly the future of semiconductor manufacturing. You know, leading in AI to drive even more productivity in the design process. Cloud for, you know, democratizing access and incubation, and R&D investment in universities and startup ecosystem. And Cadence is eager to partner, eager to invest and go together. Thanks a lot.
Thank you, sir. Any one question can be asked. Anyone? Yeah, there. So there's a question. Yeah.
Good morning. I am Pranay from Takshashila Institution, and I work on semiconductor geopolitics. So my question was, geopolitical contestation has emerged as one major risk and opportunity for the EDA industry as well. So how do you see it, and what are the ways to make the industry more resilient to such shocks?
Well, you know, what we always say, you know, what we always focus on is having the best product. You know, we have about 40% of our R&D invested in, 40% of our revenue invested in R&D, which is the highest level for any kind of large-scale public company. And so, yes, geopolitics things will evolve, and you know, there's always you know, local competition or you know, sometimes state-sponsored activities. But if we have the best products, we work with the right customers. You know, that's our focus. You know, this is technology business at the end, and I believe best product always wins. And I think it's very important to have not just set up things, but to do them well. And I believe that always works out in the end.
Yeah, sir. Sir, 1 minute, kindly, the Honorable Minister wants to.
Good evening, Anirudh. Good morning from Bangalore. Rajiv Chandrasekhar here. Look, obviously, one of the important things that we are hearing from this conference is the need to develop talent, deep talent, and skills around the semiconductor ecosystem. Can you just, in a few minutes or a few words, tell us what you believe the priority should be based on your own understanding of the talent pool in India? What do you think are the areas that we really need to concentrate and where these skills need to be further developed and expanded? Thank you.
Yeah, that's a great question. You know, there's multiple facets to the answer, but I can tell you that one of the strengths of US that I saw personally, of course, I had fabulous education in India, in IIT Delhi, and then when I went to Carnegie Mellon, and CMU is world class in in computer engineering and VLSI. I think this combination of research activity in universities, investment from the government, US invested heavily after World War II and even the big companies, and the coupling with industry, and to solve, like, I think the focus should be this three-way combination of industry, government, and universities, and to focus on uh, product level problems, all the way from the system level down to silicon. I think that's a formula that always works. And I think that more and more of these research centers of excellence, and we would love to participate on our side, to take the education is already world class at the undergrad level, but in terms of product and research can be a breakthrough for India, in my opinion.
Thank you.
Thank you, Dr. Anirudh Devgan, for your keynote address, and take care, sir. We'll be closing this session with your concurrence. Yeah, thank you. Thank you very much. And now we move on to the next session, which is, in fact, a fireside chat on 5G, 6G, next wave of innovation opportunity for India. It's a combination of physical and virtual. In the virtual mode, we have Shri K. Rajaraman, Secretary, Department of Telecommunication, and also the Secretary of MITI. He has held important positions in the Union Government, including Additional Secretary, Investments in Infrastructure in the Department of Economic Affairs, Finance, and also Joint Secretary in Department of Expenditure. We also have with us Professor Arogyaswamy J. Paulraj, the Emeritus Professor from Stanford University, who is known for the invention and advancement of multiple input, multiple output. And he founded 3 companies in wireless semiconductors in Silicon Valley, acquired later by Intel, Broadcom, and HP. And also we have with us Dr. Kumar N. Shivarajan, who's the co-founder and Chief Technology Officer of Tejas Networks, and which is India's leading design-led OEM of high-performance wireline. Yeah. I would now request Dr. Kumar N. Shivarajan to kindly come over. Physically, he's present. So, ladies and gentlemen, let's give you a round of applause. Shri K. Rajaraman and Professor Arogyaswamy Paulraj will be joining us virtually, and Dr. Kumar N. Shivarajan will be here physically. Yes, they've all joined, sir. It's over to you.
It's a pleasure to be here today with 2 eminent personalities. So let me begin without much ado. I will play the role of posing questions to Professor Paulraj and Secretary Rajaraman, and we hear from them. I'll begin with Professor Paulraj. Professor Paulraj, India is on the brink of launching 5G. But US and other countries have already launched 5G. What are some of the learnings that we can take from the launch of 5G in the first few months or years in US and other countries?
Good morning, Kumar, and good morning, Mr. Rajaraman, and also my greetings to everybody in the audience. I can see Minister Chandrasekhar, and also I think I see Vinod Dham there. So, my greetings. Well, let me, before I sort of get into your question, Kumar, let me mention a Government of India report which I was involved with on 5G, and it sort of optimizes what 5G is for India. So, let me read it out. So 5G is the next generation of cellular communications technology with evolutionary and revolutionary services that can have a deep impact on India. So 5G can unleash new economic opportunities and societal benefits, giving it the potential for being a transformational force for Indian society. It can help the country leap forward the traditional barriers to development, as well as to advance the Digital India vision. The cumulative economic impact of 5G in India can reach perhaps up to $1 trillion in the next 15 years or so. So it's a huge opportunity for our country. So let me say that 5G, unlike 1 to 4G, is not just another G. It is certainly that, but it also opens up a complete new dimensions of supporting connectivity to transportation vehicles to IoT, manufacturing, remote operation, so a whole range of new services. In fact, in some sense, that is the more interesting part of 5G, and perhaps for India, the most interesting part for value to our country. So having said that, a little bit, your answer to your question is complicated. Let me focus a little bit on the US, where I'm more involved with. So US launched 5G in the millimetric band, perhaps about 3 years ago, I think. And so Verizon and AT&T have been the MNOs, operators. A millimetric band has proved to be a little challenging in terms of its range capability. And the equipment, as yet, is still expensive. It's almost a full 3G, 5G base station DNB with its own pole is almost $75,000. It's about $45,000 for electronics. So obviously, the AT&T has been very slow. Verizon so far has built about, I think, 20 to 25,000 GNBs. As you know, for full coverage in the United States, we need 300 to 400,000 base stations. So it's been going a little slow, and because the business case is still not great, so everybody has been waiting for the C-band to be allocated. So that has now been done. So in the 3.65 to 4 gigahertz, and so there's been slight hitches there with the altimeter issues. But I think that should hopefully get resolved mostly soon. And C-band, the rollout will begin to happen. Today, in the millimetric band, we probably have only about probably not more than 1 million customers. It's also what's happening in the US is we've been deploying 5G in the 4G bands. It's called the dynamic spectrum sharing, where we actually cooperate 4G and 5G together. So that's added another 1.5, 2 million people. So we have about 3 million subs in 5G notionally. Globally, it's much larger. It's probably around 350 million. Most of it is in China. And so just to finish up this response, US is moving slow so far, but I think with C-band, we want to build momentum. By 2025, we should be 50, 60 million subs. There's another band called the CBRS band, which is kind of quasi-licensed with the general licensing and the proprietary licensing. That's going to get probably deployed in private networks. The private 5G networks just begin to take off. So it's a mixed picture, but US certainly now is really focused on building up our 5G.
Thank you, Professor Paul Raj. I'll return to you. I think there are a number of follow-on questions I could ask you on various aspects. But I'll now turn to the Secretary, Sri Rajaraman. The Government of India and both DOT and MeitY have had a number of initiatives over the last few years, probably arising from the committee report chaired by Professor Paul Raj, on encouraging 5G. I think so. I request the Secretary to outline some of what has been done and what is in the works.
Good morning to the Honorable Minister and to Professor Paul Raj, who's on this call. I think he's a dear friend of the Government of India and the Department of Telecommunications. Morning to you, Professor, and morning to you, Mr. Sivarajan, and to all the other participants in this great conference. So it's a pleasure to be part of this discussion. I think very, very deep discussions are going on, as I could see from the previous presentations and so on and so forth. it's really a great, I mean, I think I would say brick loads or ton loads of inputs, which the government of India needs to now take forward. Now, coming to a question, I think the 5G was around the corner for quite some years, I think. So India has been quite active in the areas of preliminary research, standards making, and so on and so forth. So to answer your question, I would go back to 2018 when the government of India decided in the Department of Telecommunications to invest nearly about $30 million in a 5G test bed covering about 8 institutions led by IIT Madras, IIT Mumbai, IIT Hyderabad, Kanpur, Institute of Science, Samir, and a lot of institutions are also involved in this process. So this forward-looking initiative, I think, was led by was rather based on the high-level forum report, of which Dr. Paul Raj was a leading player. So the recommendations of this report led to the formation of this test bed. And I'm happy to say that the test bed has seen very significant progress because they have developed a 5G core, a standalone core. They have developed a radio head which is in FR1 and FR2 bands. Other auxiliary technologies, including NB-IoT chips and a host of other equipment that is required for 5G, all have been developed as part of this. Now, I'm also happy to say that the 5G testbed products, which have been put out by these institutions, have been picked up by a few institutions, including our own CDOT, the TCS, and a couple of other institutions are picking it up and probably working on the hardening of these products into a carrier-grade, market-ready product. So, as the previous speaker from Cadence also mentioned, I think it requires substantial amounts of investment in research and development. I think that is what is the way forward for India in terms of developing technologies that are future ready. So I would also use this opportunity to say that the opportunities are not only since this conference is all about semiconductor, the opportunities in chip making is also phenomenal. In fact, some of our companies like Sankhya, Lekha Wireless, Wisig, there are many of these companies that are also involved in chip design for 5G and 5G advancement, so on and so forth. So a lot of capabilities have been developed locally, which I believe needs to now be taken to the next level through investments from the government, through R&D investments, and also other facilitation that is required. Let me also close my answer by saying that it is not only the investments in the R&D that is important. It is also important to enable intellectual property to get into international standards. That is very, very important because India's participation and global leadership would be tested by its level of participation in standards making in global bodies. So I would also like to say that that the efforts of the IITs led by IIT Madras has been phenomenal, especially in breaking into this very closed club of standards making, which is in the 3GPP, which is the global standards body for mobile phone. So the large mobility, low mobility, large cell or large coverage LMNC standards, or which brings in a new encoding standard to enable the investment made by a TSP in a tower. It covers a larger area with the same kind of investment. It's something which is very important for a country like India, which has got large areas which are rural in nature, where populations are thin, and also we have mountainous terrain where populations are thin. So therefore, we need to ensure that our capex is efficient. So therefore, this LMNC standards, which has been called as 5GI, and I think many of you may know about it, has now been accepted as part of the 3GPP release 17 standards, thanks to the excellent work done by our research institutions and also the cooperation of device makers and equipment makers, including MNCs. So this has been possible because of the tremendous leadership of the Honorable Prime Minister and the Ministers of Communication and the Ministers of State and so on and so forth, which have led to this collaboration happening for the first time. So going forward, I see a lot of effort happening in local research as well as in standards making. Thank you. Over to you, Dr. Sivaraj.
Thank you, Sri Rajaraman. I think the Secretary touched on a number of points. India has taken many steps over the last few years to develop various aspects of 5G technology at a university research level. But now, it's time to roll it out. Spectrum will be licensed and we'll have 5G systems. My question to Professor Paul Raj is, as in the next step, when we start to commercialize, should we build systems? Should we build chips for phones? Is there any aspect of 5G we should focus on? You touched upon IoT and V2X as being sort of key applications. There's also the issue of licensing. So maybe I'm asking too many questions at the same time, but what would be your advice or prescription for the next steps we should take after we now have a proof of concept 5G technology?
Thank you, Kumar. So one point I want to make, and I think well understood by everybody, is that 5G is a global technology. We just look at anything touching 5G, the ecosystem there are probably 15, 20,000 supply chain companies in 5G at various levels. And the standards themselves are globally set. They're probably something like 25,000 standard essential patents. So it's a global system, and India should integrate more and more with the global systems. We not only build technology for India, but also for the global markets. It's only then that we have a really viable technology. So that's my one thought that I have. That is, we certainly it'd be good to have some captive markets in India initially, but we must go beyond that and compete and win globally. And that is will take an enormous amount of effort, because the incumbent companies are very heavily funded, and almost any company today building chips or devices on the client side employ tens of thousands of people, and vice versa, also likewise on the infrastructure side. So we've got to scale up, but I think we've done a great job. I'm very close to the activities in IIT Madras, and so it's a very good start, but do remember that there's a lot of scaling up to be done to make sure that we can actually deploy these systems. 5G, I mean, just a little bit of history is that it's actually more, it turned out to be pretty complicated, because there are already 3 dimensions in cellular. It's time, frequency, and the MIMO dimension. But 5G has beamforming, and I'm involved with the industry here, and more I look at it, more I find that it's really complex. And in fact, what we lack in Silicon Valley is talent, finding really talented people who have the experience to build these systems. So India can play an enormous role here. Having said that, let me also say, you mentioned licensing. Maybe I can take it up as a separate question. But once India, we are serious about entering this whole area, then we got to get really clever about, or get involved with the whole issue of FRAND and SEPs and licensing. As you know, for example, every phone that we buy, something like 10% of that phone cost goes for licensing. We currently may not face it in India because all the manufacturing of phones in India are controlled by MNCs who look after it. But once we start building IP in this area, as the Secretary mentioned, then we play a central role in the whole area of licensing and FRAND. And this requires enormous infrastructure. In the United States, I think we have about 25,000 people at the governmental level, in the law firms, in the court systems, and in companies involved with all the legal issues around licensing. So we'll have to build all that. So licensing is a very, very important part. And once we start building IP and claiming IP, as we've begun to do, we've got to bring that up also. So it's right now, I think the infrastructure is very limited in India, but we've got to build that. So let me hand it back to you, Kumar.
Yeah, thank you, Professor Paul Raj. I'll have a follow-on question to Secretary Rajaraman. I think Professor Paul Raj outlined that it'd be important to build systems companies with an initial market in India and global focus. And he also touched upon the FRAND issues, especially in the context of phones. But FRAND also impacts system companies equally well. Of course, you could leave it up to individual companies to go after FRAND, but is there any thinking of how the government could support Indian companies to get some of these IPR on a FRAND basis, of course, either for phones or for systems companies. So any thoughts, sir, on that front?
Thank you, Dr. Shivarajan. I think we essentially, we believe that the product development in India will be driven by, original design making within the country, which I think many companies are involved with, and also the possibility of acquisition of technology. I think this is both are equally important. So in the last budget, which the Honorable Finance Minister announced, we have decided to launch a design-linked incentive scheme for manufacture of telecom equipment in the country as part of our production-linked incentive scheme, which will provide for the kind of acquisition of technologies. So, and also for original design within the company. So we acknowledge that that unless there is a domestic development of technologies and designs and IP, the product, the scale of companies and the presence in the global market would be peripheral. So from that perspective, I think the importance the government gives to the support for industries that is required for coming out with designs is very important. Similarly, the case with the semiconductor policy which has been announced by the government, wherein I think a design-linked incentive scheme also has been put in place. So the support that is provided therein would help in kind of developing technology, not only original, but also probably based on technologies that can be taken from other countries. Going forward, we will be very open to actually to take suggestions on how we could make our programs and schemes much more supportive of the industry, especially on these matters. We look forward to input from your end as well. Thank you.
Thank you. I'll turn again to Professor Paul Raj. So you alluded to millimeter band having its challenges and maybe FR1, C-band getting greater focus. You also said something about CBRS, which could also have applications here for rural broadband. So do you have recommendations on areas we should focus on? Should we skip millimeter band altogether and just focus on FR1? Should we do something like CBRS for rural broadband? Should we focus on V2X and IoT and sort of pass over the mobile broadband, sir? So any more advice?
Thank you, Kumar. So Amit raised a lot of questions. So what I would say is that I think the millimetric band, there's little footprint in South Korea, Japan, and mainly in the United States. And I think in general the view is that it's challenged. And but a day will come, because in millimetric band we have something like 15 times the amount of spectrum we have in the low bands, or even in the 10 times spectrum in the mid bands. So spectrum is king. So millimetric band has it, but I think it's in terms of competitiveness, in terms of market competitiveness, is still weak, but it'll come back. So I would think as a priority, I would not prioritize millimetric band in India right now, but not something to ignore. Having said that, 5G fundamentally can operate in any band. It can also operate in the low bands, in the sub 1 gigahertz bands, and in the standard LTE bands. And in fact, in the US, a lot of that has begun to happen through what I call dynamic spectrum sharing, which I think India should look at. Therefore, technical operators can deploy 5G in the current LTE bands. But of course, we should open up the C band. And I believe the spectrum will be auctioned soon, and that will bring 5G into those bands. With respect to CBRS band, and let me also say something about 5G. Why should 5G actually replace 4G? Well, it's spectrally more efficient. It's more refined technology. It's got a lot more bells and whistles. Even for phone access, it's a better technology. So you want to really move it in. I'll comment about URLC later. You mentioned about CBRS for rural. The rural is all about range, and I feel that we should deploy 5G, but deploy it in the low bands for rural, because that's where we get more range. So I would be a fan of moving 5G into sub 1 gigahertz or sub 2 gigahertz bands. And CBR is banned because it's partly unlicensed, or at least that's how it works in the United States. It's actually very attractive for private networks. So things like universities, manufacturing facilities, warehouses, airports. So, there's a very good reason why private networks, as different from public networks, actually make sense. So I would actually, and because it is semi-licensed or unlicensed, private network can actually deploy this quickly, and the big operators will actually have the license bands. So I would actually look at CBRS band. We've had something similar in India to go take it to private networks, do the rural on the lower bands with 5G, no problems. And millimetric bands, at this point, de-emphasize it till the world ecosystem builds up more. But at one time, we will need it, spectrum in the nominal spectrum there. To come back to the second question about the other part of 5G, that is the URLC and the MTC part, IoT part, that is an enormous opportunity for our country, because we do have, our infrastructure remains weak. It's not easy to fix things quickly, and this can be a very big part. But this has been going slow. I think only one country in the world which has been doing well, and certainly in Europe, I think there's been more progress. United States, it's not been moving well because it's much harder. It's not like buying another phone. You got to wire in the transportation system, you got to wire in manufacturing, who are not familiar with this technology and use cases. So what's needed really is, and this happened in China, is that to have massive government investments in use case, in small townships to labs, to help industry build use cases and try out ideas to build this area. Europe has done a pretty good job, and United States, we now realize that the government has to play a role. And so I think now there's lots of discussion about government funding such use case investments to accelerate the role of 5G in this other area, V2X and manufacturing. So I think there too, I feel India, we should have a very concrete plan and make that happen, because we will and should manufacture a 5G infrastructure. But remember, that's a small part of the entire value of 5G for India. 5G value in India's applications. And that application on the phone side, I think, will happen. But on the other side, it needs a government pushing. And I think we need to go back and build a concrete plan to make that happen. And we can actually lead the world if we do a good job.
Thank you, Professor Paul Raj. We are almost at the end of our time. So I will now turn to the Secretary to say anything about the bands in which India plans to launch 5G, and then I'll give both of you a chance to say what you want about 6G before concluding. So, Secretary, sir.
Thank you, Dr. Shivraj. So, I'd just like to add some thought to what Dr. Paul Raj just mentioned. In fact, for the first time, I think we will be putting new bands to auction, which includes, say, 600 megahertz band also. I would feel that this is a very important band for India, especially because it's a very large country. The sub-gigahertz band is actually a coverage band and a penetration band. So therefore, from that perspective, I think the 600 megahertz is very important. It's a great opportunity for Indian companies to come out with 600 megahertz radios. So I would entreat the companies who are part of this conference to come out with chipsets and other radios for 600 megahertz and 700 megahertz, because there is a great opportunity. Similar is the case with millimeter wave. As Dr. Paul Raj mentioned, maybe the use case for millimeter wave may not be as widespread as perhaps the C band, which is the most important capacity band for 5G. But certainly, I would feel that there is opportunity for it in use cases like Industry 4.0. So I think there is I think that's where I think, as he said, we might actually need to invest in the capacity building of various government departments as well as the industry, and work with the industry to ensure that there is proliferation of use cases across various sectors. So let me also use this opportunity to say that we have set up an interministerial group which is now very actively working with all the key ministries. It includes the Department of Industry, the Agriculture Ministry, the Energy Ministry, the Power Ministry, the health ministry and the urban development ministry to actually to roll out use cases that are potentially possible because of 5G. And some of these require test beds, actually, as Professor Paul Raj mentioned, and a lot of investment also needs to go into it. So we are in the process of looking at how to finance these test beds and get the appropriate institutions involved in this process. So over the next 3 months, we would probably be supporting and facilitating the launch of these test beds in some of these leading institutions which are domain experts in this particular sectors. Now, I would also like to add a few things relating to the licensing framework, which came up a little earlier. So, as Dr. Paul Raj mentioned, I think the IoT machine-to-machine communication is a very, very important part of the industrial applications which are possible. So, from that perspective, very recently, about a couple of months back, Department of Telecommunications rolled out a registration mechanism for end-to-end service providers, low-power wide area networks, and so on and so forth. So, and we see the last month or so, I think about 8-9 applications have been filed, one has been granted. So we would see a lot of businesses coming up based on this M2M communication, and 5G promises to add on to that using the massive machine type communication feature that is embedded in that. So going forward, the 5G use cases would lead to a lot of innovation happening in all these industry verticals, rather than probably personal communications which were using mobile handsets. I mean, obviously, it will present a better user experience, but I think the substantial amount of growth would happen going forward in these industrial use cases. So with these, I would end, but since we are part of this semiconductor conference, I would also entreat the participants who are there to look at development of these chipsets which are there in the RF transceivers, baseband chipsets, IoT chipsets, and also various low power chipsets which are probably be used in the private networks that will come along with 5G. So thank you, Dr. Suraj.
Thank you, Secretary Rajaraman. Concluding remarks on 6G, because that's part of our mandate. So Professor Paul Raj, what would you want to say about 6G?
Right. You know, I sit on so many committees on 6G here. US has now begun to look at it also. Certainly, firstly, we must, in 6G, we must be an active participant both at research and in the standard. So I think in 6G, there'll probably be 50 to 60,000 submissions in 6G when it begins to, it'll start, the standard submissions start around 2026, and we should at least get 5% of those. That's something like 10,000, not 10,000, so something like a couple of thousand technical submissions into the standard. So that needs a lot of ramping up. So we should do that. And I usually joke saying that we must first really start deploying 5G, learn all the pain points, and then define 6G. So, but having said that, certainly the usual things about 6G are that we want to go to higher frequency bands, to terahertz bands. I get a little worried because we had enough problems in the millimetric band. Certainly space-based networks, which is attractive because that's, when you have base stations in the sky, they treat both urban and rural equally well. So we can really get broadband into our villages if we have space-based networks, active reflectors and others. So the huge opportunity. So we need to ramp up our research, but more importantly, ramp up organizations like CVIT and universities to at least capture about 2 to 3% of the submissions into the 6G system, and hopefully also get some steps.
Thank you.
So India has, you know, as I look at this area, when you look at 5G and AI, the real issue today in the world today is finding the right kind of talent. These things are really complex. India has lots of them available. I often say much of them in our villages. So let's find them and bring up our technology and be a part of the world, be an important player in the world. Thank you.
Thank you, Professor Paul Raj. Secretary Rajaraman, any remarks on 6G before we conclude?
Yes, I mean, I will just take 30 seconds. So we, the Government of India have set up a technology innovation group on 6G. I mean, I think, and there are about 5 task forces which are working on under it in terms of spectrum, in terms of IPR development, terms of systems, and also on conceptualizing R&D test beds for the same. So let me also say that very recently in Meiti we have sanctioned a 140 gigahertz test bed for 6G, where IIT Madras and SAMI would be involved, and there are more such test beds which are in offering, which will probably go towards the terahertz frequencies as well. So we would be very happy to receive input from the industry in this regard, and let me say that it's exciting days ahead. And as Professor Palraj says, I think we need to all work together to see that we have more submissions, more standard essential patents from India, I think, going forward. And Government of India will be constantly and consistently in support of all these efforts. Thank you very much.
Thank you, Secretary Rajaraman, Professor Palraj. I think I've already run over time, right? It was 10:15. So I will conclude here and leave it to the organizers if there's time for audience questions. Otherwise, I conclude here.
Yeah, I think if the questions are quick, we'll take 2. Otherwise, we'll take 1. Yeah. Here, Illy, Yure.
Yeah, I'm Hitesh, sir. Thank you for those insights. Being part of the indigenous 5G testbed project myself, and having known independent end-to-end wireless system design enthusiasts, I often see them struggling to access state-of-the-art equipment like 5G 5 compliant analyzers or large bandwidth high performance USR base. Can encouraging indigenous 5G instrumentation equipment boost the telecom as well as the semiconductor sectors in India? How do you see the prospects of the development of an indigenous instrumentation equipment manufacturing contribute towards the 5G as well as the semiconductor manufacturing industry?
So I don't know if the question was audible and which one of you would like to take it. How do you see the development of an indigenous test equipment market for 5G? Not market, test equipment developers in India. We have a market, of course. Yeah.
You can probably make a few comments. Maybe perhaps Secretary Rajaraman, and I can follow.
Yeah. It's a very, very important area, because obviously these high-end equipment which are traditionally supplied by a few companies is a very, very important part of the infrastructure. It would take a lot of effort to actually develop these kind of instrumentation and things like, say, signal generators and test equipment and so on and so forth. So it would take a lot of effort. We would be very happy to work with the industry here to see how we could support you as part of the research and development grants, as well as part of the production-linked incentive schemes that we currently offer. Thank you. Over to you, Professor Palraj.
I think Secretary
Thank you, sir.
Important point, let me answer. So I would just say that, in India, we're just beginning to enter this wireless ecosystem. I think we're doing a good job, and I have to thank Kumar for all his good work in 4G. But the thing about instrumentation is that the market is always fairly small.
Yeah.
So within the bandwidth that we have in our country, I would put more effort into infrastructure development and into device development. But certainly, to the extent there is skills available, equipment could be a part of it. But do remember that the ultimate market value is small compared to the impact of 100,000 base stations or millions and millions of handsets.
Thank you, Professor Palraj. Is there time for another question?
Yeah, one quick question. Yeah,
sure,
please.
I'll ask quickly. But before that, thank you so much. You put it very beautifully that let's implement 5G successfully and then take that learning and go towards 5G, 6G definition. So the question on the same line, what do you think is our biggest barrier to launch 5G successfully, and how are we trying to overcome that barrier?
Which one of you would like to take it? Maybe Secretary Rajaraman, our secretary? If not, I can. Your thoughts, sir, what's the biggest barrier we have to launch 5G? Spectrum is being auctioned, operators are ready. Maybe there is a business case. I don't know the gamut, that's the gamut of questions, but any thoughts, sir, on what's the barrier to launch 5G?
Let me say that 5G, like any other new technology, is unknown. There is some uncertainty because about the revenue potential and the use cases and so on and so forth. But let me say that the experience of the other countries, as Professor Paul Raj mentioned, I think this technology will take steps gradually. I think it is not something which would proliferate all of a sudden. In a year or two. It will take 5G will have a long years ahead, at least about 5 years or 6 years, and to grow in this country. And I would see the use case development in industry going forward as the most exciting phase of 5G, I think, because of the new features that it offers, like network slicing, maybe things like the MFTC, URLLC. These kind of features are required in niche areas, and these are the guys who would actually tap it to gain more productivity and to unleash more efficiency in their processes. So going forward, I would see this part of the market growing very rapidly, and therefore, it is exciting days ahead from that perspective. Thank you.
Thank you. I think I'll conclude here. Thank you, Professor Paul Raj. Thank you, Secretary Rajaraman.
Thank you very much. With that, we come to the conclusion of this fireside chat, and now we move on to the next presentation on the propelling growth of semiconductors in communications. We have with us virtually Mr. Matt Grob, the CTO, Chief Technical Officer at XCOM Labs, which develops innovative wireless technologies, and he previously spent close to 26 years at Qualcomm in technology and engineering leadership roles. Importantly, ladies and gentlemen, please note that he is a trustee of the Fleet Science Center in San Diego and a volunteer for over a decade at FIRST, the robotics and education organization inspiring future leaders in science and technologies. So let's give a round of applause to Mr. Matt Grob, who has joined us online. Yeah, and hearty welcome to you, sir. Can you hear us? Can you hear me?
Can you hear me okay?
Yeah, okay.
Thank you very much. I'm very glad to be here and excited to talk to you. I wanted to make a few quick opening comments. Again, I'm very thankful for this opportunity to present. India presents an amazing challenge for wireless network scale and performance. And for someone who's been involved in wireless for a long time, I'm really excited about trying to tackle these challenges, and I'll explain exactly what we mean by that. And in particular, semiconductor advances are going to be enabling significant performance gains, and we'll talk about why that is. In my preparation for this talk, I learned that India's mobile data consumption at 12 gigabytes per month per user is the highest in the world, and the growth of as many as 25 million new smartphone users per quarter is very dramatic. Many years ago, when we first started working on high-speed networks, our goal was 200 megabytes per month per user, and now we're looking at something here that may be as much as 2 orders of magnitude higher. There's a profound relationship between the semiconductor evolution and the wireless network performance and capacity, and we'll explore that a little bit. So in this talk, I'm going to offer a historical perspective on wireless innovation, how we got to where we are, and what's to come next, and some comments about how the user interface, the interface between the actual device and its user often drives requirements for capacity and can be predictive of future requirements. I want to talk about the interdependence between communications networks and semiconductors, and really argue that the wireless business is born by the advancements in semiconductors. I'll offer 2 examples, one a high-capacity 5G radio access network, and another example, a robust, high-performance, untethered augmented reality, virtual reality network. And then sum it up, and hopefully I'll be able to take a few questions. So let me just recount one view of cellular innovation over the last 3 decades. Starting perhaps, let's say, in the 80s, when analog cellular came into being, and this was the first time large numbers of users could communicate and dial phone calls to each other with a mobile battery-powered device. We now call it 1G. At the time, we didn't call it that. But since there's been 2, 3, 4, and 5, and coming 6, now we call it 1G. And it used analog modulation, frequency modulation, for example. Then the desire on the part of operators to have higher capacity led to the introduction of digital techniques, which increased the capacity. Now, the radio parameters, to some extent, were the same in terms of what band and approximately what coverage area per tower, but the modulation encoding allowed higher capacity. And then that's known as 2G. Qualcomm had CDMA, IS-95, there was GSM, and TDMA, different forms. They became very, very successful. And then we moved to 3G, which was more advancements to improve the throughput and allow internet connectivity. And in this era, gains came about through improvements in modulation and coding. And then moving into a more modern era, the standards and the requirements in order to improve performance use techniques such as carrier aggregation, and then ultimately the definition of wider channels and more spectrum and more reused spectrum, the introduction of smaller cells that could use a piece of spectrum in one area, and then I reuse it again nearby and again. That allowed the increases of capacity. And then with 5G, the introduction of millimeter wave bands, which provided, again, a lot more spectrum. So in this era, more spectrum resource. In many cases, the modulation and coding is not that much different. Yes, it's refined. There are always incremental improvements, but it lies in the same category as the previous generation. For example, on 4G versus 5G at sub-6, but there's more spectrum, wider, more bands, wider channels. That's the era we're in now. Looking forward, we envision more use of joint processing, where a single, very powerful modem can process the signals from multiple phones, from multiple base, and also transmit to multiple phones, base stations concurrently. And through the use of processing, which is, again, where semiconductor comes into play, huge performance gains can be achieved. And we'll be talking about that. And also peer-to-peer, and device-to-device, in cases where the fact that a piece of equipment can either act as a user device or assist the network, or components of the network can be entirely wireless and use the spectrum for both access and backhaul. Those are very powerful techniques, which we think will bring a lot more performance gains going forward. And I want to talk a little bit about how cellular user performance requirements have been very much influenced by the user interface of the device. So in the case of the original voice phones, that's really for voice. That's for audio, that's for your ears. That's an ear service. And if you notice the device has got a big round speaker and nice ear seal that you can put, and the voice quality is very good. But the radio design was characterized by the need to transport voice, which is a few kilobits per second. It's characterized by symmetry, uplink and downlink needs to be the same, equal grade of service across users. You want one user to have the same voice quality as another, and you'd like it to be the same whether you're close or far from the base station. Sometimes it doesn't always work out that way, but that's the goal of the network, to try to do that, and that's how things started. Then became the era where we started to put pictures and videos on the devices. And that's really service for your eyes. And in order to capture that demand, you need more throughput. You need megabits per second, or maybe tens of megabits per second, in order to supply high quality video, because it's no longer ear service, now it's eye service. And as you can see, the displays on the devices went from a couple of lines on the first one to expanding and filling the entire real estate of the device. The microphone and speakers are now just small dots, and everything is screen. So where are we going? Well, perhaps we're going to brain service or total immersion, where you wear a head-mounted device, and now the requirements are hundreds of megabits per second, or even gigabits per second. And I'm using this fictitious science fiction analogy. This picture comes from the 60s, but in fact, the idea of a head-mounted device training a surgeon to do something beyond their normal ability is exactly what's happening. And there is in fact, multiple projects now to achieve that, and you need very good wireless to be part of it. So a theme with this is computing power causes benefits for wireless. And that's the central theme for this event with semiconductors. The more powerful semiconductors and processing enables more signal processing and compute. More compute enables more capacity. And so this is a photograph of an actual machine that we built that is deployed in a sports venue. It's at an NBA stadium, and it runs there. And using these advanced techniques together with computing power, we can get linearly increasing capacity in many relevant cases. So on this chart, there's just a comparison between some legacy techniques, distributed antennas, and small cells, which, by the way, are great things and have accomplished a lot. But as you scale them up, they tend to saturate. And with the joint processing and coordination, you can have linear capacity gain in relevant scenarios as you increase the processing power and the number of radio units. And so that's kind of an explanation of improving the capacity of the network, but doing that lets you deploy with greater effectiveness concepts like edge computing. And that means you can run apps that would previously be run on the smartphone processor. Instead, they can now be run on an edge computer. So if you think about it from a developer standpoint, what would you rather target? A mobile processor or a big, powerful edge computer? Of course, there are benefits to both, but the point here is for very high performance applications that may be very compute intensive, you can actually benefit by targeting an edge computer that has a bigger footprint of processor power and memory, and can reduce the cost actually of developing powerful applications. Okay, so now I'm going to give you two examples, starting first with a high performance untethered AR/VR. And this again is an evolutionary chart, starting with what we've seen in the recent past on the bottom left, which is a tethered system. Many of you may have tried this already. You can get a head-mounted display from a vendor like HTC or some others, and cable it up to a gaming computer with a big graphics card. In fact, there are actually products on Amazon that you can buy to carry your cable and attach it to the ceiling so you can stand there and have this experience. And by the way, it works fine. You get a very good quality experience. You can use a big, heavy graphics card. As long as you kind of stay in the same small spot and there's only one user, this works well, but we obviously want to move on and get rid of the tethers. So there have been many companies now that have gone to try to put a backpack on a user. And in some cases, it's not even like a laptop. It's like a full desktop gaming computer with full power, large battery, very heavy, can be over 20 pounds, but you get a very good experience and you're not tethered. And that's an intermediate step. But what we really want to get to is the next few steps, where the processing of the backpack and the heavy graphics are untethered and moved into the network. And so now the user device, again, with its requirements as it interfaces to the user, can be much lighter, lower power, lower cost, and also you can upgrade the graphics without having to change the user device. So there are many benefits and of defining this and supporting it with high performance wireless for stages and sites, which is what we're doing now, and looking forward to larger venues with multiple sites, and ultimately at the end, wide area applications, outdoor parks, campuses. And now if you think back to the original couple of kilobits for voice, now we may be talking hundreds of megabits for completely immersive, again, times large numbers of users. You realize that we have to really increase the performance of the wireless network. So here's an architectural diagram of this approach. The blue stack is what you would have without the wireless component. You'd have an application and a game engine and an SDK. We split that and put the wireless in the center, but we don't change most of the other parts. The application, the game engine, the SDK, those all are as they are now. They may feel like they can target a larger processor, so that's good, but you don't have to go to the vendor and ask them to rewrite things. And yet you can enjoy the benefits that I described. There are many, many use cases for this. I can't, in this time slot, go through them all, but I want to just mention the telemedicine one. This is one that is definitely happening, and an example would be two surgeons. One surgeon is local where the patient is, operating on the patient. Another may be remote and have a specialty or is an instructor or may have some special reason for participating. And with these technologies, the local surgeon can have a augmented reality view where an overlay of the instructor or specialist can be there in real time helping out. The instructor or specialist can use a VR view to overlay and annotate everything he or she is participating in. And the result is, much better patient care and better use of the expertise. And of course, what do you want? You want high throughput, you want low latency, you want to be tether-free, you want small user devices. So this is just one example of many of the kind of services that are coming as we push the envelope with these platforms. Okay, next is a second example, which is a high-performance 5G radio access network. And the basic idea here is start with a conventional system that's common today, add more processing, centralize so that joint processing can be enabled. And we want a big, powerful computer. And this can increase capacity by a lot, even with the same radio sites being used. And also, I should add, it doesn't change necessarily the phones or the standards. Of course, evolution can come there too, and that's a good thing, but it's not necessarily required on day one. You can introduce benefits without having to change the phones. And that's even with the same locations and sites. You can go beyond with more gains can be had by adding more radios. And again, as I mentioned, if you try this in a conventional system, the gains will saturate. So this is kind of a depiction. Again, this is a scenario from like a sports venue or a dense deployment where there might be a distributed antenna system and a certain number of sites. We're able to replace those sites with the same locations, but a joint radio, and realize 6 to 12 times capacity gain. That's a comparison with the same amount of spectrum, the same amount of radios, and the same antennas and the same total power. So it's normalized in that regard. But that's not the end. If more processing power is available, you can add even more sites, which would have done you nothing in the first case, but now the capacity and performance continues to grow, and this is how we feel we can meet these new demands for these services. This is an architecture, just kind of a diagram of how a system would look. The part in the middle, the so-called BBU or DU and CU, is where the joint processing is done. On the right, you have normal devices. It may have a split rendering client if it's an AR/VR device. On the left, you have a core network function. And again, you may have a split rendering server or other form of edge computer. And that's overall system, which we feel is somewhat straightforward, can really provide high performance going forward. And we've done this. It's a great use case for sports venues. In this case, maybe cricket stadiums comes to mind where you have high density and the venue operators want to offer new services, augmented reality and other ideas for that. This is a picture of a deployment that we actually did at the Golden One Center. We deployed it a couple years ago, just before the COVID came, and got very, very high performance, even in just 20 megahertz. We were over 20 bits per second per hertz with an LTE system. There were devices mounted under the seats, and we did that. Okay, now just to summarize, significant performance wireless gains are still possible. There's a long way to go, actually, before we run out. High performance processing enabled by semiconductor advances enables this evolution. More processing not only increases the performance of the network, but also the application. And a combination of very high performance radio technology combined with edge computing can enable next generation applications. Now, we're working on these processors today using today's platforms. We're also doing research and study into future architectures for these modems. I noticed watching Prime Minister Modi's address at the beginning of this conference that he mentioned a large number of designers in India in the semiconductor space. If any of those designers are interested in these topics, please don't hesitate to contact us, because we've got a lot of good work going on. And then finally, the increased demand for wireless performance, particularly in India, It's a great, I mean, it's almost unique to the world situation to drive these kinds of advances. So thank you very much. And in the final couple minutes, I would love to answer any questions that you may have.
Any questions? And final call. Yeah, there's one question.
Yeah, hi. How effective is the solutions with respect to cost, especially if you talk about taking those applications and having it deployed in, say, cricket stadiums like you mentioned?
Well, we think it will be very effective. Of course, the processing cost per unit always goes down, but the cost of spectrum can be very high. And depending on what market you're in, for example, if you look at some of the C-band auctions that took place in the U.S. recently. So the ability to save precious, scarce resource, which is radio spectrum, has great value. And therefore, we think the ultimate benefit here is a more cost-effective solution for an operator. Now, it is true it benefits most in these dense cases initially, but ultimately we feel it's a cost win for the operator.
Yeah. Okay, Mr. Matt Grob, thank you very much for your presentation and answering the query. Thanks a lot for joining us from the physical audience present here and the virtual audience all over the world. Thank you very much, and please take care. Thanks. Bye-bye. Yeah. We now move on to the next session, which is, in fact, it's a combination of virtual as well as physical. We have Mr. Lars Rega, who is joining us on the virtual mode. He's the Executive Vice President and the Chief Technology Officer for NXP Semiconductors. As CTO, he's responsible for the overall technology portfolio of NXP and, of course, focusing on the markets, automotive industry, and so on. Physically, we have Mr. Jitendra Chadda. Kindly come over, sir. The Country Manager, Global Supply Chain at Intel, a thought leader with 2 decades of experience in executive roles across multiple geos like US, India, Mexico, and Canada. Vast experience in developing and driving robust growth of R&D organizations in intensely competitive global markets. So it's a fireside chat on computer on wheels. It's over to you, Mr. Chadda. Yeah. He's already joined. Mr. Lars is already there. Yeah.
Thanks, Shankar. Greetings to everybody in the room here and people who are joining online. I'm really glad to see so many people in the room on Sunday morning. And I'm assuming you are all non-golfers like me. That's why you are here. And actually, I'm also trying to avoid house chores and housework on Sunday morning. So this worked out great. I'm not an expert in this field, but I am here for a reason why I wanted to really moderate this when I was asked to do it. I think one of the moderators, they had some personal emergency, so they couldn't do it. We all have heard about so much evolution, so much innovation happening within the automobile industry, and how the autonomy, the connected cars, the electrification of cars, the safety features that we require in the cars. There are many numbers which say high-end cars would have 20% of bill of materials in next 7 to 8 years, as compared to 4 to 5% few years back. So all of this, I think we all know, we have heard about it. But I have been intrigued over the last couple of years on how is all of this coming together, so much of evolution that has to happen in this space. How is the tech industry trying to manage it? I know a little bit from the Intel side, Nivritti and leaders, keep, telling us, what is happening. But there is a larger industry, which is working on all of this evolution and very fast innovation that is happening in this space. So my, personal goal today was to learn from the leaders. We have Lars here. Thank you, Lars, for doing this session for us. He's an executive vice president and the global CTO of NXP Semiconductors. What I want to do is, personally, I want to learn what is happening at the background and how you guys are dealing with so much of innovation, so much of evolution, so much of complexity. And I'm here to then also listen to the other industry leaders. Nivritti will be talking after this session, and we have a panel discussion. And over the last couple of days, I tried to prod few of the people who were joining this conference to ask them, what would you like to hear? What should I ask Lars? And I was pleasantly surprised that they had the similar question I had in my mind on how is this all working out from behind. So Lars, what we want from you today is actually a one-on-one session for beginners on what is happening in the automobile and the tech industry, semiconductor, how is it all coming together, okay? So I have few questions that, I have been thinking and wanted to ask and get clarification on. We'll start with that, and I may pose few questions to the audience too, okay? So the first one, give us your view of what do you think of future of automobiles and the cars? And I want to know from technologists like you, what is the major difference between designing and manufacturing for an auto grade versus a normal, a chip design that we do, right? So give us your overall perspective and what are the differences so that I understand, more clearly here.
So, JC, ladies and gentlemen, namaste, big thanks for having me here and good morning to all of you. JC, like you, I'm also a non-golfer, but a car enthusiast. So Sunday morning is not a bad time to chat about smart automotive innovation. Hey, maybe the biggest change that we're gonna see in the automotive world will be that we have more diversity by our means of transportation. And like in a lot of areas on our planet, diversity is a pretty prominent topic. And what I mean with that is the following. Some years ago, we had suddenly discussions, will passenger cars go away or privately owned passenger cars, because everyone is going to go car sharing, everyone is going to go leasing transportation services. Will that be the new future of automotive, and will private people do not care for cars anymore? I guess that will not happen. But what we're going to see is we're going to see a wild mixture, a growing mixture in the overall portfolio. So for long distance driving, for quite a while, we will still have combustion engine, very efficient combustion engine cars and trucks. For the mega cities, we will have a lot of pollution-free e-mobility. We will have different form factors. In the countryside, you very likely will have privately owned vehicles, at least for a big amount of time. And in the big cities where parking is the issue, but getting services is not the issue, car sharing, transport sharing will happen. So what we will see spreading around the world is a big portfolio of different services. And what we can do, of course, in our electronic sector is we can help drive this innovation. Because in automotive already today, 95% of all innovation is not done by mechanics anymore, but by electronics. So in other words, having smart electronic systems will move the needle. And from an automotive chip design perspective, of course, this all means if you want to build such a smart, connected, rolling robot, you need to make sure that these devices are trustworthy systems. And you were pointing to what does trustworthy mean? Well, in my language, it means they are not hackable. So you cannot abuse them if you want to hack them from the web. And they never, ever fail. And if they fail, they detect it, that they are not feeling well, so to say, and they start either to repair themselves or they go into a fail-safe state. So prominent example is, of course, your braking system ICs. You have to build redundancy into the system. You have to understand the overall system. If your front left wheel sends you strange signals from your wheel speed sensors, the other three sensors are there of the other three wheels as a redundancy. And you can balance this. So if you have a clever system understanding, you can take all of that into account when designing your chip. And then, of course, what you do is you typically qualify these chips a little bit differently than your consumer chips, where a mobile phone has to stand, let's say, 0 degrees centigrade to 50, 60 degrees at the end user side. A vehicle need to start at minus 40 degrees centigrade, winter in Finland, or as you have it in India at the moment, 50 degrees centigrade, very, very high high temperatures outside as well. So cars have a different mission profile. The electronics has in the qualification a very different mission profile, and that's it basically. But it's no magic. It's just hard engineering work, which is good for us.
Thanks, Lars. And also, there is a lot of talk about evolution of vehicle architectures for future automobiles. What does that exactly mean, and how does that play a big role in overall semiconductors for the automobiles is concerned?
Well, that's a good one, Jesse. So let's look at a modern car, or maybe a middle or upper class car. I mean, the second heaviest device next to the engine in such a traditional car is the wiring harness. So the wiring harness is as heavy as you or I am. Kilometers of wires, ultra complex devices, hundreds, between 100, 150 electronic control units that all need to somehow work with each other. So this is such a spaghetti in the network. If you would build this in just a traditional way, like we have built cars 15 years ago, you would never come to an end. You would never be able to reliably qualify such a rolling machine. And therefore, it would be a huge calorie spend for the car makers to bring such a device into volume production. Or on the other side, if you don't achieve your quality, it would be dangerous to have such a thing on the road. So in other words, what the car industry needs to do is we need to structure the way how we build vehicles in a different way. Or in other words, we need to cut the job of how we build a vehicle into different pieces. We call it domains. And therefore, a car, for example, has in my language 5 domains. It is connectivity to the outside world, separated from everything else. It is autonomous driving, not influenced by the other domains. It is the body and chassis electronics, so light, climate control, access control. Then what you have is you have, of course, the powertrain and the powertrain dynamics. The combustion engine or the battery-driven engine has to be driven. You have your ESP and ABS systems, and you have the driver infotainment. So 5 domains, they are all separate from each other, and they are connected via one big network router, like in your home. We call it the automotive gateway. And this is basically a highly safe, highly secure data pumping device. So what you have is, you have this structure of 5 different areas and one central area, and now you can start qualifying these sub areas. You can start say, okay, I did an update on the connectivity, but I do not need to re-qualify the autonomy part. I did an update on the powertrain section. I do not need to re-qualify the infotainment part. So there is a very new architecture, a domain-based architecture. In future, maybe for cost reasons, even the next evolution of this domain-based architecture, we call it zonal architecture. But by and large, the black magic of building modern rolling robots is compartmentalize into domains, substructure, and then only take care for those sub areas. That is the key point, and that is nevertheless quite a big architectural task for the car builders, and of course for us hardware, software guys, because you need to make sure that you are really clean in your architecture.
Yeah, so Lars, what you explained, I was just thinking that means you'll have to work very, very close with, you just can't do all this work, just in your shop. You have to work very closely with the automobile, companies, because they have to architect according to what you are building, or vice versa. So how does that relationship, at least I can ask you from the Europe perspective, how are you building those relationships in Europe? And any guidance you may have for the audience sitting here in the room and worldwide also on what India should be doing as far as those relationships are concerned?
So, JC, so very, very good question. What you had maybe 15 years ago, there was a very, very strict value chain hierarchy. So we, as chip makers, tier 2, were talking to the tier 1s, the box makers. The box makers were talking to the car makers, the OEMs, and there was no crosstalk between the different levels of the value chain. What we see today is this strict value chain is breaking up. I would call it a value network. And this is breaking up because the car makers have understood, hey, if we are only waiting for the tier 1s to come to us and we do not know what the tier 2s are doing, so what the semi guys, what the electronic guys have in their kitchen brewing already, what they develop, then we are too late. And it's like in private partnering. You do not want to wait to marry the best partner when all the rest is set. So what they are doing is they start dating, in brackets, us early. So we have a lot of cross discussions. Maybe you can call it a value network rather than a value chain in the meantime, where suddenly the OEMs are reaching out to us semi guys and say, hey, Lars, what is it that you are having as next generation chips or systems or visions in your kitchen? And we are playing, of course, tier 1s included, but in that network, so we shape little innovation value chains much earlier than the volume manufacturing, much earlier than the real awarding of contracts of the procurement side. But look, for example, at ultra wideband technology in car access. We were working on the mobile phone side with the guys to have ultra wideband in the mobile phones, and with the car OEMs to have ultra wideband in the cars. And now what you can do is, for the most modern cars, you can take away your car key, and your mobile phone does not only act as your wallet. So years ago, we took your wallet, stuffed it into a mobile phone, called it mobile payment. And now I take the key ring out of your pocket, stuff it into the mobile phone, and you can also access your vehicle, your front door of your house, your environment. And that is, of course, the magic of this ecosystem works, but you need the end customers for that. So the set makers, the car set makers, the OEMs, or the mobile phone set makers. And that is a big time changing. And my recommendation to the Indian ecosystem, of course, is this is a very fast-paced, fast-learning system with a lot of great innovators towards the set making. Look at companies like Bhavish Agarwal's Ola, for example. Highly innovative e-scooters, a lot of electronics in there, a smart rolling device, two-wheeler, not four-wheeler. But this is, of course, exactly one of those devices where electronics innovation and device making are getting very, very close to each other. And I've only mentioned now Ola, but there is, of course, many others as well in the same ecosystem. So I guess the same applies for the Indian ecosystem, much more even than for the European, because you are moving in a shorter, faster of time.
Okay, great. Thanks. So, that brings me to, as you were talking about, coming together of the innovations in the device and the semiconductor, there is a lot of talk we also hear about the importance of compound semiconductor because of electrification. How do you want to manage the power, sources? So can you give us a little bit insight into how that is going to either grow or will be different from what we are, seeing today as far as semiconductors in the car goes?
Yeah, so I mean, of course, with the new battery electric systems, there is a additional huge hunger for semiconductors in the cars. And what we are doing in the meantime, for example, NXP is supplying the advanced battery management electronics to Volkswagen, Audi, and Porsche, so for their electric fleets. And what you're seeing there is that we are supplying systems where hundreds of battery cells are in a vehicle, and each battery cell is optimally and individually, very precisely managed by our chips. Why? Because you can only deplete your single battery cell to a certain minimum, otherwise you would be damaging. But you also cannot overcharge your single battery cells because otherwise you could set these devices on fire. Now, if you are depleting only where the most empty cell is already depleted, and then you stop for all cells, you are leaving a lot of electrons unused in the battery. If you only charge until the fullest cell is full and you stop with charging every cell, you are not charging to the optimal amount of the 100 other battery cells. So in other words, there is a lot of precision measurement, functional safety electronics, and very individual cell balancing and cell measurement required to have an optimal battery. And just to give you a rule of thumb, 1 millivolt measurement inaccuracy on such a car is 1 marathon running distance for that vehicle, so 40, 50 kilometers. And that, of course, is a pretty strong topic because driving range is the key issue in modern electric vehicles. You wanna extend your driving range, of course, as possible. So from all of that, there is a very important new class of precision analog electronics entering the game. And the funny thing is, these precision analog chips are typically produced in technologies between 60 and 130 nanometer technologies. While the entire world is talking in our chip area of modern technologies are below 10 nanometers, this is only true for purely digital technologies. So on that analog side, world class happens between 60 and 130 nanometers. So we need to be very clear on what we talk about when we talk nanometers of transistors.
Okay. Lars, there's a question coming in. I'm seeing here. Can I ask you a personal question? Is that okay?
Yeah, sure. Absolutely.
Yeah? Okay. So, it is about you must be driving. You are a driver for, must be driving cars for a long time. So as a driver and then as a CTO, what are you most excited about the future of automobiles and the semiconductors going in the automobiles, right? And the people were asking with some of, I think this has come from NXP, because somebody knows you, much better. So your elder one must be already maybe driving or learning to drive.
Yes,
and
yes.
And their younger one must be getting ready, right? So what, as a CTO, what do you see? What do you want to build for them? And what are you excited and also very concerned about where this is going? So if you can elaborate on that.
So I very honestly, JC, I'm more upbeat than concerned. So of course, what I like to do is, I'm really a car guy since 25 years. I was in navigation system development, car connectivity development. So I have been quite a while sort of a mover between the semiconductor and automotive world. And so I like driving. I like test driving a lot. That's my personal hobby, of course. But what I don't like everyone here, is I don't like standing in traffic jams. I don't like just sitting behind the wheel by not being active. So driving when it's fun is okay, but the real fun is for commute to work, for the daily drive, if you don't have to drive yourself. So advanced driver assistance systems, highway pilot systems that are existing today. So systems where you have computers and compute units helping you, avoiding mistakes, fighting against fatigue, taking the boredom out of the driver task, and taking the task off my shoulders when I don't want to have it. That's the most exciting part that I see, and that is relevant for me because I'm getting an old guy now. So I want to, of course, keep my mobility, my capability to drive also up when I'm old, when my private personal sensors, my eyes, my ears, my hands don't work that well anymore. Also under stressful conditions, I want to drive. So also there, the advancement of assistance systems is great. And of course, also, let's say for my teenagers, the same thing happened. And what we need for that, by the way, is we need to have very cleverly designed systems. So it is not only about AI and machine learning systems in driver assistance systems. Some of us always think a car is a brain on wheels. This is nonsense. A car is as much a brain on wheels as you are a brain on shoes, right? I mean, there is a lot of sensing systems. There is a lot of data management systems around that. And in that brain, you have a mix of deterministic systems and AI systems. AI systems are for the creative part. The deterministic systems are like for my teenagers, the rules that they have to learn how to behave in traffic. And these deterministic systems are watching that you're driving on the right side of the lane, that you're not driving diagonally across crossroads, that you're not using the walkway for driving, that you are stopping in front of a red traffic light. All of these type of things. They are strict deterministic rules. Funny it gets when you stop behind a car and the system needs to find out whether you are stopping because you are at the end of a traffic jam or whether just a car is parking in front of you on the road. In case of you are at the end of the traffic jam, how do you get out of this situation? Well, overtaking and try to get around the car in front of you is a very, very bad idea if you are just the end of the traffic jam. But standing behind a parking car for the next 2 hours is equally bad. So you need to find that out. For that, you need AI systems. And for the rest, you need a mix of AI, so detection systems, and deterministic systems. And that is for techies like me, I mean, that's fantastic. I mean, that brings so many opportunities in building the right failure-free sensors, in building the right microcontroller, microprocessor units for the vehicle, and in building the right actuators. So in other words, we are deeply diving, me and the generations following me, into how we build the smartest robots. And
great.
In the automotive case, how we build the smartest robots on wheels.
Great, thanks, Lars. What I'll do is I'll open up if audience has any question. We'll open up. I have few more that have come just now on WhatsApp. People have sent, but I will open up in the audience. Only a couple of questions, and then we will come back to a few questions I have here.
Hello,
yeah,
sir. My name is Murli. We're working in the space of enabling cycling, rails, not much of cars because India needs more of public transport. In the US, there is a company called Parallax System, which has actually automated the entire rail things. Are you aware of it? Like fully kind of like we are talking about autonomous cars. It's more of autonomous railways. So if India has to go, right, currently we have a huge rail network, right? So I feel there's a huge potential like Bangalore city. If we had put autonomous instead of buses, right? I just book a ticket, say I want to go from here instead of metro, right? Get into the rail, right? Which is autonomous with bogies, separate bogies, not one engine driving around 10 bogies. If we, because India needs those kind of systems, right? So any ideas on the Parallax systems if you're aware?
Yeah, thanks for the question. I think for all the different form factors, from railway to transport on roads, cars and trucks, to two-wheelers, there is a lot of commonalities that you see. On the one side is of course the electric propulsion that is going into the actuator side. So a lot of electricity driving trains, driving vehicles, but also driving two-wheelers, bicycles, and the scooters. And what you see is, of course, what you were pointing to is you want, of course, ideally to be able to move freely between these systems. So getting your tickets, getting your devices. In my opinion, you will use your private piece of electronics, your mobile phone, your smartwatch. For example, what we are working on with NXP is on ultra wideband to have easy access, easy ticketing, seamless ticketing between the different services, and different access to, for example, even car sharing fleets or scooter sharing fleets as well. So for municipalities, what I see is that we as innovators, we have to remove barriers for you in the end from getting from the Bangalore airport to our Bangalore offices. I take the NXP case. For me, of course, it is very, very key that I leave the airport, and as a foreigner, I don't need to find out now how Bangalore transportation works, but ideally, I just have my mobile phone with my mobile payment options in my pocket, and they work also seamlessly without me touching anything maybe via ultra wideband when I walk into a train, when I walk into a cab, when I take a car myself, or when I take a scooter or e-bike. So for all of these things, ideally the state sets the regulations to an extent that it does not prescribe the detailed technology, but politicians can very nicely prepare this, because it does not help if Noida has a different system than Bangalore, than Pune, than Chennai. So that is a benefit that countries like India have at the moment. You have one central government. Look at Europe. We have 27 member states and then the districts, where this is all very, very difficult to harmonize. But my vision for countries like India is going strongly into these hybrid mobility concepts. And there, we from the electronic side, payment side, security side, can big time help. I mean, it's for us, it would be a fantastic market. For the end users, it would be a very seamless experience. But I think this is very, very exciting in the years to come.
Thanks,
So
Lars.
my-
I'll take
my
one
question-
more question from
Yeah.
the audience, and then we have 3-4 minutes left. Yes, go ahead.
So I think you know that there are multiple microcontrollers used inside the car today. What efforts are ongoing to reduce that? And in future, I see that there will be a lot of electronic waste created. So what is automotive ecosystem thinking to tackle that issue?
Well, so you're absolutely right. So today, an average car has in the range of 1,000 silicon chips on average, yeah, and that depends very much on whether you have a Tata Nano or a 7 Series BMW. There is an enormous scale in difference in that. So I'm only giving you average numbers. What I see is that a lot of the data management will get up integrated in central main hubs, so to say. Maybe not one central brain of the vehicle, but several, we call it the zonal aggregators. What I do not believe is that the overall amount of chips is going down, because what you're seeing, for example, you're building a radar sensor system, a radar cocoon around your vehicle. You have a lot of small radar units around your car, and each of them has the radar transmission reception side and the microcontroller in. And from there send, but it's a comparatively small control unit, and from there, via a good network, sends the main data to the main brain for further computation and further merging with the camera systems and the LiDAR systems. So what you're going to see is, you see the high performance compute being aggregated, while the amount of ECUs and sensing systems at the periphery is not going down. So you are fully right. I mean, that is, of course, a big challenge in building these systems in a trustworthy way. So on the one side, how can they not be attacked by hackers? On the other side, how do you make sure that they are redundant enough, robust enough, that they don't fail? And for that, yeah, it's also there again, it's great field of innovation, great market for semiconductor companies. But we see actively the architecture changing. You have things like time-sensitive Ethernet networks entering the vehicle. You have a lot of redundant electronics as well, or system build. How these devices get into this domain and zonal architectures. So a complete overhaul of the setup of how cars are built compared to 10 years ago, and for us, of course, a lot of new products that we need to develop for these markets, and then a very, very attractive segment.
Thanks, Lars. You know what? The last session, guys, gave us to start exactly on time, and I want to respect the next session to start on time too. So what we will do is we will conclude here. And I know there are a few more questions here, but there are a lot of the smart people, the experts who would be speaking today. So a lot of those questions, beyond Lars, we can get addressed. Nivriti is coming next. There is another panel discussion that is going to happen. So I'll conclude here. But for the panelists that are coming after this, one question is left, and Lars, maybe we don't have time here. But what do you want from India tech ecosystem? All the people who are working very, very hard to bring the innovations and evolve this to really become a reality. The semiconductors in the cars, in the wheels. for the future. So what do you want from India ecosystem, from the government, from the startups here, the industry, the universities, right? I think that is one question I think we will try to address with the other leaders who are coming on board here, right?
JC, give me 20 seconds on that one. So what I want is, India is a super hungry ecosystem. And even each time I'm in India, I'm super upbeat how much the people want to contribute and learn and how fast-paced also the university ecosystem is. So come and play with the tech opportunities. That is the key door opener. And what I can only say, I mean, there might be a lot of additional questions. Sanjay Gupta, our country manager, is in my team. Address him, use your India specialists to play with these opportunities. Yeah, I'm very much looking forward to a very, very strong, very innovative Indian ecosystem to help us globally, driving innovation forward. And big thanks for having me for this opportunity. I wish you.
Thanks, Lars. And you have the commitment from the industry here to help out in any ways we can. So with that, we will conclude so that next session can start on time. Thank you. Thank you very much, everyone, and happy driving with Semiconductors.
Thank you very much, Ms. Lars Reger and Mr. Jitendra Chadha. And thanks, Mr. Lars, for joining us. So with this, we come to the end of the session one. And now we move on to the next important session, the semiconductors for the next-gen mobility solutions. We have with us Mr. Nivruti Rai, the country head of Intel India and vice president of Intel Foundry Services. Ladies and gentlemen, let's welcome her at Intel Corporation, and she's based in Bengaluru. She provides overall engineering and business unit leadership and leads operations for the site, driving innovation, cross-group efficiencies and execution for engineering teams, delivering global products and roadmaps. Hearty welcome to you, ma'am, and let's give a round of applause to Nivruti Rai.
Good morning, everyone. JC was mentioning that his session was hard. Think about me. The first day, you already got inspired by some amazing speakers. The day two, you heard a lot about technology, and I was very excited that I saw Lars's presentation, a lot of information on technology. So what am I left with? A time slot right before lunch. So mine is the hardest, but you're already inspired. You know the technology. Let me talk about some action. What can we do? I completely agree with Lars. We are a nation who's hungry to do more. We are a nation who is not complacent at all. We are ready to go, full speed. Time is now. Very recently, I was in Munich. And I was meeting a lot of world's leading auto manufacturers. And I must share this one statement that one leading, he's an industry stalwart. I don't want to take his name, but this is what he said. He said, I know you guys will succeed in your automotive mission and vision because you know how to work with others. Unlike some countries who live in a walled garden approach. My data, my technology, my manufacturing, my. We are not my, and therefore I'm very excited, and I have a call to action for all of you. So you heard about semiconductors. You heard it's very important. Today, semiconductors are $600 billion industry. In 2030, is going to be $1 trillion. What excites me more about semiconductors is what does semiconductor enable? It enables better access to health. It enables access to, villages to get access to the world market, economics. It's enabling education. It took us a very hard COVID experience to realize many of that, but suddenly everybody knows that semiconductor is exciting. None of the world's software can run in the air. It needs the basis of semiconductor and a platform and a system. And I'm very excited that our country, our government is putting so much push behind driving this industry. I will talk a little bit about, importance of end-to-end ecosystem. You cannot just think about a certain building block. Semiconductor by itself is just, okay, it's pituitary gland for the whole body, but it needs the arms, it needs the head, everything. So I'm going to talk about how do we come together as an ecosystem, need of focus. Semiconductor for what? I told you semiconductor for education, semiconductor for health. My goal is, how do I convince you that the sector focus can be automotives? And I'll give you a reason why. I also want to talk about, before me, Lars called about that, computers are the brains inside the car. But I'll tell you, the computers inside the cars are definitely brains, but the brains enables the vision of the car. The brain enables a lot of arms and legs of the car. So I am thinking the car of tomorrow is nothing but like a human being. It can see, it can process, it can move, it can deliver, it can do many things, it can get connected. So what is the car of tomorrow? I'll also talk about the value chain. From the semiconductor all the way to the car, there's many things in between and even below. And how do we do this? What is my call of action to all of you? I want to start with life needs to be thought as a complete equation. When I was growing up, I always thought of input, process, output. A lot has to do with, programming. So you've got to think, what is the input coming in? What are you going to process? And what's the output? The entire semiconductor ecosystem needs to be thought like that. In the business sense, you think supply and demand. So this whole ecosystem, on the left side is the silicon ecosystem, and on the right side is the manufacturing. You can think of one, but you have to think of the other as well in tandem to create value. You'll start building semiconductors. Where does it go? You build a semiconductor, you have a packaging, it needs to go into a system. So therefore, think of it as a whole. Let's talk about a little bit on the left side. India today has a lot of building blocks and components that go onto the left side. For example, I have taken the liberty to put crosses against the one where we don't have a lot of presence. Question marks are the ones where we are growing, and pluses or tick marks where we are very strong. And so clearly design services. I think India powers the design services for the world. We have the leading design services. Can we design for ourselves, for the world, is what we are going to be working on. Fabless design houses. There was a time, was very sad we didn't, but now we are building. Can we have a company which is very large, fabless design house based out of India? Can we have, something like a Qualcomm India, like Qualcomm in India, and many such things. EDA vendors, we are having many of them. Once all of these inputs are coming together, they go into fabrication of a chip. Once the chip is fabricated, it is packaged. Once it is packaged, it goes and sits on the board. Once it sits on the board, that goes into some box. For example, one engine control unit inside a car. Finally, that engine control unit goes inside a car, which is an OEM. That is the entire ecosystem that we have to think. And the policy today is doing exactly that. We have to look at how do we come together end to end. Now, there are many components over here where you see a big cross. We don't have, the companies like ASML in India or, local. So what? Not everything should be, or could be built out of India. Some things we may choose not to. Those we will import. Now, for importing, we will be needing help for, a lot of import policies, etc. But remember the German comment that I shared with you? If one country can come together and do it, it's India. And we do believe we will leverage our partnership, we will leverage the value that we create to bring together different countries to enable us build this entire semiconductor ecosystem end to end. Remember that unless you have a demand to be able to sell, no matter what you supply, there will be, a gap. Once you have a local supply and demand, you can build the supplies to meet the needs of the world. Today, the world makes 80 million cars a year, 80 million, out of which about 25 million is made by China, about 10 by Japan and US. India makes 4.5 to 4 million cars for the world, which is 5%. Therein lies an opportunity. 5 million cars mostly meet our needs, but can we make for the world? That's the opportunity we like to address. The second thing, if you look at 1,000 people, in US, 800 people own cars. In Israel, 400 people own cars. In China, 200 people own cars. In India, 40. There is another set of opportunity. Now, the world is telling us we may not own. We may be getting access to different business means. With a lot of the gig economy that you talked about or heard in the past, we can enable every single Indian to get access to cars. That's an opportunity. That is what we want to address by bringing together all of us. I'm going to go to the next slide. So now we've decided that let's have a sectoral focus. The sectoral focus, so read from the right to the left. So sectoral focus could be, automotive, telecom, cloud services, defense. Many of these, could be designed by Indian chip companies. What is the silicon that goes into some of these sectors? So let's look at, I'm going to talk about maybe a couple. Let me talk about telecom and networking. Telecom and networking needs 5G and 4G equipments, and the silicon chips that could go into it could be very large server-like chips. That could be part of the infrastructure, enabling cores, enabling, radio access networks, and could be smaller as well, which could be sitting inside your phones. So the chip requirements spans a lot of these different needs. Let's look at automotives. Bulk of the automotive is leveraging, 50 to 100 engine control units, ECUs. Each ECU has, 1 to 10 silicon components in it. So you can think of, on an average, like Lars said, 1,000 silicon components sitting in an average car. I will tell you one quote by Pat Gelsinger, who's my CEO. He said, today's automobiles have 4% of bill of materials that's coming from semiconductors. By 2030, 20% of the bill of materials is going to be semiconductors. Therein lies the opportunity for India. Not only do we have our desire to have every single person have access to cars, but the product needs are tremendous. Semiconductor is 600 billion today, going to 1 trillion. Cars will have 20% of their BOM coming from semiconductors. So he said, automotive industry is coming so close to Intel. So we have to get prepared. And I really feel that as India, with our strengths, we can focus on one of these sectors that, I called out. Automotives, I personally believe, for many reasons, I'll call out why I think automotive is going to be really, really critical for us to focus on. So know that the OEM translates into the needs. For example, for automotives could be ADAS. In India, I think autonomous driving will be initially limited for fleets. We could have, fixed lanes and highways and the fleets carrying goods. Eventually, I'm definitely going to dream one day, but not in the next 10, 20 years. I don't see autonomous driving, but I do see ADAS. And I do see what is called collision avoidance systems, which will save the deaths that happen on the road. Today, India sees 17 deaths per hour. How can we use the brain of the car, the arms of the car to maneuver away? a young person to die due to road accident. I'll tell you another very sad statistic, but don't look at it as sadness, look at it as an opportunity. India has 1 to 2% cars of the world, but 11% accidents and death. That's the opportunity. We have to save our people with the brains inside the cars, and technology is ready. I want to tell you, before I share my punchline here, I want to tell you, any innovation cannot be driven by a single technology. There is something called convergence of technology. I'm standing here as Intel, how can I not mention Moore's Law? And yesterday, Windham, who's the hero and architect for Intel, he and I were talking that Moore's Law is not really a law. It's like an inspiration. It's like a motivation. And we live up to that motivation. Whether it's through scaling of transistors that you heard Raja talk about, whether it's improving the performance of the transistor, or coming up with technologies which are engineering technology, less of physics, for example, packaging, disaggregation and packaging. We've already looked at scaling of our transistors. We're also looking at quantum. Can I change my transistor into a qubit and get the performance and meet the expectation Gordon Moore had from us? So Moore's Law is saying 50% per year the transistors is growing. Not only the transistors, which come together to make the brain of the car or any device. Second thing, storage. Every, I would say, year and a half, storage means what is the cost per bit for saving is going down by 50%. Digital imaging, cost per pixel is going down by 50% per year. Transmission is going down by 50 to 60% in 9 months. Lastly, lithium-ion battery. I can tell you, over the last 5 years, the cost of lithium-ion battery has gone down by 80 to 90%. Technology is in our favor. It's for us to come together, think the end-to-end ecosystem. Everybody has a role to play, whether you are a STEM graduate or whether you are a business graduate. Give me a work model that will create value with the automotives. I also want to tell you, a question was asked on 5G. 5G is going to become a revenue generator with the belief is something around 85 billion by 2030, only when we come up with exciting use cases. Same with AD/ADAS. You know how much the world is spending by 2030 on EV and batteries? It is $500 billion, $500 billion going towards EV and battery. Now, how do we generate value? Every car, there's about 250 million cars by 2030. That means R&D cost for every car is $2,000. Now, where are you entrepreneurs to create value such that we can generate, the justification of spending this $500 billion? Now, all these technologies coming together, I shared, all of these opportunities in each person having access to a car. Only 5% of the world's car. We have amazing technology. If our cars can run in Marthahalli, they can run anywhere. So our cars are strong. Our cars see much more. So all of that gives me the belief, in Intel, when you go through a validation, you have a test strategy called mother of all tests. So if mother of all tests is called out for cars, it's going to be Marthahalli and Bangalore in India, and we can then build a car for the world. That's why I believe we have opportunity, we have technology, we have a need. We have to save our people. And thinking and summing all of that together, I truly believe India should aspire to be world's leader in automotive, semiconductor, and electronics, and we have the hunger, we have the capability, and Automotives is not behind like many of the industries. What I loved about, Jam Trinity, it redefined the world. With Jandhan, Aadhaar, and mobile, how many unicorns have we made? We have our guava vendor leveraging digital wallet. I mean, that's the kind of passion I have in automotives. So I believe this is one area that we already have a lead ahead. We can continue to grow not just for India, but for the world. So now when I've talked about my pitch on why I believe this is the sector for semiconductor that we need to focus, I want to talk about what are some of the trends. You heard, a lot of need for EV. Why? EV has 2.5 times more life than ICE-based cars. Overall, for the lifetime, 10x more cost-effective. And it's going to be much simpler. Supply chain is a complex subject. I sometimes shudder, how the supply chain guys manage. ICE cars have 2,000 plus moving parts, the gears, the whirring, and the shirring, and all of the movement that happens. EV will have 20 plus parts only. Imagine the ability to manage such cars. So therefore, 10x lower running cost, 2.5 times more life. That is what EV will offer us. Then comes AD ADAS. I intentionally did not put AD for passenger cars. AD, I believe, is going to be for commercial vehicles and dedicated use cases. Rail was an amazing infrastructure that you called out. So ADAS. The other thing is architecture. Lars called out, some question was asked. I don't know, was it Shivraj? The car has, 1,000 plus semiconductor components. Some are MCUs, some are CPUs, some are GPUs, memory, you name it, all kinds. The analysis that we have done shows us it's not going to reduce the number of semiconductor components, but it's going to make the life easier for supply chain owners. Why? 100 unique MCUs can be translated into 4 to 5. So rather than have, 6 different vendors design 100 different types of MCUs, we can simplify. Not only that, we can aggregate. Also, can a higher compute take care of many tasks and reduce? Look at what Tesla has done. It's actually software defined. They are able to upgrade features through software. Life is easier. So a lot of architectural changes. Wires gives me headache when I look at, the kind of wires there are in a car. It's a mess. I want to see wires in the car going like how I see interconnects in my semiconductor. You see that logo, how nice straight lines we have per metal layer. That's the kind of wiring we want to see and simplify such that wires can become 20% of the automotive weight, if not kept in control. So architecture changes are important. And enabling open compute, which means Mahindra can have its recipe for differentiation versus the Tata can have its, and a Mercedes can have its. So open compute enables you the ability to create differentiation and add your secret specific sauce. I already talked about supply chain. Connectivity is also very, very, very important. If you look at Merriam-Webster dictionary, it says a car or a vehicle is a transportation mode from point A to point B. We've already defeated the meaning because our cars are not just, transportation modes. When I'm stuck in my, again, Martha, I sometimes hear music. Sometimes I call my parents. Sometimes if I have, a nice rental car, I even get a back massage. So cars are no longer modes. They're already like a spa for you. They're already like, a music system for you. I don't know what many industries will get disrupted with the cars of tomorrow, with the kind of connectivity and services we are planning. The 500 billion that are being invested for EV needs to be recuperated at least 10x more by creating services which these technologies will give you. I will share some example for the entrepreneurs out here. You must look at what are those services that can generate the value. And I truly believe India is synonymous to software. If anybody can drive services that we have imagined and all of you imagine, we can do it out of India for the world. Connectivity 5G, you all know. You know, whether we talk about beamforming, whether we talk about massive MIMO, these are complex technologies created for 5G because 5G, one, doesn't penetrate, you know, it gets disturbed by cement, even trees. So you need something called small cells. 5G needs beamforming because it needs to have all of the information come together into a single beam because it's being distracted and moved around from all over the place. What can cars do? Nature of ownership. I really loved two visionary statements. One was, you know, from, if some of you remember, the Deccan Airlines. It had a very aspirational goal that it wanted to fly every single Indian. Similarly, I like US defense. They say no soldier left behind. With our technology coming together, can we give access to every single Indian the benefit of a car? That's the kind of goal that we should have, such that it makes just life a little bit better for people. So whether, you know, it's the gig economy like the Ubers and Olas, what more can you imagine? Car, like I said, no longer is just point A to point B. It's already doing so many more things for you. So what can we do with some of these technologies? Compute, I already told you, Moore's law, and I already told you, you know, digital imaging, I told you transmission. I want to tell you, AI alone can add $13 trillion to the world economy. 13. I also want to talk about 5G. I know 5G use cases are still developing, but I'll tell you, 5G has an opportunity to create 85 billion plus for the world by 2030. So, if these technologies are available in your automotive along with smart compute, what can we do? Vehicle as a service, you know. So, think of e-commerce, think of, you know, cold chain, a lot of transportation required, hazardous material. My CEO just had a meeting with the Prime Minister, and Prime Minister made one statement. He said, you know, in Himachal, in the northern areas, there's so much potatoes, amazing, most delicious, but they get rotten and they get wasted. Can a drone bring them down to the plains and make them, you know, the villages get the ability to recuperate the money that they've invested? So automotives can be used as a service beyond just transporting people and in many areas. Second thing, this one really excites me, and I am looking at how to make it happen because it needs to be working with telecom service provider. Now, you know that there are two towers for 5G. Each tower has what is called massive MIMO, multiple input, multiple outputs. But between these two towers, which is a lot of investment, there needs to be small cells. These are smaller cells that enable your call to not drop when you're going from point A to point B, such that, you know, this kind of handshaking happens. I was in Munich, and I thought, you know, in Munich, and all of it is a city, Germany is a small country, that my calls won't drop. But I was having a tough time because from one tower to the other, calls were dropping. And I'm thinking, there are like tremendous number of cars all around me. Can each car be a small cell that, you know, we can support each other, not just use it for our benefit, but the compute inside a car can be a small cell. Then insurance. I told you the car is not just the brain. It has the arms and legs and it has the eyes. So much data about the car, about the driver, about the environment. Can we leverage it? For example, insurance, cars insurance, a driver rating, how the driver rides, and many such things. Data in a manner that is shareable. And of course, you know, when you come up with the problem, you have a solution. There are ways of sharing data without the identity without actually giving the data, but the juice of the data. It's called federated learning. Then services-based. Today, that Google Maps, then there is Waze. Can we leverage the information the car sees such that we can create a dynamic route planning, emergency services? Your car is stuck. Lars was saying that, that's the most boring part. But all cars are connected. Is there a car which actually is a coffee place and, deliver you coffee because you're stuck? So not only your house can be your Airbnb, but your car can be a little restaurant with neighboring cars. I mean, the services are endless. Truck platooning. So that this, again, is a defense example. There is a truck which drives, and there are like many trucks behind. Can we think of a concept to, which is one is the lead and the others are followers, and save emission, reduce traffic, for one lane for children's school, which only follows the platooning kind of concept. So this is my list. I really think that there are many, many more things. The entrepreneurs out there, there can be amazing services could be generated out of all of the compute and all of the technology sitting inside our car. So before I go to the next one, I think time is now to call within the IoT, Internet of Things, to think about Internet of Vehicles. Imagine in India, okay, there are about 1% or 1 to 2% of the world's cars, but a lot of cars running around. It's like a galaxy. What can we do? What can we learn? There's so much data this car has within and outside and between. So I really believe time is now for Internet of Vehicles. I want to call out this automotive ecosystem. This is a very busy slide. The whole point to show you is we've translated the ecosystem into different segments: design and fab, manufacturing, feature and application, and user and demand for automotives. And in the bottom are some of the companies that are driving. So in design and fab, you need all kinds of compute elements, memory and connectivity, analog, some cutting edge, some trailing edge technology nodes, and what are the companies doing, work in there. If you start looking at systems value chain, I'll tell you, software will play such an amazing role in this market segment. But I have a list of companies that we have actually worked, some of the companies with, who can create a significant systems value chain. And the reason I have these companies is because I have a call out for all of you. Then we have component value chain, more of like, what Lars was calling tier one. OEM is a car manufacturer. Tier one is the one that builds boxes. Oftentimes we'll call it ECU or, chassis, etc. Then tier one are the lower building blocks. So if you look at this, this is a tier one. We have quite a few tier ones based out of India. And then you look at the end users. Can we come together and drive this ecosystem to create value, not just for India, but for the world? How can we move forward? The government has put down some amazing initiatives. Can we look at coming together? This thing, remember the German comment that I made? If any country can do it, it's India, because they know how to work together. Having said that, sometimes I get scared because history made us follow the divide and rule concept. So can we come together, see this opportunity, not just money, economics and finances, but the need of saving our people? Come together, beat the history, believe what, the largest democracy of the world houses hundreds of language, hundreds of religion. We still live together beautifully. Can we come together and drive this? The government is already, has been an enabler for us. What can we do together? I think time is where academia, industry, and entrepreneurs need to come together. We need to have the supply demand. We need to have the input process output. So time is now. Time is for us. We have to make it. I'm going to end with my urge. Let's make a new trinity. jam enabled better lives for our people. This new trinity, I'm calling it ACE, which is a function of AI, connectivity, and EV. Let's drive this trinity, not just for the people of India, but for humanity and the world. Thank you very much, guys. Okay. I think I ran over, so only one question, please. And I will be out here, so you can ask me.
Madam, namaste, Murli. I've been working in the space of sustainable transport last one decade almost. So to begin with, actually, we are trying to promote active mobility, public transport, because we feel cars are not so efficient for cities in Bangalore, right? For example, to give a big instance, when Raju Chandrasekhar ji was the chairman of Abide, he introduced Big 10 buses in Bangalore, which was a great revolution, right? The Big 10 buses ran on from Electronic City to the center of the city, Marathali, right? So that reduced the connectivity to these Electronic City offices. It reduced the demand of cars by 20%, right? So from that consistent policy, Government of India has brought in this urban transport policy, wherein the focus is to make our bus system smarter, right? So I think if you see the big blunder the Bangalore city did, okay, it ignored the BMTC totally. There's no intelligence. So I feel, because we are trying to see how we can make BMTC more stronger, because they are not getting funding from the government, and there is not much motivation, right? So this, if I say AI, connectivity, and EV for public transport system, I think it's a huge opportunity for not just India, for the entire Asia, because entire Asian cities are congested because of we drove this culture of cars, right? So this is amazing, AI, connectivity, and EV, but I feel it should be focused on buses, and we have not thought about railways, right? Railways are learning like what the British did, right?
I'm with you.
Yeah. So
I definitely want to do something in railways, but this focus was automotives. So, but I completely agree with you. I want to give you just one quick example. You know, I'm going to give you an example of Wipro and Intel. Wipro has 400 plus shuttles. Intel has several, tens of shuttles that going around, for our people. If we leverage this ACE, we will be able, EV could be a second step. Like India missed credit card. We went from our actual wallet to digital wallet. Let's miss out hybrid and go straight to EV. But we will save significant amount of time with these shuttles all coordinated, taking the right route and enabling people to come. It will just make things so much better for people. But thank you very much. I'll answer more.
Yeah. Last question. I was standing from that.
Oh, so sorry.
Very quickly, please.
Yeah. See, 150,000 people die every year in accidents. That's like 50 people an hour and four people every minute. We are continuing with the design of the automobile invented 100 years ago.
Yes.
It's time to disrupt this design. So I was just thinking how we could do it. Now what we are trying to do here is apply the technologies with the existing design of the automobile. Can we leverage the technologies that we have in AI, robotics, airbags, and other safety features to really rethink the car? So what idea I just had offhand was like we have 4 cocoons which are flexibly coupled together inside the chassis, and which is like you're talking about human brain. So our brain is like a jelly floating inside in the water. That's why it doesn't hit the skull very easily unless it's a very high impact. So the same way we have a viscous jelly which prevents those cocoons from impact. And instead of airbags, if we go in the vertical direction, if there is an impact, suddenly there is a parachute which just takes all the 4 cocoons. And if we make a 100% foolproof, safe car which can eliminate death to 0, I think that will be the disruptive innovation of the next century.
I actually agree. We can have offline discussion, but if technology can save lives, that's the best use of technology. Otherwise, technology is just good for patents. It has to translate. And I believe that we can build a car with the goal of 0 deaths. Thank you very much.
Thank you, ma'am. Yeah. And as she has said that she's available offline for some more time, so some of the questions can be addressed to her later when she's around, and you can ask the questions directly to her. Well, ladies and gentlemen, we have now come to the final session prior to the lunch break, and this is a panel discussion on smart mobility. We have the moderator for this session, Mr. Vinay Shenoy. Mr. Vinay Shenoy, the Managing Director at Infineon Technologies India. Now, this particular panel discussion also is a combination of virtual and physical mode. Mr. Vinay Shenoy has over 20 years of knowledge semiconductors, consumer wiring and telecommunications industries. He has worked in several roles with Texas Instruments, Philips Electronics and Sem India. So I would request Mr. Vinay Shenoy to kindly come over. Ladies and gentlemen, put your hands together for Vinay Shenoy. I would quickly read out the name of the other panelists with their companies which they represent. Importantly, we have Sri Lyre Selton from Mobilia Intel, who is going to join us on the virtual mode. We have Mr. Sanjay Gupta, NXP Semiconductors, also from the virtual mode. Mr. Uday Dodla from Qualcomm. I would request Mr. Uday to kindly come over. Yeah, he's here. Welcome to you, sir. And also we have Vivek Singhal from Texas Instruments, who is here. Mr. Vivek. Yeah. And finally, we have Mr. Amit Jain from Minda, who is going to join us from virtually. So I would, the dignitaries have joined us on the virtual mode. I would request Mr. Vinay Shenoy to take us through. It's over to you, Mr. Vinay.
Thank you. I just hope that in the next 55 minutes, we make that time worthwhile rather than giving you that extra hour in the morning to sleep on a Sunday morning or going for a stroll in this beautiful Cubbon Park. But we'll try to make it exciting, light-hearted. And we have two virtual participants. Unfortunately, I can see them now, joining us online. But before we get into smart mobility in particular, what I would like to do is to set the broader context of the smart city in which smart mobility is a part, broadly speaking. And at what's driven smart cities globally all over the world. One, with respect to urbanization, population increases, upwardly economically affordable families, traffic has become a nightmare. I mean, I just loved the way it was 2.5 years ago, although for the wrong reasons. Hardly any traffic on the street. But now we are back. And Rajiv Ji was speaking about, in his inaugural, how familiar Bangalore looks now. Now, what's traffic congestion leading to? One, like Nivriti said, fatalities that we need to avoid. And where do the fatalities come from? Because of traffic congestion to a great extent, anger management is always a challenge for us. There you're sitting in traffic, you're late. I think the most commonly used excuse in our industry, at least IT industry, is, sorry, I'm late, but don't blame me, it's the traffic. Though you may be at home still, not yet in traffic. But this is one part. And second, look at the productivity losses that we have, stuck in traffic for an hour and a half, 2 hours, whether you're sitting in a Wipro bus or an Intel bus, or you're driving your own car, it doesn't really matter. You are stuck in traffic for an hour and a half, fatigue by the time you reach office, or fatigue by the time you reach home, and an ideal foundation for arguments at home. So, the conventional thought with respect to addressing traffic congestion is very linear. Broaden the roads. Add yet another layer of roads. But all that you're managing to do is to create an induced demand for more people to buy cars, and which eventually will lead to more traffic congestion. So that's where smart mobility comes in. It's a new, not say new anymore, but radical, revolutionary approach to managing mobility, one that focuses on efficiency, for example, like I said, second on safety, and 3, convenience. Now, the end goals are, of course, it could be 0 emissions, 0 accidents, or even 0 ownership. The first of these, in my view, is the transition to net zero transportation, primarily EV. But today, EV is still not net zero because the source of the power generation that charges your cars is still not renewable in nature. And then that is a transition that we will achieve not very far from now. On efficiency, today when you get into a car at home, your destination is still your car. Now, smart mobility also explores different ways where you can use multimodal transport. Bounce is an example where the last mile connectivity is from a nearest metro station. You can just take a bike so that you don't have to be stuck in traffic, you don't have to find parking spaces, etc. And then, of course, this new realm of opportunities that conventional semiconductor companies or automotive companies, if I may use the word, have not dealt with yet. And this is ride sharing, ride hailing, e-scooters. I don't know how many of you see these, dangerous looking kick scooters, as we call it, right? You start with the kick, or, hover boards or hover scooters. Again, you use the footpaths or the curbs to move around. Again, a new technology. Autonomous vehicles, of course, will come a little later. Subways, street cars, you name it. There are plenty of modes that are evolving today. End of the day, this whole smart mobility aims to offer an end-to-end platform/solution for people to find convenience way, empowered ways to move around. So, coming back to the scope of this panel discussion, technology is a driving factor, for sure. It's not just about ways of living or ways of commuting. Smart mobility essentially requires core technologies such as the ability to gather data through multimodal sensors, whether it's in your vehicle or on the infrastructure, being able to analyze, make sense of the data, and then, of course, finally, to be able to integrate drivers, vehicles, and infrastructures to provide the best smart mobility solutions. And, of course, semiconductors plays a very pivotal role in all of this technology. So we have a very interesting panel here, and let me make a quick introduction. We have Lior Sethon from Mobileye, a darling startup, I think a couple of years ago, continues to be a darling startup, being acquired by Intel for 15 billion, and are now here. Probably the valuations will hit 50 billion when you go public. Nothing like it. Second, Sanjay, again, a colleague from the industry, from NXP, Infineon, as well as NXP and TI included, have been delivering automotive solutions to the market for over 2 to 3 decades. So, but we could also say we are transitioning into the new world of automotive from the old world. We have Uday from Qualcomm. Again, new entrant, I would say, though you may disagree, but in our terminology, 2 to 3 decades is normal. Where you bring in communication, which is so critical to enable smart mobility, autonomous driving, or any other value-added services, which we call as mobility services. So I think you're right in the midst there, probably making more money than all of us put together. And then you have Vivek, also familiar face when we go to customers, sitting in the lobby area, trying to sell the same products or similar products to the customers. And Kashyap, are you on? Did Kashyap join? Okay, Amit. Sorry, Medha. A long-term player in locomotives, electrification of drives, and now also venturing into electric drivetrain for commercial vehicles and heavy vehicles. Kind of a tier 1 for the locomotive industry, or even OEM for heavy commercial vehicles. And the last, we have a Indian tier 1 serving the automotive OEMs, Minda. Yeah, from Minda, I'm sorry. Very interesting panel, and we'll have probably about 30-35 minutes before I launch over to you guys to ask questions to this interesting panel, and I'll make it a little tougher on them too. So let's begin with the Lior. The smart mobility is a nice keyword. It's like AI. I studied AI in 1991, but that was only in books. Before it became a reality, probably it took us another 2.5, 3 decades, because the basic technology available to launch AI applications was not available. So where would you stay is smart mobility at this point in time? You need plenty of infrastructure technologies, communication, sensors, power, road infrastructure, curbside infrastructure, in-vehicle infrastructure. So where are we today with respect to smart mobility? Is it still a buzzword whose time has not come yet? Or are we ready and getting there very soon? Lior, question to you. And of course, the others of you can also jump in because it's a generic question.
So I hope you hear me. You hear me well?
Yes, we can hear you.
Okay, so first of all, thank you for having me here. My pleasure to be here. Best regards from Jerusalem, Israel, to everybody. So coming back to your question, the reality is already here. The fact that you have software with very strong chips and compute power in the vehicle and AI technology already embedded or can be retrofitted on vehicles brings a lot of new opportunities. And the reality, as you started to mention about smart mobility and sensors that are providing real-time or almost in real-time information, it's there. We are there. If I can add a few words about Mobileye, we are the world leaders in avoiding collision technology, which is based in the last 20 years on vision sensing, machine learning, and usage of AI. In the last years, we are also one of the leaders in putting autonomous vehicles on the road, which is a very complicated and task that involved a lot of complicated challenges when it comes to software and hardware and regulations and algorithms from all kinds and redundancy of sensors for safety. But we are coming from vision sensing. So also today our ADAS system, including in India, are able to extract a lot of data and give and provide information not only for the autonomous vehicles, also to decision maker, road planners, public transportation authorities, infrastructure companies, and road operators, about the traffic situation, about obstacles on the road, about the infrastructure status, such as position of new potholes on the road, position of traffic signs, and their status, position of poles of all kinds, and a lot of information. We are today extracting something like 30 different type of object in real time. And of course, the technology is, we have started to implement that in the last years, but we are developing and changing the technology all the time. And we have also the ability to update the sensors, the moving sensors that we have on the vehicle constantly. So we are uploading in a lot of new information and also to adopt the software to the geolocation landscape. I mean, when you drive in the roads of Munich, or you drive in the roads of Tel Aviv, or you drive in the roads of Bangalore, it's not the same infrastructure that you see there. And we can understand all of them and to do localization of the road understanding and the traffic understanding constantly.
Thank you. Though I would like to, Lior, challenge you to get your Mobileye technology on this famous ring road we call in Bangalore, which houses probably 100,000 IT engineers, including Intel. It would be nice to see you drive past Intel autonomously, and we look forward to that sometime very soon. Coming back to Qualcomm, because again, disruptive. What infrastructure, I mean, you guys are working on a large part of the infrastructure besides more. Where do you see as Qualcomm the basic infrastructure getting ready for smart mobility, autonomous, electrification, you name it. It's all V2V communications, V2 infrastructure, infrastructure to V.
Thanks, Vinay, and good afternoon, everyone. Thanks for having us at the show. Well, Vinay called us new kids on the block. It's been 20 years since we've been in automotive. 2002, just a little historical fact, was when Qualcomm launched its first telematics solution for GM's General Motors OnStar system using CDMA. So 20 years is a long time for us to hone the skill and be in this industry. And ever since then, we've continued investing, bringing new technologies to life, such as cockpits, cockpit domain controllers, ADAS very recently. But specifically for smart mobility, 3 years ago, we launched our CV2X platforms, cellular V2X. And that has evolved, and I'll talk a little bit about that. Now, stepping back, for Qualcomm, smart mobility encompasses both the vehicle and the infrastructure. Smart and connected vehicles are the key to smart mobility. They come first. They create broad adoption and then pull the infrastructure along. They act as a catalyst. Vehicles nowadays, and those that launch going forward, are inherently intelligent in nature. Like the previous speakers have said, they have a lot of AI, they have a lot of ADAS systems, domain controllers, which are very, very powerful, are capable of making split-second decisions. And they are the ones that will essentially start pulling and acting as a catalyst for smart infrastructure. Now, smart infrastructure, on the other hand, is, I'd say, a little bit more challenging. It requires a lot of interventions, especially at the city, state, and the national level. The technology is there. It's alive, it's real, it's working. But the adoption of that and rollout has been lagging in the industry. In fact, it's a billion-dollar question. So instead of addressing it at a wholesale level, if we start implementing this in bite-sized chunks, we can actually see smart mobility come to life. And that's where the key is. Qualcomm has conducted several trials, real-world trials in San Diego, Denver, Atlanta. Japan has had its own smart mobility system for several years now. Europe is rolling out smart mobility solutions. But I believe in India, we will see this come to life in the very near future. We are working with almost all the major OEMs to bring the CV2X, specifically CV2X, to life. So we don't think it's that far away. It just takes a little bit of conviction on everyone's part to make this a possibility.
The next question, Amit, to you and also Sanjay. Traditionally, we are a hardware-oriented industry, automotive in particular, whether you're in tier 1 or even as a tier 2 or semicon company. We have been in the business of making semiconductors or integrating them into another hardware solution. Now, increasingly in smart mobility, you begin to see software and services playing a very, very prominent role going forward. And probably semiconductors will dwarf in comparison with the revenue and the value of services that are on top of the semiconductor solutions. So how are companies like yours transitioning? How do you look at this? Although in a semicon company, of course, we still have a significant number of software into our semiconductors, but I think the scale of software and services is on a magnitude probably 100x going into the future. So how are semiconductor companies and traditional automotive companies responding to this transition? And what do you see as major challenges? Question to Amit. Sorry, Amit, I missed you when I introduced the virtual participants. And Sanjay, either of you can take this question or both.
Sure. You want to go first, Sanjay?
Sure. Let me take a dive on that first, and then I will hand over to you. So, good afternoon, everyone. I had to come back to Delhi last night because of some personal reasons, but I had wonderful first 2 days. So a great conference and a great thought leadership. Kudos goes to all the organizers for such a wonderful show together. To come back to your question, I think that as our previous speakers said, we are in an era where it is literally computers on wheel. That is going to drive the future mobility. Now the wheels could be flying wheels like a drone, or it could be a wheels for a car, right? We keep talking about 75 billion plus devices, connected devices. That is going to be the future in next few years. And all these devices are going to be the symbol and the signal for this smart mobile world that we are all trying to conceive and innovate. So in this world, needless to say that hardware and software go hand in hand. What cannot be done in a hardware has to be done in software, especially when you talk about cars as an example. With a 10 to 15 years of lifetime, you can't expect to take the car back to the garage and take the entire hardware change to incorporate the latest and greatest features which are coming in. So truly, like a mobile phone, we have these software upgrades that happen without the users need to worry about any compatibility issue or anything to do with the security. I think exactly same is going to happen with the future mobile devices and automobiles, where on-the-air update is going to be the norm, and this is something that all semiconductor companies, including ours, are designing towards. And once you expose your cars to on-the-go updates, one thing that goes without saying is they have to be 100% secure, right? Otherwise, as was signaled in one of the lab-based, benign hackers a few years back, that you can control everything inside your car by getting through the open channels. I think in that specific example, they entered into this GM vehicle via infotainment channel, and then entered into the entire braking system and steering systems, and potentially it can kill someone if somebody wants, right? So that was a wake-up call for the whole industry, that any smart system cannot be a secure and cannot be a future compatible if the security is not there. And that's where a key link remains to make this system seamless mobile. So that's what I would say. I will leave it to Amit for the next response, but we'll discuss more on that.
Yeah, thanks, Sanjay, and thanks, team. So I think from my perspective, I'm going to speak more from an automotive tier one perspective. I come from Minda. Minda is a 65-year-old purely automotive tier one company. We do everything from seat belts and airbags all the way, up to ADAS, infotainment, and electrification, products. For us, smart mobility is synonymous to sustainable mobility. And everything, when we speak of smart mobility, we need to look at how sustainable that is in the long run. In the automotive scenario, the life cycle of developing, car is typically 3 to 4 years, and it needs to be on the road for the next 10 years. So you're looking at making hardware decisions like today for the next 15 years. And speaking about how these technologies are getting integrated in the next set of vehicles and making sure that they remain relevant with either over-the-air updates or making sure that the features for the next generation of smart mobility are more or less like package protected for what's going to come in the future. Yeah. And one of the key issues, again, in these areas when we speak about India as a country is definitely affordability. India's got airbags 25 years after it was mandatory in most parts of the world, something that's so critical to just safety. And we made airbags mandatory, the front airbags mandatory just recently. So there's a lot of affordability, and unless there is a regulatory framework around a lot of these, we believe that adoption of many of these would actually continue to be on paper. So the way we're tackling this, this situation is making sure that we work closely with policymakers, with organizations that set standards and the regulatory framework to more or less ensure that some of these really get embedded into regulation and homologation, and in order to ensure that these things are more or less forced on when we actually design the vehicles rather than an afterthought. And obviously, we also continue to work with other ecosystem and infrastructure companies, because at the end of the day, all this is not going to work unless there's the right infra in place. Yeah, thank you.
Thank you very much. My next question is to Vivek and Lior. The automotive industry, I shouldn't say notorious, but has not been very embracing when it comes to standards. Now, when I look at my car, the only thing that I can buy off the shelf from anywhere is the battery. Even there, my automotive OEM says, you should not use this battery, you should use the one that I recommend. Number two, the tire, not even the rim. Amazing. And three, the horn, right? What else? I can't think of anything else that can be used across cars as a default. Now, it's an industry that has not embraced standards very much across. And now you bring in a new dimension of these mobility services, which are probably another 6-10 layers of software and other technologies on top. And the only way to make smart mobility successful is through standards. So where do you think are the standards heading? I mean, I'm sure, Lior, for mobile eye technology to work, unless you start customizing it for every car, you start customizing it for every street in every city, in every country, I think it's going to be a humongous effort. So I would imagine for you to scale up, you'd also require multitude of standards to be in place so that cars work seamlessly even across Europe, which is not necessarily known to be a very homologous continent. So Vivek, first to you, role of standards in making smart mobility successful and scale, and then Lior, your turn too.
Sure. I'll probably take a little longer to get to this question. Maybe also try to explain this whole question around standards, very important. How is it really complex? It's not just standardization of a communication infrastructure, standardization within vehicle, but it's a much, much, much larger problem, and I think we're just scratching the surface. But before I get there, maybe just to share my view on why smart mobility, what is needed so we can comprehend what is the scale at which we are looking at it. Consider this, it is happening every second. Somewhere, somehow, someone is getting injured in a road crash. Cars are lining up not just at Marathali, across the world, various cities. Traffic is piling up. Ambulances and police vehicles are struggling to make their way through the traffic to reach the spots. And all the cars that are stuck in traffic, drivers sitting in there are getting frustrated. Even worse, by the time I started speaking about it, someone probably lost their life in a road crash. There are countries spending up to 3% of their GDP to tackle costs due to road crashes. We are spending countless hours. If you go by statistics, it's up to 15% of our working hours are being spent stuck in traffic. That's a huge number. And I believe in 2019, the CO2 emissions caused by passenger cars were around 3 billion metric tons, which is around 10% of the global CO2 emission. So clearly, smart mobility, the way I see it, has to make things safer, has to make mobility safer, has to make it cheaper, has to make it faster. We want to commute fast. Has to make it more comfortable. I heard Viviti talk about getting a back massage while stuck in traffic jam. So making it comfortable and absolutely greener. And it's not just vehicles. We also learned that semiconductor content in a vehicle is growing from 5% to 20%. We are finding use cases, we are solving problems which are not standardized. We are still trying to figure out how to solve problems. But it starts from infrastructure. We are talking about smart traffic signals, where we have sensors that can not just detect, it can predict and prevent traffic jams. It can reroute traffic. We are talking about smart parking spaces where you have radar sensors equipped which can find open spaces and guide incoming vehicles to open spaces, probably even pre-book the parking spaces by the time the cars are arriving. With electrification of vehicles, we need smarter infrastructure. Think of the buses. We want electric buses, but then how do we ensure that they always remain charged? So we are talking about bus stops where you are able to have faster and quick charging of EV vehicles, EV buses. So coming back to your point is, I still believe the whole smart mobility paradigm, while there are certain places where we are talking about ADAS systems, which is, I would say, probably still a step ahead. We have a much, much, much larger, broader problem. And the standardization, I would say, is still evolving. And now think about, you have these smart traffic signals, you have smart parking lots, you have smart vehicles, you have smart parking stations. All of this needs to be interconnected through smarter connectivity solutions. And we have to build not just one smart vehicle, we have to build a huge smart ecosystem. So we have standardization at certain individual places, but to me, the biggest challenge would be how do we think of it as a big ecosystem and drive standardization across.
Thank you. Leo?
I think I heard many things. I agree with some of it, not with all of it. Practically, I think I would surprise you. First of all, standardization and working with the policymakers is critical. And I do agree very much that smart mobility, landscape or city or country has to be safer. And I think that the solution that Mobileye provides, which in one end is the ADAS safety system, and I'll give you some numbers that will surprise you, I think. And the other end, collect data that can be generated for other purposes, but first and foremost, to analyze the safety on the road. This is something that can be done. It's a very straightforward solution to an issue that you just raised. Our technology is already on over 100 million vehicles worldwide, and it works under very strict standards. If it's the European standards or the American standards or Japanese standards. And also in India, together with Intel, we are now doing a very deep dive in the Intel industry, in the Indian industry. And one thing that I would like to surprise you with is that we don't need to change all the vehicles to have those smart sensors. For example, the Mobileye solution can be retrofitted in every existing vehicle almost in India today. And to have safer vehicles, safer drives, statistically, by the way, worldwide, this will reduce accident significantly. Sometimes it comes to 40–50% reduction in accident. If it's commercial vehicles, for sure, public transportation, also passenger vehicles. And those systems working very closely with the government under standards can do a big difference, and at the same time to send data to the benefit of the industry, the cities, and the road operators. We already started to do that especially in the last 1.5 years in India, and we see outstanding results with the fleets, commercial fleets, that have started to adopt this technology. We did, together with Intel India, we have localized our solution in the sense of, not of the sense of how to prevent the accident, because this is standard, in the sense of how do we look at the data, which needs to be relevant to the driving culture, the local infrastructure. So as I said at the beginning of my words, the solution is in place and can be adopted very, very, very fast, not only on new vehicles, also on existing vehicles.
Okay. Thank you. Now, in all this discussion and also how smart mobility is evolving, technology has been a driver or continues to be a driver. Now, it's very interesting to now step back and say, what has the 2.5 years of COVID and the lockdown, where smart mobility effectively meant no mobility. We were all sitting at home, very few cars on the road. It's a paradigm shift. It's even, perhaps in one way, when someone would see it, it's even smarter than smart mobility because you just avoid moving around, but while you are as productive, those that come from the semicon industry, we had our best 2 years of revenue and profitability for the last 15, 20 years, sitting at home. And we were not even able to deliver components to our auto industries, but still very profitable and growing very well. But that's not a paradigm that we're looking at as smart mobility, because I think this complementary technology, which is called the digitalization of the world, starts to intervene into what you would constitute as mobility. You're virtually mobile, if I may use the word. Businesses are being done virtually. And this is all a complementing technology. As you see, we are in a hybrid mode of panel discussion, which I think 4 or 5 years ago was unheard of. Either you're absent or if you are physically present for a panel discussion. Now, it's an equal representation, but from a panel perspective, we have more panel members virtual than physical. Do you see this trend also affecting this paradigm called smart mobility? Any one of you can take it. It doesn't have to represent your company, but it can also be your personal opinion.
I'll go first. You're right, Vinay. When there's been no mobility, we've seen the biggest transformative changes happening to our industry. The most intelligent of vehicles have launched, be it the Tata Safaris or the Harriers with all the ADAS systems, or the Mahindra XUV, which has a totally digital cockpit. All this was done. The design development was done when everyone was sitting at home, right, with COVID. In the two-wheeler space, the most disruptive of technologies have come to bear. Yes, everyone's spoken about the Ola Electric S1. There've been plenty of other technologies that have come into play, ride sharing through Bounce. So all this has happened despite COVID. Essentially, I'd say in spite of it. So the bottom line to us is that industry is rapidly changing. It's not going to wait for disruptions like this, and it's changing at a pace that is unprecedented than in the past. I believe our industry is, especially the silicon industry, has stepped up from a technology perspective. Of course, there's supply chain that we all have to worry about. Luckily, there are no auto OEMs here. Otherwise, they'd be throwing tomatoes at us, for not keeping up with the demand. But I feel that at least for the next decade, even earlier, there'll be unprecedented change in the smart mobility space. Now, we're only talking about vehicles. On the infrastructure side, more has to be done, and we all collectively look to the government, the ministries here, there's road transport, etc., for them to come collectively together, for the industry and the policymakers to come together to jointly act as a catalyst for smart mobility to really take off, and not leave this as an island for the industry to kind of figure out on its own, like what you said, right? Vehicles are pretty much very closed systems. Outside of a few moving parts, you can't really change much. We don't want smart mobility to be like that. We want it to be a very collaborative effort. And I believe the industry is ready for that.
Okay. Anyone else who would like to take this question on any mid-course adjustments that you had to make or your company's management has had to incorporate in view of the learnings from COVID? Of course, we have had a lot of other learnings related to COVID, but purely with respect to mobility. Any comments from any of you?
So I would share my thoughts on that, Vinay. So first of all, COVID actually accelerated the entire digitization. That otherwise would have happened over a decade. Probably it happened in a couple of years. I think we all saw that. And some of the key learnings from a technology standpoint that clearly come is, this whole mobility concept, going back to the theme of security. Right? You may have the world's best high performance products. You may have the fastest, device connectivity, but if they're not secure, trust me, we all sitting at home will not be comfortable either dialing into our bank accounts or doing online payments or doing a lot of virtual stuff, which is enabled today because we know that while we do that, there is absolutely low chance of getting things hacked. So a special emphasis on secure solutions, whether it is a credit card transaction that were really got through the roof with this UPI and other digital payments. NFC, by the way, is another key technology that made it possible with the NFC and secure elements are enabling almost 90% plus of credit card transactions today in India. If you add the same theme to standardization, security to a different level, which is like more of a safety or a functional safety if you talk about human aspect, is another key area of focus. We were talking about standardization earlier. I think that we have a lot to learn from mobile industry, which is kind of a couple of decades ahead of us in many ways. There were days when you had multiple standards of mobile communication, not only GSM and CDMA, but within that 1900 or 1800 megahertz, 900 megahertz. And soon we converged as a world so that once we are traveling as an international traveler, we don't need to worry about changing our mobile phone SIMs or anything like that today. Today on the electric side, I just want to mention that we have a big challenge that we are dealing with the government. There are a lot of standardization bodies about the whole charging thing. We may talk about the best electric vehicles, but today we know that we have a Japanese standards, Sharimo standard. We have a Tesla as an independent standard. We're talking about Bharat standard. What are the ways and avenues for Indian consumers as well as Indian OEMs? Which standard we will align to? For 1 billion plus Indians, if they want to go with the two-wheelers, what is the most cost-effective charger they need to carry with the two-wheelers? Every part of the world. There are a lot of unsolved problems, but I think they're all opportunities for us. So the seamless mobility will pave the way for innovation. There's no doubt about that. But a lot of work needs to be done on ground level to make it a reality.
Thank you very much. I think we have some time for audience to ask any questions. So if you can arrange a mic. So please wait for the mic. If you have any questions, raise your hand. We go ladies first, Jaya.
Thank you. So Vinay, you ask a very beautiful and much needed question that in this smart mobility, there is a need of standardization. And Vivek answered, extending to that, there is a need for ecosystem to, because we're talking about infrastructure, the vehicles talking to each other, right? The question is, we do have a need of a community who start thinking this standardization, start thinking this ecosystem, and start laying down the use cases and make that happen in future. So do you think there is already a community or consortium being made to talk about those standards and make them a reality in future?
Well, if you ask me for my personal opinion, each region is in the process of developing its standards. Like you mentioned, Japan, EU, US, and maybe Korea, China. Is that adequate? Will that serve the purpose? Do we always have to have a global standard? Perhaps not, as long as they're regional standards and you have the ability to adapt to a certain standard. I think we have served the purpose. The big question is take electrification of the drivetrain itself. The battery technology, battery swapping, battery charging, you name it, unless you have a standard at least nationally, scaling up is always difficult. Otherwise, Ather will have to install its own chargers, next to it Ola, and then X, Y, Z, you name it. And then this is a waste of infrastructure, and it's a lot more expensive, because of which the consumer in the end will end up paying more because of this redundant infrastructure that you create. And this has to be solved, but I'm hoping it's also well known in the industry. But historically, we have not been a standards-driven industry as automotive. I have to acknowledge it, but I'm sure we are getting there. And government plays a very important part in it. It may not be able to set the standards itself, but definitely try to at least stimulate, steer, mandate standards before mass-scale adoption can take place. Any one other comment before we move to the next question?
Maybe I can add to it. So I was talking about, while we look at standards, let's have a macroscopic view first. But then if you go down, so we have safety standards in place. We have emission standards coming in. If you talk about communication, we have standards across how devices need to communicate. To my earlier point, the need is how do these different sectors, how do these different minds come together and then think through. It is the standardization we'll not be able to work on in isolation. If government or each of these technology companies think of in isolation, we'll not be able to come up with it. The intent here is how do we come together, understand this, and try to solve this problem. And that is where actually we'll also realize places where we need standardization. That was the intent.
Thank you. Vivek, you had a question.
The only thing I would add there, this Amit, is that I think there is already a very good framework of how we set standards in the automotive space. Under the Ministry of Road Transport, I mean, there is already, a set committees. There is AIS committee, the CMVR. They all set standards today. And the kind of speed that I have seen, at least, or the momentum that I have seen in the last 2 years, has been possibly 4 times or 10 times more than what I have seen in the last decade, right? So yes, there is, there's more motion, there's more momentum in the way standards around all the things that we've spoken about, right? From smart cities all the way up to ADAS systems, they're all there. They're all under the process of formulation or under, on the draft perspective. And there's a lot of people from the industry who are a part to those, those standard formations. Is it fast enough? Maybe not. It can be faster, but we also at the same time we need to ensure that we take everybody along, all the ecosystem players along. So it's very important that when the standards are formed, that everybody's voice is heard, and hence it takes a little bit of time. But yes, speed will definitely help.
Thank you very much. Vivek, your question.
Yeah, Vinay, my question is more about the processing or computing trends for the automotive for the future. So because of the increase in features and functionality, we have seen number of ECUs going maybe 50 to 100 or even more depending on type of the car. While it's good for semiconductor industry as well, but it adds to the complexity in the design, wiring harness, weight, etc. On the other hand, if you look at the central computer features like dashboard, connectivity, etc., the processing need there is continue to be increasing. So my question is there a possibility going forward that there's a very large multi-core processor sitting in the central processor, and like we do in server and data center, you can carve out virtual machines and you can get rid of 50 or 100 ECUs and simplify the wiring harness and the entire architecture of the processing for the car? Question open to anybody from the panel.
Go ahead.
I can take that. You're right. There's, excuse me. A very distributed processing has clearly showing the trend of moving towards a central domain controller in vehicles. So, sorry about that. And that trend is forcing the central domain computer or controller to be more powerful, more monolithic, because it can handle pretty much all the tasks without relying on other ECUs. So we're clearly seeing that trend. It also alleviates supply problems in a way, right? You essentially rely on one SoC to provide all of this, as opposed to 10 or 20 other ECUs, smaller ECUs. Now, it also represents a single point of failure. So the key is to make sure that there's enough functional safety built in, enough redundancy built in to ensure that the central domain controller can handle that task that, say, a distributed setup could, before. So yes, clearly that's the trend we are seeing. The OEMs are favoring that as opposed to a very distributed architecture.
So if I may add to that,
maybe someone else can jump in. Sanjay, you have a point to make?
Yeah, I just want to add to that. Vivek has a very valid question. And historically, since automotive grown from a mechanical industry pretty much into electronic, based driving systems, analogically, the hundreds of chips were looking like a very old historical city in Delhi or a Chandni Chowk, right, where everything is clustered without any planning. And the way we are moving ahead, completely agree with the previous comment. It is going into more of a domain-based controller, so that neither we are going, very centralized structure as a single point of failure, neither we are, completely randomly distributed. So the different domains with a like-minded ecosystem, for example, a dashboard and infotainment kind of a, domain is a domain which might require a different kind of voltage and, even the temperature-related qualification requirement versus something which is a core power domain or a braking domain with a very high temperature requirement, and even the SL functionality, whether it is a SLD or a SLA, based on the criticality and the life-saving kind of requirements, those kind of features will differ. So there are 5 domain controllers typically where we can divide the whole automotive architecture into, and they are all governed by a central gateway. So that is the way the industry is more or less heading at this point in time.
Thank you. Your perspective on this existing decentralized computing, which is an evolution from the past, where every feature began to get, let's say, electronically controlled, whether it's the ABS or airbags, to now probably we have reached a disruptive stage where processing starts to take precedence over control. How do you see the trend of as Mobileye of how computation is done within the car, or significant amount of processing is done within the car, but perhaps maybe a large part of it also shifts outside the car because of low latency, high speed networks? Why should computing happen in the car? It could also happen outside. And so how do you see it, Lior, now and going forward?
Yeah, so first of all, I think most of the compute and the decision-making process of any action, if it's in ADAS or autonomous vehicle, will be, as I see it, that and the way that Mobileye moves forward will be done in the vehicle. But on top of that, and we can see that in the future regulation in Europe or the UN, there will be some complementary information for safety and redundancy in data that will be processed in the cloud and will be integrated with what the sensors are viewing and detecting. So, for example, there is a new regulation that's supposed to start in several years that it calls intelligent speed assist. It means that on top of what your sensors are detecting, you have to have an updated map on that is being processed in the cloud that complete information from the sensor with a clear standard of how much of the speed limit indications should be accurate and detected. So what you see is the fact that you have more and more intelligent vehicles that can send information and the information can be more up to date. Also, the regulators are pushing the industry to use both options, or both disciplines in the vehicle to take the decisions, but to complete the information in places that the information is missing from the sensors from the cloud. And this is the future of, if you like, as far as I see it, of ADAS. For sure, autonomous vehicles, it's another layer for safety for the autonomous vehicle. And if you ask me, it's very much makes sense since the world is full already with the car floating data and sensors like ours that are extracting a lot of data. And the data, and not like in before, is up to date and very relevant to driving. So it means practically that vehicles that have driven this morning in Bangalore can update or updating the maps that can be sent to the vehicle that will drive there in the afternoon.
Thank you. Two more questions stand between us and lunch. So for those who are going to answer the questions, you know the pressure on you. Yeah.
Sorry. So I'll be quick, but I think talking of standardization, I think we have some major issue, by the way, in India. And since I've been into this for the last 1 decade, although I've been a hardcore design engineer. So in charging infrastructure, so yes, automotive evolved as an independent siloed ecosystem, and they developed their individual set of standards, which are fine till recently. When we talk about EVs, now we have multiple other interplay with a lot of other ecosystem. First is the smart grid, okay, and the other is smart cities and all that. Now, how do we bring in a homogeneous framework for standardization? And in India, when we were, there's a committee in Bureau of Indian Standards on EV charging infrastructure, ETD 51. Anybody may look up that. So there we were trying to do the harmonization of the charging infrastructure. One of the first problems that came, globally we have 3 ecosystems. One is the CCS in Europe, in Japan, CHAdeMO, and then we have China, this is GBT. Our Bharat charger, which was initially developed, had a GBT connector. We tried to harmonize with one connector for India as a big ecosystem, but you know, standardization political game. Nobody would let us do that, and they made sure we cannot come up with this thing. But the problem with India is the connector is such an expensive thing, the way it comes from Europe and Japan and all that. And the cable, now, you know, as of today, what we have still the 3 different kind of this thing. Anybody can put this thing, charging infrastructure or charging station with any of the connector. We don't know what car will come there. So and those charging cables and connector are pretty expensive for Indian ecosystem. I think we need a holistic system level thinking about standardization when we look at this interplay across domains. So what is your take going forward on, so we are trying to do a lot of things, but battery swapping is another thing. And how do we share data seamlessly from the battery to the, you know, within the vehicle, as well as battery to the charging infrastructure, and that same data goes to the grid, to the city ecosystem? I don't know.
Yeah, we don't have an, I would ask the panel members to not dare to attempt an answer. Yeah.
I like that.
But it's an ongoing process. Any standardization initiative in technology or elsewhere brings with it vested interest of individual companies, Absolutely. Individual consortia to push their agenda into it, and that is what slows down the whole standardization process. Now, but I hope that the larger industry, for its own success, will not play a spoil sport in the adoption of electric drivetrain, because we are going to be left behind and we are not serving a larger cause, while maybe the rest of the countries might move into electric drivetrain much faster, even if it becomes, from a total cost of ownership perspective, a lot more attractive than a gasoline-based engine.
Absolutely.
And if you're not on the international roadmap for electric vehicles, you just get left out, just like the hybrids that we talked about, right? India never embraced hybrids in the first place. So we were either gasoline, and now we bootstrap into electric. And my only wish is amongst the various stakeholders of which we are a part to, maybe a lesser part as Semiconductor, that there is a united front towards standardization, because only when that forms can we really hope to scale up this industry. Otherwise, it's a loss for most of us anyway.
Absolutely. I only want to touch one point for this ecosystem that we have here is that there's a lot of interoperability required from the electronics parts, electronic blocks that we use in the car with the electronic blocks outside our electric vehicles. So I think our ecosystem can be cognizant of those kind of things and work toward harmonized interoperability, application layer, data models. Those would be some of the good starters from this ecosystem to expect.
Thank you. Thank you for that comment. But I don't know if I can take the second question anymore because, so let's conclude. Bala, I'm sorry. I don't want, like I said, to stand between, very good smelling lunch here. But it's evident. Every one of us sees this as a great business opportunity now encompassing a lot larger ecosystem of mobility service providers who probably in the end will drive this whole smart mobility agenda. But until then, and even at that point in time, we will have to be content with heterogeneous systems leading towards homogeneous systems and the government stake, because it's all in the context of smart cities. So the governments have to define their own standards for smart cities before smart mobility can really scale up. Plenty of challenges, government stakeholders, multitude of companies, some with deep pockets, some with shallow pockets, have to address this as in a united way. But until then, all that we can do is to put in our efforts and move in that direction. So thank you very much to everyone on the panel.
One comment, sir, I just want to make.
He wants to make one quick comment for
30
seconds.
30 seconds.
Yeah.
So basically, I was going to say about the same thing because government has spent almost 94 billion till now, smart cities, right? So we need to start off with the ontology, epistemology, and theology. What is the structure? What does smart mobility mean, right? We don't know what the definition is not known. Then what is the theology? What do we want to do it, right? Epistemology of it, right? I mean, do you want to make it safe cities? Do you want to make it less pollution? That we have to define. Then the process on how we will achieve has to be defined. Otherwise, what's happening in the last 10 years, the money is spent. Smart mobility, Kaban Park, they are doing something. Because I'm watching every day what smart mobility, smart cities are being done. Money is totally getting wasted. I think the industry should start putting these words like this is what we mean by smart mobility and coming up with the open innovation things that will take us at least 2 steps ahead. Now we are just discussing this is smart, this smart.
Thank you, but I would contest your statement. I would not agree with it because smart city is not just about smart mobility. It's a lot more. Smart infrastructure, including enabling people to walk. If you can walk, it's good. And you see in Kaban Park, what's being said are the beautiful footpaths that you love walking on. It was scary to walk earlier on footpaths, but you see now this transformation is going on. That's also part of smart city, enabling cycling, walking agenda, not just smart mobility as it comes to technology. So please give it some time. Don't be so pessimistic about government wasting money on smart cities. I think it's a move in the right direction and smart mobility will come. With this, we end this panel discussion. Over to you.
Yeah. Yes, we started this discussion with a walk on the Kaban Park Road and it ended with a walk on the Kaban Road. So then and now, but now we'll have to move for lunch. So let's enjoy our lunch, take a walk and come back at 2 o'clock. Enjoy yourself. Namaskara.
Your smartphone is a computer that's millions of times more powerful, 40,000 times smaller, and 16,000 times less expensive than the first mainframe computer. And there are more than 2.5 billion in use today. How did that happen? Industrial scale. Every year, nearly 30 million wafers are processed for smartphones. Each 300mm wafer contains hundreds of chips, all meeting the same rigorous specifications. Applied's world-leading expertise in materials engineering and building equipment to manufacture chips has made this industrial scale possible. In partnership with our customers, we continue to make chips faster, more energy efficient, and more affordable. Today, our systems touch virtually every chip and display made. Even after more than 50 years of creating new possibilities for our customers to embrace, We're just getting started. The world is moving rapidly into an era of self-driving cars, robotic manufacturing, the Internet of Things, virtual reality, and more. Digital devices are becoming extensions of ourselves, sharpening our vision, deepening our insights, and enriching our experiences. These devices will be powered by a new generation of chips, requiring new materials and new ways to build them. Applied Materials is at the forefront of making this new world possible. Come join us.
Namaskara. My heartiest welcome to all the delegates who are participating in the Semicon 2022. We are extremely happy. Your presence is going to make a huge difference. Probably in the journey of establishing the semiconductor fab and display fab in our country, especially in our state of Karnataka. I, on behalf of our government of Karnataka, we promise you and ensure that your journey of establishing a unit in the area of semiconductor fab, display fab, compound semiconductor, OSAT, ATMP, and design center. You're most welcome. We'll be with you and ensure that nothing comes in your way. We'll give topmost priorities been given for the ease of doing business. And then we'll ensure the very process of establishing the unit will become the most enjoyable journey and most fruitful journey, and it will be very productive. And we'll extend fullest cooperation. I wish once again your stay will become very fruitful, and we look forward to your support and participation in the growth of the state of Karnataka. Already we do have an excellent semiconductor ecosystem in the state of Karnataka. We want to further widen and strengthen and deepen our strength in this area. We look forward to your cooperation. Namaskar.
We at Karnataka Digital Economy Mission welcomes all the delegates of Semicon India 2022 to the semiconductor capital of India, Bangalore, Karnataka.
IBM has produced the world's first 2-nanometer chip. Its tiniest components are smaller than a strand of DNA. Designed and produced by IBM Research at its Semiconductor research facility in Albany, New York, this wafer contains hundreds of chips the size of a fingernail, each with 50 billion 2-nanometer transistors. This technology is designed to help improve calculation speed or boost energy efficiency, depending on the job. Where speedy complex calculations are the goal, IBM's 2-nanometer design is projected to achieve 45% higher performance than today's 7-nanometer chips. Or, if energy efficiency is the priority, they are projected to use 75% less energy than 7-nanometer chips. This breakthrough will help accelerate advancements in areas such as AI, 5G and 6G, edge computing, autonomous systems, and space exploration.
We are experiencing the fastest tech transformation in modern history. As the creators of the technology the world builds on, Intel is innovating faster than ever to solve the world's most significant technology challenges and put that value in the systems, software, and ecosystem solutions you trust every day. Thousands of companies take a faster path to AI at scale using their flexible, Intel-based technology. Our leadership in silicon-based security and confidential computing continues to help you share data with reduced risk. Groundbreaking process and packaging technologies let us build entirely new ways to compute for leaps forward in user experiences and capabilities. And now we can offer that technology to the world through our foundry. Decades of work in open source software continues with our ongoing initiative to maximize code reuse across any hardware, no matter which company builds it. And we're collaborating with industry and government to move the world to a low-carbon economy. Every day, our world-class architects and engineers do something wonderful. So you can too.
Your smartphone is a computer that's millions of times more powerful, 40,000 times smaller, and 16,000 times less expensive than the first.
The unique pattern of innovations in the semiconductor industry continues to elude the perception of Moore's law slowing down, challenging the status quo. RISC-V instruction set architecture is not only witnessing a quantum leap and unprecedented levels of processor innovation owing to its free and open nature, but also pushing the Moore's law beyond its limits. Now, when the Union Cabinet has approved the Semicon India program with an outlay of rupees 76,000 crores to create a vibrant semiconductor ecosystem in the country, the RISC-V processor ecosystem must grow in the country to realize the ambition of self-reliant India in electronics product design sector, thereby taking momentous strides towards Atmanirbhar Bharat. Today, there is a thriving ecosystem of chip designers at academia, scientific societies and startups in the country, contending to gain the market share in RISC-V growing market. While India has certainly taken several early steps in processor design area, the time is fallacious now to advocate India's strides in RISC-V global community and unveil the Digital India RISC-V processor roadmap to the world. India today announces its ambitious roadmap with the Ministry of Electronics and IT planning to join soon the RISC-V International as premier board member to collaborate, contribute and advocate India's expertise with board members, which include other leading organizations like Intel, Google and Western Digital. Digital India RISC-V program for the DIRV is being announced with Professor Kamakoti, Director IIT Madras as Chief Architect and Sri Krishna Kumar Rao as Program Manager. The blueprint of the roadmap of design and implementation of the Digital India RISC-V program is also being unveiled with Shakti Processor by IIT Madras and Vega Processor by CDAC. This 3-year roadmap envisions to develop, siliconize the processors and achieve design wins through an ecosystem of startups and companies to position India on the semiconductor map of the world. To catalyze the semiconductor ecosystem in the country, unveiling the strategic roadmap for India's semiconductor design and innovation. The roadmap outlines the mission statements for achieving the design wins for the DIRV, excellence in skilling and propelling the startup-led ecosystem in the country.
इसकी स्थिति हमें सिखाती है कि इसका मार्ग एक ही है, आत्मनिर्भर भारत।
At Lam Research, we challenge assumptions, defy conventions, and push the boundaries of the semiconductor industry. And we're just getting started. Because as technology gets smaller, we think bigger. We achieve unprecedented collaboration through open communication. We know breakthrough isn't a product. It's a process driven by precision. We don't just speak of the future, we ensure it. It takes recognizing that the right inputs lead to significant outcomes, then delivering time and time again. It means that when we say a smaller, faster, smarter world can exist, consider it proven.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize.
We rethink, we transform. Because today's data doesn't just reside, it lives.
It's the spark that makes you feel alive. Feel alive. Feel alive. Feel alive. Feel alive. Feel alive. It's the spark that makes you feel
Micron is where data lives.
Namaskara. My heartiest welcome to all the delegates who are participating in the Semicon 2022. We are extremely happy your presence is going to make a huge difference. Probably in the journey of establishing the semiconductor fab and display fab in our country, especially in our state of Karnataka. I, on behalf of our government of Karnataka, we promise you and ensure that your journey of establishing a unit in the area of semiconductor fab, display fab, compound semiconductor, OSAT, ATMP, and design center. You're most welcome. We'll be with you and ensure that nothing comes in your way. We'll give topmost priorities being given for the ease of doing business. And then we'll ensure the very process of establishing the unit will become the most enjoyable journey and most fruitful journey, and it will be very productive. And we'll extend fullest cooperation. I wish once again your stay will become very fruitful, and we look forward to your support and participation in the growth of the state of Karnataka. Already we do have an excellent semiconductor ecosystem in the state of Karnataka. We want to further widen and strengthen and deepen our strength in this area. We look forward to your cooperation. Namaskar.
We at Karnataka Digital Economy Mission welcomes all the delegates of Semicon India 2022.
Good afternoon, ladies and gentlemen. I would request all of you to kindly take your seats. We are starting the post-lunch session right away on time. And friends outside, delegates outside also can come in and occupy their seats. So welcome back, ladies and gentlemen. Hope you all enjoyed your lunch. And just to refresh ourselves once again, we'll start the session with a video. And I would request all of you to kindly just sit back and watch the video. Video, please, yeah.
As we rapidly embrace new age technology, semiconductors have become the new building blocks of a smarter world. With the presence of nearly all of the top 25 semiconductor design companies, India is engaging with the brightest minds in the field to create the most innovative skill hub for semiconductors. Blessed with a rich demographic dividend of a young population and a median age of 29 years, India, under Prime Minister Shri Narendra Modi, is emerging as a global skills hub, focusing on nurturing and training the talent pool for its fast-growing talent economy and the world. In the last few years, India has also delivered successful indigenous technology programs of digital payments and digital identity authentication, connected to the lives of over 1 billion people. The quick adoption of high-end technology-based devices and growing consumer demand for electronic devices have seen a surge in the semiconductor demand and innovation, with an outlay of $10 billion to create a robust and sustainable semiconductor and display ecosystem. The government's Semicon India program has also laid a roadmap to develop and train talent. Nearly 2.5% of the total outlay of Semicon India program is allocated to the R&D, skill development and training requirements. Skill development and training is an essential requirement for generating industry-ready manpower specialized in semiconductor and display fabrication facilities. Special manpower development program is being implemented for Silicon to Startup, SMDB S2S at 100 academic institutions to generate 85,000 industry-ready manpower specialized in VLSI, chip, SoC design and manufacturing. The India's Semiconductor Mission's Design-Linked Incentive Scheme, DLI, to support design firms, aims to augment PM Modi's vision of the next decade being India's techade by nurturing 100 domestic semiconductor companies for ICs, chipsets, SoCs, systems and IP cores. It'll facilitate the growth of not less than 20 such companies to achieve a turnover of over INR 1,500 crore in the next 5 years. Partnering with the best and the brightest global semiconductor leaders, India is already on its way to becoming the next global hub for electronic system design and manufacturing.
Indeed, after that video, it's indeed a pleasure to watch the moderator of this session, Professor V. Kamkoti from IIT Madras, walking in. Before Professor Kamkoti comes over, just a brief intro about him. He specializes in the area of computer architecture, information security and design. He heads the microprocessor development program and the information security education and awareness program at IIT Madras, funded by the Ministry of Electronics and Information Technology, Government of India. So ladies and gentlemen, let's give a round of applause and welcome on stage moderator Professor V. Kamkoti. We also have Professor Subhashish Chowdhury, IIT Bombay. Professor Subhashish, one of our panelists. Kindly come over, sir. And we have Shri Anil Sahasrabuddhe, AICT, joining us on the virtual mode. We have Raja Subramaniam of Synopsys, Mr. Raja, kindly come over, sir. We also have Mr. Sambit Sahu from Intel, Mr. Santosh Kumar from Texas Instruments, Mr. Venkatesh Prasad, RVLSI, and also we have Mr. Jun Gu, the General Manager of Memory Business Unit, of course, Semiconductor Manufacturing Comp. Yes, Mr. Jun Gu will join us on the virtual mode. I think both of them have joined. Yes. Good afternoon to all of you. Let's give a round of applause, whoever present here. And also, we would like to welcome all the participants who have joined us on the virtual mode and even the panelists. Welcome to both of you, sirs. And it's now straight away over to Professor Kamkoti to take us through. Over to you, sir.
So very good afternoon. Last day after lunch session. We'll try to keep as exciting as possible. So that's the first challenge, number one. So I always, I want to link this session to, I want to start with an analogy. Suppose we are driving from Chennai to Pondicherry, right? First we see a board, a placard which says Pondicherry 163 kilometers. Then there is we need to have our car, a driver, and we need to drive safely. And there will be a mechanism if we have a puncture or something, there will be somebody to attend to it. Okay? So, in my view, the government's role is that we have shown a path and we are setting up certain mechanisms to see that our travel is smooth. But then there's an industry which should own the car. And what this panel session is how we give you trained drivers who can drive the car properly. Right? So that's where we start. So we have a very exciting, a very broad spectrum of people. We have educationists, we have people from established industry, we have people who govern education, we have established business managers who have administered large-scale production industry. And we also, people who have done at-scale training, right? So that's the overall composition of this particular panel. And we would like to have, discuss this threadbare, because unless we have a driver who drives a car properly, we can't reach the end goal. And this is a very, very important component of our semiconductor mission. So with this few words, let me just start with Samvit, who is the VP and GM of IoT and Edge Computing, Intel. Intel has been playing a very important role in this, in our overall development, especially from the DIR5, the Digital India RISC-V initiative. The first chip that came out, the RISC-V chip for India, Intel had fabbed it out at 22 nanometer. I thank Intel on behalf of DR5. Specifically, we are now trying to look at multiple aspects: the design, the the front end and back end. Then we have the fab manufacturing, and then ATMP. And Intel has been doing this for several years, right from the 8080 to the current, multi-core server chipsets. And you have also jumped into what we call as the domain-specific architecture. And there is also a need for understanding these verticals from the domain perspective, right? So this is also something that comes out with the IoT. So as Dave mentioned in the fireside chat, there is a need for a different approach to design and manufacturing, specifically driven from the domain perspective. So, and that requires a different type of talent. So there cannot be a generic talent. There's a different type of talent for different domains. So now, Samvit being the hem of affairs for that very important business of Intel, we would like to hear from him what are those type of talent and how do we bring that up? What is the expectation from a large industry like Intel in this direction?
Thank you. Good afternoon, everyone. And I lead the IoT engineering of Intel. We have 2,500 employees doing silicon platform software worldwide. And the engineering headquarters is in India. And when I landed in India through Intel India in 2005, the story was very different. We were struggling to get one SoC done, hardly a couple of IPs. I think in the last 15 years, not only Intel in India, but all other companies have really marched pretty well in delivering products and IPs. And now we have around, in the whole country, 30,000 semiconductor engineers delivering 3,000 chips a year. This is an amazing accomplishment so far. However, we are not done yet because the semiconductor demand is significantly high right now. We are growing from 500 billion to 1 trillion by 2030 in semiconductor revenue. And there are just huge set of applications you may have heard about. So we need to continue this journey ahead, whether it is Intel, the startups, the academics, the government, all of us need to join hand together. And there are three aspects that we need to focus on to carry this journey forward. The first aspect is building the technical skills or growing the technical skills at scale, because capacity is a strategy. So we need to continue to build the capacity. And how we can build the capacity, it has to be done grounds up. We have to introduce the right level of courses, the right type of courses in our colleges, universities, in our MS and PhD programs. So I'm looking forward to my colleagues and friends here in academics to do that. Of course, we'll be happy to help. Secondly, I think we have lots of good skills today, but we are lacking in some specialized skills, particularly in architecture. And as we are growing into new fields of AI, IoT, automotive, which Professor Kamakati was saying, we need those domain-specific architectures, because those architectures for the different segments could be very different. So we need to build these technical skills at scale. And third piece is the MNCs and the other industries have to play a catalyst role in building programs and building facilities in our institutions. I'm very proud to say that Intel India is doing a lot of things. In our Unnati program, we have plans for building 100 labs in different universities very shortly. And that will help the students very much. And secondly, we also have programs to train artificial intelligence for all citizens. And we have a goal of meeting 1 million citizens, training 1 million citizens. The second piece is culture. What I see that in India, our engineers are very smart, very energetic, very passionate, very committed. But what we need to do is, how do we increase our influence? How do we define new things? How do we market ourselves in the global levels? Like in conferences or patents, we need to increase our presence there. So this culture needs to grow. Just by passion, hard work, commitment will take you to some level. To reach the levels of US, we need to really look at how do we increase our influence. And the other piece is strong collaboration is critical. The success of Silicon Valley was because of strong collaborations between universities like Stanford, Berkeley, companies like Intel and HP, and lots of startups. So lots of collaboration. We need to imbibe that in India and extend our collaboration. And third piece is innovation. We need to really innovate. The AI and 5G, these two technologies, as per market research, are going to enable a $17 trillion economy by 2035. So there are lots of opportunities to innovate. I was listening to Raja Kodri yesterday. He said, India should not be focusing on legacy stuff, but more focus on the new stuff, the upcoming stuff, like artificial intelligence, IoT, 5G, automotive. We need to innovate here. We need to innovate in these fields. And I really applaud the government's initiative and the DLI programs and PLI programs to encourage our startups. So innovation is key. So three things: technical skills at scale, strong culture of influence and marketing, and innovating in new fields. And all three is based on a foundation which our legendary ex-CEO of Intel, Andy Grove, said, that only the paranoid survive. We need to really be paranoid. Thank you.
Thank you very much, Samvit. I think like now we have AI course for every discipline, AI for chemical engineers, AI for naval technologists, right? So I think we should also have a hardware design course for every engineer, specifically mechanical, chemical. I think that's going to bridge this domain-specific part, because to teach hardware to a non-electronics engineer is much easier than teaching, say, chemical to electronics engineer. I think that's the thing I get. Now we go to Santosh, who is president and MD of TI. So acronym for TI, though it's called Texas Instrument, we also call it as Training Institute. Because so every time we meet a very senior person or who are non-TI, ask where did you start? They say TI. Right? So TI has been one. And very interestingly, I also found that people who left TI actually did something else. Again, came back to TI, reskilled themselves, and again, they were very happy to accommodate them back and even spawn out companies, and they have been doing this. And you had the first grand challenge of hundreds of engineers, or probably thousands of people participating in hardware design in the country. I think TI has launched, and it's been a continuous program. And from IIT Madras, IIT Bombay, everywhere, there have been a lot of collaborations with TI. So I request Santosh specifically to talk more about the statistics of manpower that we have, right? So today we were looking at making a holistic system, and you have been involved with mixed signal. I think every chip you touch is a mixed signal design. So how many engineers exist who can do an end-to-end chip and make it a product? And what is it that we need to bridge that gap? Thank you.
Thank you, sir. Thank you for the question. It's really hard to sit in front of professors and really speak, but I'll just do that because that's really the need here. The industry is like the audience that I see in front, right? Reasonably full, but can definitely have a little more people. But what is important to me in industry is just not really about how many people are there. It's really about the quality of the people, like the audience, right? I really care about who are sitting and what are they really going to ask us and take the message back. Similarly for industry, we are happy with much higher quality. Scale is important. I agree with Sampath, but I'm far more interested in having much higher quality. So to me, the need of the hour at this point of time, I think what we have done, industries particularly leading in the last 10 years or so, we came to India 37 years back. We were the first to come here 37 years back. The primary reason why we came and the reason why we continue to exist with the relevance it has got today is simply because of the talent. We have told it in several forums, right? That's really the reason why we exist. Today we deliver more than 50% of TI's products end-to-end right from here in our Bangalore office. I think what is important in the last 10, 15 years, maybe this is primarily because of the industry, the greed to have more people, the greed to go faster, etc. We are trying to make students coming out of the college employment ready, right? When I just look back, right, I would really like us to go back and tell the students, right, I'm telling my daughter who is doing engineering now, to be really more of product ready, to me, employment will always come. You can take a little bit more time. Go back and study linear algebra. That's far more important. Like what Professor said, right? If we are actually doing one branch of engineering, learn other branches of engineering. Be a true engineer, right? The holistic engineering is far more important in the long run rather than in your own domain you really try to do something, right? So my ask is very simple. When colleges teach, let them take more time rather than sending us ready to do what we have to do 6 months or 1 year later. We can wait. Industry has its maturity, we can wait. Let us just get them to learn linear algebra really well. Let's get them to do other branches of engineering before they really come to us so that we can truly make them product ready rather than employment ready. Only if the engineers coming in are product ready, we can take the country to market ready. Right? Because today we are making employment ready, which is really the need of the hour when students are studying. But when they really go through this, right, unless they can create and conceptualize products, right, we have very less number of people than several of our competitions here in the country. The reason why we are able to do complete end-to-end designs right from conceptualization to delivery of the products is because we do have that quality of talent that we have built over time. How have we done this? We have actually gone ahead and our hiring strategy is significantly towards hiring from the campuses, right? We hire from all kinds of campuses, more than 100 campuses today historically, and 80% of our hiring today comes from campuses directly. We respect all our competition, we respect people who are going and working outside, we would like them to come back, but that is when we really start a new domain. Mostly for our existing domains that we are actually growing, we are very, very happy to have people come from the campuses, challenge us, and they do challenge us on status quo, what we are actually trying to do, and make us definitely do better. To your simple questions or what you really asked, how many people, I try to answer it by quality of the people, but I'll tell you that there are designs that we do, extremely interesting ones, very, very innovative in the market with a couple of dozen people, end-to-end, most of the stuff that we do, right from architecture, development, conceptualization, which market to work on, all that we love to do that kind of work here. Two, there are definitely longer programs which involve a couple of hundred engineers working for 2 to 3 years of time. Right? So it depends on the complexity of the parts that we are picking up and the market that we are trying to grow. It's varied number. We do have all kinds of work, but my two asks is really looking at it to make engineers coming from the campuses who are more and more prepared to be product ready and very good in other branches of engineering. While we look at semiconductor as an important industry, we simply cannot forget the fact that ESDM is so much more important, right? Because unless we do have great people who can design these boxes that our products are actually going in, and some of them coming back and working with the product definition, we are definitely not going to be as good as what we can actually be. So ESDM market, how are we really growing talent there? How can we really crisscross between semiconductor development and product development, which actually uses semiconductor chips, is very important. And absolutely with all the new work that's happening in India now, when we are also manufacturing ready and future-proofing ourselves with manufacturing, we will complete the spectrum, right? So ESDM is an important portion, manufacturing and all associated things that comes along with it. And go back and look at the semiconductor design where we have already established that clearly we are market leaders in it, right? Anything that can be done anywhere in the world, we can absolutely do that here. And several of you have played a very active role on this. But we must actually have much more active work on ESDM. We've made some progresses, but we can do a lot more there. And of course, with manufacturing, we are looking at it to see how we can complete the spectrum.
Thank you very much, Santosh. And I surely we take these points, and of course, we'll discuss a bit after we finish one round. Now I go to Raja. He's been with Synopsys. Synopsys has been a great supporter of many initiatives of our country. We have started the Special Manpower Development Program in VLSI 20 years before. And from that time, Synopsys has been our great supporter. I still remember writing purchase orders in those days in 2001, 2002. Thank you, Raja, for that. Please give a round of applause to Raja for... So, Raja, now, in this marriage of semiconductor, the bridegroom and bride is the tools, right? So, now, please do. What is it that you feel that you can do in terms of building the talent with your tools? What sort of offerings is there going to be now that we have the Semicon policy for India? How are we going to, what do you think would be a great approach for our country?
Thank you. Thank you, Professor. So, good afternoon. Whether it's x86 architecture or ARM architecture or RISC-V, the underlying layer of all of this is the EDA technology. So EDA technology helps all of this, and thankfully we've been, I myself personally have been in the EDA industry for almost 3 decades and conceived part of the committee member of the SMDP, even before MATI was born. It was the Department of Electronics with a few key resource centers, they were called then. The top 5 IITs were part of it. And we divided the country into north, south, east, west, and picked 4 colleges of repute across India. And today, all the semiconductor companies, both global companies as well as our own companies, as well as the local companies, have really worked out of that initial vision that was painted by Department of Electronics those days. Going forward, in terms of what we are doing, in the last 20 years, and most recently, just about an hour back, right, we signed an MOU with MATI to now expand this to more than 120 colleges. So within the next few months, and all of this will be put on cloud. So we'll have access to all of the EDA technology available to every nook and corner of this country, which our budding grad students can definitely leverage from and come that much more better qualified into the industry. Is this enough? Obviously not yet, because you heard the rest of the panelists talk about scale. So I'm sure for a country today, we're not just looking at India, because we ourselves, Synopsys has about 89 offices throughout the world, and thankfully I've been in the company for more than 25 years, and I get an opportunity to travel to various offices of Synopsys, and to every office, whether it's in Europe, whether it's in Far East, or in the US, right? I walk in, I see an Indian employee who grew from one of our colleges here, got associated with a VLSI company, maybe TI, like Professor likes to call it, as a training institute, and then has successfully, at some point in time, either become a customer of ours or is working in the EDA technology. So it gives us, great, look back to see that we are now contributing talent to the whole world, not just India. Of course, now that with the push that, with Semicon 2020, right, we see a lot of buzz happening. And so we definitely think we are, as an EDA vendor, as an IP provider, we have the skill to provide this technology at scale so that more and more students and research institutes in India can leverage this and get to look at the next level of innovation, solving the more complex problems that all of us as humanity face. Thank you.
Thank you very much, Raja. And again, I place on record your great contribution personally and from your company to our India semiconductor program. Now, we just move on to manufacturing. We've been talking more about this product and the tools. We have Mr. Jun, who is the General Manager, Memory Business Unit of the Power Semiconductor Corporation of Taiwan. So we request Ms. Jun, welcome to this conference, and very nice, and thank you for joining. We would like to understand from a manufacturing perspective, what sort of manpower requirement that you have, what sort of courses you think that the students should have as a fundamental understanding of manufacturing so that they are almost ready to take up a manufacturing job, and what are the challenges you are facing specifically in recruiting such talent. Mr. Jun? You are muted, so hello? You are muted. We are not able to hear you.
Sir, you're muted. Kindly, yes, unmute yourself. Or can you raise the volume or something like that? Nothing is coming. Yeah, I think he is now putting on the headphone or something. Yeah, there's some connectivity problem at their end, sir. Yes. Yeah. Yeah. No. We can't hear you.
We can't hear you. Is it? I think, can you reboot and start? I think that solves the problem mostly. Right? And,
that's again Indian technology, sir.
Right. And right.
All engineering colleges, we learn that.
Hello. Yeah, we will just, we request you to reboot the system and join the link. Thank you. Yeah. So while we'll wait for Mr. John, now I request Subhashish that we have now that we have listened from all these people on the requirement of talent, now as IITs, what we can do, and please give your vision on how we are going to satisfy the talent requirement of our country, given our Semicon mission.
Okay, thanks, Kama. You know, we heard here people who have developed tools. We have like architecture. You know, we have the, you know, those who are making chipsets. And maybe we should have somebody who is also assembling and making a final product. So where does, you know, I would say people like us, IITs, NITs, other so many, you know, 1.2 million, I think, graduates. I think Professor Sahasrabudhe is here. He can tell where do we actually fit into this ecosystem. Now, you know, right now with this the focus that we are putting in here, you know, thanks to this great initiative by the government, the question is that what is lacking right now is the talent pool, and at what level? See, if you go back, you know, maybe I would say around 90, early 90, and see that that time all the computerization was happening, okay? And there was a need for large-scale training. And what happened was that, you know, there was a mushrooming of so many training institutes you could see across the road, and they could, to some extent, take care of the fact, because that needed a kind of training, which those kind of institutes are good enough. Now we are talking about training people in certain areas which are very high-end, you know, high technology areas. And normally, the lifetime of a high technology area is also very short-spanned. So there is a, you know, it keeps on, you know, you have to keep on updating yourself with the new things. You need to have a lot more depth, not only in physics, engineering, everything that you need to do. And also, what you possibly, you know, I can take it, another example is that probably, you know, machine learning, artificial intelligence. This also needs a lot of manpower, which is not possible by those kind of people who are on the, you know, did a great job those days, but no longer does. Here, actually, these educational institutes have to come together. Now, what is the first thing, right? See, right now, we probably produce manpower, which you can count in, you know, few hundreds, right? But you need like thousands, right? Okay. So we need a proper handholding, because such kind of things, when you go for high-ending, the tools, devices, everything is a lot more expensive, okay? Sometimes you cannot even touch them, right? Even those kind of things you have to do on the simulations, right? And we actually, that's where we need to have proper handholding. No institution here, I would say, you know, whether it's IIT or something beyond that, can afford to do that kind of training unless we sit down with all the industry people together. First thing is that we need to define the curriculum. What is very appropriate? And this curriculum also, we have to keep on updating every 3-4 years or something. It's not like once it is written on the stone and you keep on doing year after year. So that will not work. So that means even, I think, if you go beyond the research institutions where the faculty has to be retrained, you know, that's a big exercise that we need to do, right? Then what happens is that normally education, typically, is a, you know, normally you have input, there is a process which is an education where you may have the, you know, the pipeline of the students in, where you have curriculum, delivery, all these mechanism, and then there is an output at the end. Now, what is the output? As of now, the output
of an educational system is delinked from the process, because we train the student the way we think we should be training them, okay, or the student think they should need to be trained, but not what I think the industry requires. That's why I said there is a void, because you may have a degree, you graduate, but you may not be employable. That kind of issues are happening. And as it goes today, the interdisciplinary and the domain of knowledge that you require is a lot more than by considering purely, let's say, E or CAs or mechanical. It has everything. If you look at the heat dissipation, you have to look at the completely the mechanical engineering aspects of everything, right? So we need these people not just from E and others, but it has to be from somebody which is a courses taken from all these disciplines. Professors and others, they can come together. But what is also required that many of these colleges, and including even many of the IITs, we may not be able to provide them the actual hands-on training. So we have to have a very strong entrepreneurship. I think the TI does a lot of things as you training, but these are the people that you have to place them maybe certain amount of time that they can spend, which of course helps them to upfront what they call it pre-placement and others, which can be given to the beneficial to the students. But there has to be certain, kind of immersion of our students. Now, coming to the other one, who delivers? The professors, Now, if you tell me certain areas, as being the director of IIT, and I was the E head, we were desperate to get people in architecture. And where are the people? Or maybe in the VLSI design. If there are few, the industry will pay a lot more and get them. We'll never get them, right? Kama is an exception, okay? So if you have this kind of thing, then we need people from the industry to come and teach those courses. We have no problem. Somebody, being shared by industry and an academia. It has to be done to this thing. And this, because of the pandemic, now we have opened up all these online and other facilities. We should absolutely use that whenever it's required, right? But unless we do it together, okay, so there are a lot of experts, and they are really excellent experts, okay, in the industry. We need them here. Similarly, we will be very happy to have some of our faculty members, if they can spend time, their sabbatical, whatever it needs, okay, they can go there. So unless we do that, we'll never see the end, the light at the end of the tunnel, because we have to, what I understand, that we have to produce something like almost 85,000 engineers in this area. Where are the numbers, right? Each IIT may be producing in that particular discipline maybe 15 or 20 per year. So it will not happen. So we also need another aspect is that, the lateral movement of people who are already in certain profession, okay, and bring them on board to this one through some kind of a lifelong learning process, continuing or evening programs that we can actually do. We can work with some of this industry and do it from the industry personnel so that they can now change the job. Because see what happened, the job profile changes. Many of them would like to go into this, okay? And there are more opportunities in this. So I think we should also allow that. And then I think, this, the vision that we have, the Prime Minister and all these things, that the whole purpose, I think it's a collective responsibility to make sure that this happens. Thank you.
I think as directors, we have actually enabled a lot of interdisciplinary programs in all the IITs. Specifically, we started with one thing. We go to the first year class of non-computer science and ask them, what is your worry or sad? Sir, we didn't get computer science. So, so that is where we said, okay, you have a core discipline, but over the next 2 years, will find a lot of things which are much interesting than computer science. Now, all the IIT's curriculum, we have now made it so open that there will be one core area, but you can explore multiple areas, and that is going to fit very well into this Semicon training also. So with this, I now go to Mr. Jun, who has joined us back. Thank you. We would like to understand the talent pool necessary for manufacturing purposes. Thank you very much.
Yeah, good afternoon. Can you hear me now?
Absolutely.
Oh, great, great. Yeah, sorry, I had to switch to Chrome browser to get the audio problem fixed. My name is Jun Gu. I'm actually a business unit general manager for power chip semiconductor manufacturing in Taiwan. Actually, we're probably third largest foundry based in Taiwan. Worldwide is about, I think, is seventh in terms of revenue. So actually, I think with myself actually is actually not exactly in manufacturing, and I'm more on the business side. Actually, I started my career with Intel as a processor designer. I only actually joined Power Chip 2 years ago. Before that, I was mostly doing product side of things. So manufacturing is also a new thing to me as well. But unfortunately, our president has another engagement. He's not able to attend. He's probably better qualified to talk about the manufacturing. But I do, I mean, within last 2 years, with the expansion capacity everywhere, we do see a large demand on the manufacturing talent, especially in Taiwan. Actually, Taiwan, relatively to India, is a much smaller country, is about 24 million people population-wise. So the talent needed for, but actually Taiwan manufacturing wafer capacity is #1 in the world, over 20%. So as you can imagine, I mean, for manufacturing, you do actually need bodies, not just a few key smart person, right? So it is a big issue in Taiwan. So from what I can see, there are two issues. One is the R&D talent. So those are usually university or maybe even master's degree or PhD are required. So for that, that counts probably maybe 10 to 20% of the people you need in industry. Then there's other large portion is the skilled technician, right? You need people running the clean room, maintain the equipment, things like that. Those actually is also a big issue because you do need a body for that. The fab is running 24/7. You need a lot of people to do the job, right? So for the R&D part of things, actually our CEO and also the founder of the company, last year he actually seeing this talent shortage, he actually proposed to Taiwan government to establish dedicated semiconductor colleges in the top tier universities in Taiwan to particularly attract students from various backgrounds into semiconductor training. So for now, Taiwan actually established 5 semiconductor colleges in the top 5 universities. And these colleges actually, they raise fund from industry, then the government matches the fund. And the colleges is a postgraduate. So they recruit undergraduates from various disciplines, then getting to master's program and a PhD program. So the plan is to recruit about 200 students each year from each colleges. Then there's about 1,000 engineers. But this obviously is still not very sufficient. Right now in Taiwan, as I said, we account for more than 20% of the global capacity. We have about maybe 200 or 300 people in the industry, right? Not all of them are in manufacturing, as you probably know. Taiwan also have a few pretty big fabless design houses. They also require a lot of engineering talent. For manufacturing, even maybe just 200,000 people, if you have about 10% or maybe 5% change every year, so you need still a lot of new, fresh talent into the field. So for this, I think for a small country like Taiwan, we actually are adjusting our policies, and the universities are actively recruiting foreign students to join into this industry. I think for this front, Taiwan and India actually can collaborate a great deal. As the panelists already discussed, for design and the software, India actually had a long history working with global companies, especially US companies. So there are a lot of talent base already. But for semiconductor manufacturing, a lot of things you really have to have hands-on experience, not just classroom courses or remote learning, right? So Taiwan actually, Taiwan fabs and can probably provide this training ground for the India as a kind of as a practicing or training ground for India hardware manufacturing engineering talents. So I think actually our CEO is also promoting this as well, and I think we have worked closely with India Institute of Taiwan, which is more like a India embassy in Taiwan to try to establish this kind of program. Actually, I think India I mean, with large population and a very well undergraduate education, such as IIT, I think it does can serve as a talent pool or hub for the global semiconductor industry. Yeah.
Thank you very much. And yes, we would have a lot of things in common. And certainly there are some models that already we had worked out with Taiwan. And I think the chairman AICT is here, and he will mention during his remarks. Thank you very much. And yes, we look forward to have many more such interactions and learn the best from each other. With this, I just go to addressing scale. I'll request Venkatesh, who is the Group CEO of RV Skills, trained more than several lakhs of people so far in this semiconductor domain. And like to request your remarks specifically addressing the scale point of view.
Good afternoon, everybody, and I thank the organizers for having me on the panel here. I represent a brand, RV, which has a 75-year of legacy in traditional education and about 20 years specifically in skilling. In the year 2002, the president of the Rashtriya Shikshana Samiti Trust, Dr. Panduranga Shetty, felt the need to enhance the employability and offer skills to the students. And I was the founder CEO setting up RV VLS at that time, which has now become RV Skills. Now, in the last 17 years, we have trained around 10,000 engineers, and we have close to 100% placement in the VLS industry. We have placed people in product companies and service companies, in EDA companies, in IP and foundries. So we have some experience that I would like to share with the audience today about how we can scale and achieve the goal, a very ambitious goal of skilling 1 lakh engineers over the next 5 years. The first and foremost thing that over the last 17 years that I have seen is there is lack of awareness about VLSI. And within my extended family, I'm finding it difficult to convince people that after you finish your engineering, you have to get into the VLSI industry. There's a lot of scope. So I congratulate the government for setting up Semicon. I think all these days, the awareness was being created by the industry bodies. For the first time, the government is doing this. Government has a bigger machinery, and I think the message will go out far and wide. So I really think that this will bring in a lot of awareness, create a lot of awareness amongst the people. Now, when you do that, the next problem that we're facing is the lack of talent. Even the IITs are not immune to this problem. We have very well qualified engineers who are either going to the fintech industries or to other industries, which with the awareness and creating a roadmap, I think we can plug the talent pool. There will solve some portion of the problem. The third, and I think we have Sahasrabudheji here on the panel too, is with NEP coming out, there is so much that we can utilize it for the betterment and improving the employability of the students out there. There are provisions currently for doing mini projects. There are provisions for internships. There are provisions for doing a final year project. I think we should not let this opportunity go waste. We should, as a body, sit together, discuss, and formulate a strategy. I think Subhashish was talking about content and how we can develop content. There's a lot of experience on putting out contrived test cases where we can enhance the productivity of engineers who come out from the colleges. Another piece which will help us in scaling is adopting technology. We just heard from Raja talking about going to the cloud. I think that is the way to go. The biggest issues that we have found with most colleges is installing the software and getting it to invoke a license and check out a license. So this will greatly improve that, and going cloud, using the technology and using LMSs in order to take forward is the right way to do. Now, one thing is, when I started this institute, I was 35 years, and now I am 54. So I'm aging every year. But the age of the student coming to the institute is still around 25, 26. Over the years, what we have seen is the attention span of the student is falling. Now I cannot hold his attention for more than 7 or 8 minutes. So when we take up education through a blended online mode, I think we should be mindful of the pedagogy of teaching that we are going to adopt. So we have to adopt concepts of micro-learning, and we have to make sure that it's interactive, it is engaging, so that the learning outcomes are there, completion rates are high. Otherwise, we are going to continue to see a very low completion rates on online courses. That's about it, which I wanted to say. Thank you very much.
Thank you very much. Now, we go to Professor Anil Sahasrabudhe, the chairman of AICTE. Sir, so we have a challenge, we have a need, we have some basic building blocks, we have industry and international partners who are willing to support. So, sir, it is all in your hands. How do we put all these things together? Because you are now the boss of the scaling. And so, all yours. Looking forward to hearing from you.
Yeah, thank you, Professor Kamakoti. In fact, I listened to all the industry people, IIT and RV College. So what it comes out to be is semiconductor mission has to be certainly multidisciplinary. We require not only people from electronics and VLSI background, but we require people from chemical engineering, mechanical engineering, and all other disciplines of engineering to put together. And therefore, and also, as June was saying, we require fabrication, manufacturing requires another set of people, be it in terms of equipment handling, be it clean room handling, be it running the fab itself in terms of quality product delivery, and when the fab is running continuously 24/7, ensuring water supply, electricity supply. So it is absolutely multidisciplinary in nature, and therefore we cannot have any other thing than solving a jigsaw puzzle. We have polytechnics and ITIs required for lower end manpower requirements to run the fab, to run the machinery, to take care of the technician job. On the other side, there may be some supervisory people at the diploma level, and then engineers who are graduating engineering for taking care of some of the little higher end work, and people from IIT and universities who come from research background to have the further new designs to be created. And I am sitting here today from Hubli. I'm in Karnataka only, from another institution in Hubli, which started a very small unit of what is known as Sankalp Semiconductors. This was about 7-8 years ago, with 6 people on the campus, and today it is more than 600, giving a lot of designs to US companies. So I think there is a lot of talent. We should not think that there is no talent in this country. In a small place like this, if there is talent, I think talent exists all over. What we need to do is, we need to do a finishing touch to that. We need to hone their skills further. And more importantly, rather than theoretical knowledge, how do we bring them actual practice, hands-on? And that is where students will not get bored. You were telling, Venkatesh, that they have an attention span of 7 to 8 minutes in a classroom where there is one-way delivery of lecture. If you involve them in interactive discussions, the attention span is more than 30 minutes. And if you ask them to do something in the laboratory, work on the, on the field, you have to develop some tools yourself. I think their attention span is pretty long. And this is our experience in terms of Smart India hackathons, which we have been conducting in the last 4 years. Challenging problem statements given to them, they give solutions, and 36 hours without sleeping they work. I think on one hand in the classroom, their attention is 8 minutes. On the other side, they can work non-stop 36 hours. So it is actually, how do we use that talent? How do we hone that talent? And that is where the role of educational institutions, first in terms of the curriculum being up to date, using industry standards, calling industry people for even taking some of the classes, sending students and faculty to the industry for internships, and so that they're abreast with what is happening in the field day in and day out. The technologies are rapidly changing, and there must be constant lifelong learning philosophy adopted by teachers first, and then in turn to the students. I'm sure with this as the mission, which the Honorable Prime Minister is talking about, Atmanirbhar Bharat, with huge budgetary provision which has been also made, I'm sure we will all put together our efforts in order to make this successful. I think I would like to give simple statistics. In the AICT approved total 3,200 engineering colleges and about 2,800 polytechnics who give diplomas. In 458 colleges, there are 8,543 seats available at MTech level in this field. Maybe not directly, only directly or indirectly, embedded system design, VLSI, nanotechnology, or combination all of this in the electronics department, postgraduate seats. In terms of undergraduate and polytechnic, this year we have opened up 2 courses, BTech in electronics engineering with VLSI design and technology, as well as I think these are 2 important, what we start taking up these courses. I'm sure some training will be required, and I'm happy June has already said that Taiwan is open for giving internship opportunities for our students. We have been working with them. We are working with US universities in terms of 2+2 joint bachelor's program in engineering, 1+1 master's program in engineering, research collaborations in terms of internship opportunities, joint offering of the courses. I think sky is the limit. We put in all our efforts to make it that this semiconductor mission of the Government of India, where it has been very serious about it, make it successful. Thank you very much.
So thank you very much. So we end this panel on a very, very positive note that we have all the building blocks. We have a path by which we can scale. We have the support from the government through the Semicon policy, and that we have a great demand for, from the employability point of view and from the customer's point of view. And we also have great support from all the international partners. With this, there's nothing that's going to stop, and in the years to come, we are going from height to height. With this, I thank the organizers for giving us this opportunity to come together and talk about this most important driver for the semicon policy, the human capacity, without which it's not going to be possible to run such a large program. Thank you very much.
Ladies and gentlemen, we are all getting set for a very, very interesting session. Dignitaries have taken time off and they have come exclusively for this conference. So I would request all of you to kindly take your seats. And I would request kind to refrain some little movement when the session is on. So please take your seats and we're going to start the session in just a bit. As the stage is being set, I'll utilize this time to give us a very quick intro into the moderator of this session. Professor C. Raja Mohan will be the moderator for this session. He is the director of Institute of South Asian Studies, National University of Singapore. He is the contributing editor on international affairs for the Indian Express. He has taught international relations at the Jawaharlal Nehru University, New Delhi, and the Nanyang Technological University, Singapore. So I would request Professor C. Raja Mohan to kindly come over. Yeah, you're there. And ladies and gentlemen, the moderator for this all-important session, the panel discussion on global partnerships for the future of technology. I would also like to call upon Mr. Barry O'Farrell, Australian High Commissioner to India. Hearty welcome to you, sir. Also, I would like to call upon Noor Gillon to kindly come over, sir, the Ambassador of Israel. Drew Shifleton, Consulate General of U.S. Embassy. Also, we have Gert Heiskoop, the Consulate General of Netherlands. Dong Kyu Kim, the Director General of Korea. Yes, ladies and gentlemen, it's one of the most illustrious panel you would have attended several conferences, but this, I think, is a real, let's give a huge round of applause for this highly illustrious panel. I mean, the first of its kind in the country, which is happening in Semicon India, the first ever edition of Semicon India. I would now hand over the session to Professor Raja Mohan to take us through.
Thank you for that introduction. We have an exciting panel, as the MC said. So, ladies and gentlemen, let me welcome you for this very special panel in this Semiconductor Summit. Unlike most other sessions, this one is going to be focused on global partnerships for this mission. We all know the semiconductor mission of the Government of India is one of the most ambitious and one of the most challenging missions ever undertaken by India since independence. There were a number of other missions before. I mean, you can go back to Homi Bhabha and the start of India's nuclear energy program that spawned the space program that also spawned the India's electronics program. And then we've had a whole range of missions since then. But this one, seeking to make India a semiconductor hub, involves a far greater energies, far greater scale. It needs to bring together India's technology, science, industrial capabilities, and bring them in partnership with the global partners. So this makes it even foreign policy and diplomacy are going to be very much part of it. But in the end, it's really about building national capabilities in partnership with other countries for mutual benefit. And we're undertaking this mission at a time of very complex international environment, which has fundamentally altered the context of the semiconductor manufacturing. Till 3 years ago, the general belief was that efficiency is what mattered. Borders did not matter. Politics did not matter. You took production to where it was most efficient to produce, and things moved from one part to another part. So China, being the factory of the world, did not make a difference to the world because it didn't matter where it was being produced, as long as it was being produced efficiently. Taiwan produces most of the world's chips. That didn't seem to matter. But today, 3 years down the road, since that general assumption, what we have today is politics matters as much as economic efficiency. Because there are major conflicts between US and China. There is also the India-China conflict. There is now the Russia versus West conflict. So these conflicts have created a fundamentally different situation in which technological cooperation must take place. We've already seen significant changes in the international environment, and that the dangers of relying just on one source for production of anything, that is a problem. Therefore, today the world is looking at new ways of doing things. And within that, the semiconductors question is far more complicated because no other sector has had so much geographic concentration. Just you had Taiwan and South Korea, my friend is here, that most of the production has taken place. China is trying to catch up with them. And then the industry concentration too is really just down to 3 companies now. So this is really a completely challenging situation. And we are trying in this situation. The principle now is everyone believes large countries must have some national capabilities in this. But at the same time, the scale and the difficulty involved in making semiconductors is so complicated, it can only be done in international collaboration. So partnerships and collaborations become a key element. And the partnerships, unlike in the past, are going to be between like-minded nations. Nations which trust each other, which can bet on critical elements of this vital supply chain, because semiconductors are everywhere, that we need to have enough trust and political confidence in each other. So that is the context in which the semiconductor mission is operating. And within that, today on this panel, I can tell you that we have 5 of the most like-minded partners on this stage. We have, if you go from the other end, we have Israel, ambassador from Israel. Israel is one of the world's most leading technological centers of innovation. So there you are. I think they're into this business very well. And then we have the Dutch council here, who, Netherlands is the only country that makes the machines which make the chips. A lot of people make chips, but only Netherlands makes the most advanced machinery, the extreme ultraviolet mechanics of making chips. We have Mr. Kim, who is from the Korea, which makes a lot of chips, but Koreans, as you know, are the second largest producer of chips. So yeah. We have Australian High Commissioner, Barry, who's Australia, is probably today leading the whole technological coalition building in relation to India and its partners. They're key members of the Quad. They run this whole lot of programs which try to bring our partners together. And here they too will have a major role. And finally, Drew from the US Embassy in Delhi, who looks after their economic, is the Minister of Economics. The US, of course, has fundamentally altered the template in which the semiconductor mission is going to take place. The last 3 years have seen dramatic changes in the way the US looks at China and the US determination to decouple at least critical sectors from China and set the stage for a new framework for cooperation. So this is the 4 panelists that we have. So I'll go from the left. What we'll do is, what I've asked each of the panelists to speak for about 6 minutes, essentially addressing 3 broad issues. One, where is the country in relation to technological development of semiconductors? 2, their international strategy for collaboration. And where does India fit into that partnership model that they have? So Ambassador Naur, we'll start with you. The floor is yours.
Thank you very much. Thank you, Raja, for speaking of Israel as being a technological hub. Many refer to Israel as the startup nation because of the huge numbers of startups per capita, the highest in the world. Investments in startups, highest in the world per capita, and total number of startups over 7,000 for a country of 9 million people. So also in the semiconductor field, Israel is very active. The biggest player in Israel is Intel. Intel has in Israel for quite many years a fab, but also as important or more important, an R&D center for semiconductors. And another player, we have actually 3 main players. The second important player is Tower, which is one of the world leaders when it comes to analog semiconductors. Tower, an Israeli company, has 8 factories around the world, 2 of them in Israel, and R&D in Israel. And the third player, there are many smaller companies, startups and others, who are producing elements of the semiconductor. So technology which is connected to semiconductor. And now the 2 first players are probably going to get married soon, in the sense that Intel announced that it's going to procure Tower during this year. So the process has started, not concluded yet. What the good news, I'm coming directly to the good news and the practical news. The good news is that this morning I had the pleasure and the honor to be with the Chief Minister when we witnessed the signing of an MOU between Karnataka and Tower for building here a fab. So, Tower, by the way, has with the space agency already made the first fab. It's not a commercial one, it's a research one, but it's still working here, the only fab that is working. So hopefully, if the whole process will continue as we hope, in the coming year, I think the breaking of the ground and the beginning of the works here, this will be a very important fab in the sense that it will create here also the ecosystem. So directly in such a factory, the investment is around $3 billion for analog. Directly, it should employ around 1,500 people, but indirectly many, many more. But more important, it will create here, I think, an ecosystem around the semiconductor. Also, we spoke this morning together with the Chief Minister and the Minister for Technology during the signing that the IIT here and other institutions will have to start preparing the graduates for practical. That was the request of the Chief Minister, to prepare the graduates with practical preparations to work in the field of semiconductor. So I think, I hope it will happen. It will be a big thing, especially for us, India and Israel, because we are celebrating now 30 years of diplomatic relations, and this will be a huge celebration for us if we can do that. So we are happy. We are happy for Karnataka. We are happy for India, and we are very happy for Israel. So thank you.
Thank you, Naur, giving us the Israeli perspective. Gert, tell us about what the Dutch think.
Does this work? Can you hear me in the back? Yes, wonderful. Namaskara. Good afternoon, everybody. A pleasure to be here and to give you some perspective from Northwestern Europe. Electronics, semiconductors is big business these days. When I joined the Foreign Service 40 years ago, I'm as old as the integrated circuit. We were both born in 1958. When I joined the Foreign Service 40 years ago, it was a different world. I mean, an incubator was something you only found in a hospital. An accelerator was something you found in a car. And a conductor was a person who was standing in front of an orchestra. So a semiconductor was the same guy with a maximum height of maybe 4 feet. But all that changed. Nowadays, these things have a different meaning. Our claim to fame in the Netherlands when it comes to semiconductors is that we are not so much a huge producer of chips, ICs, and semiconductors, although we produce these things. We make the machines that produce chips and semiconductors. The company that is involved most of that in this business is ASML. I have a strong personal link with that company as well because one of my sons works in ASML. And they have now something like 80% of the market. It's on the Dutch stock market is the biggest company by far. Their stock market value is as big as Shell and Philips combined, and these are not small companies either. And the future for this sector is very bright. There's a lot of collaboration already with India in this field because in the Netherlands, the biggest Indian community in the European Union lives in the Netherlands, 30,000 people. And most of these people work in technology. A lot of them in the south where ASML is located. You see, when you compare India and the Netherlands, we have the capital, Delhi for India, Amsterdam for the Netherlands, where everybody always travels to. There's a finance center, Delhi, Mumbai here, and Amsterdam also in the Netherlands. And there is the Science and Technology Center. That is, of course, Bangalore here in India. And it is Eindhoven Brainport in the south. And that is where so many people work. We employ thousands of scientists and engineers, and many of them from India. You see, Dutch universities train a lot of Indian students. There are now over 3,000 Indian students studying in the Netherlands, most of them in fields like engineering and science. And we try to keep these guys because they're bright and smart, and they often work for ASML. Yes, you can applaud your countrymen living in... We're very grateful to have them because we need them for our high-tech economy. And we're looking for methods to improve and increase the cooperation between our two countries. You couldn't possibly have missed the visit of Indian President Ram Kovind to the Netherlands a few weeks ago. It was all over the press. The Dutch Foreign Minister was here last week, and we are looking at ways to increase the cooperation between our two countries, also in the field of semiconductors, because, as you all know, there is a problem with semiconductors these days. There's not enough of them. It's hampering the production of cars, household electronics, phones, TVs, you name it. These things are in every item we need. So production needs to be extended to other places, and it has to go up. Right now it's concentrated in East Asia, in Taiwan, Korea. My neighbor will talk about it later on, Japan and China. It's not a good idea to increase production in a country like China for many reasons, also for strategic reasons. So it would be good if we increase production in a like-minded country like India, and that is one of the things we're aiming to see. And that is basically what we're working on. It's one of the part of my job here, and I see that the moderator is looking at me, so I'm overextending my time. So this is where I stop. I'll take questions later on. I'll pass the mic to my neighbor on the right, Mr. Kim. Thank you very much.
Thank you, Gert. It's really I think one of the points that are being discussed in this summit is the Indian talent and its global impact. I mean, I think that's what you mentioned. Thank you for that. And Kim from the...
Thank you, Mr. Moore. Thank you so much, to invite me here in the Bengaluru for the India future business industry. I think it is a very significant event for the future of India. And I'm very happy to have you here because I live in here. So, especially I would like to thank you, Honorable Minister, Sri Rajiv Chandrasekhar, to host this significant event here in Bengaluru. Appreciate. I can say that Tuna Pada Kalu. Is it right? Thank you. Say the Korean companies who have established their facility in India have tremendous contribute the concept of making India policy for the last 30 years since 1990s. As everyone here, industry leaders know that starting from LG Electronics, Samsung Electronics, and Hyundai Motors, Kia, POSCO, most of the Korean manufacturers, major manufacturer conglomerate, have their presence in India to hire several 100,000 employees to produce the best quality of product for the client in here and domestic or overseas. That's the concept of making India, we believe. It's not just for the Korean company itself. It is for the India and for the global, the concept of making India. I want to point out the Hyundai Chennai factory have produced 700,000 cars in a year. Among them, 150,000 cars are exporting to other countries, Middle East and South Asia, which is exactly the model of making India, the asset of India's industry. So this is the concept that Korean companies wanted to build up relationship in India. Now here in Bengaluru, I want to say Samsung and LG, they have the biggest overseas research center here in Bengaluru, hiring around 4,000 high qualified IT engineers to develop and research for their product to make the better one. So, among them, I'm very proud that Samsung has a managing director is Indian, Mr. Dipesh. It's for 7 years. Continuously grew up, continuously evaluated the best leaders of Samsung. So that's, practically speaking, I'm very proud of that because he loves India, he loves Korea. So we wanted to build up those kind of relationship here in India. Now that we can say the semiconductor area, still, the Korean companies have not decided anything, I think, but now they can understand how much India is, ambitious to make the best of semiconductor, the hubs for the market in global. So I think this kind of session and government is, the plan and strategic plan can contribute. A lot of the semiconductor companies, including Korea, Japan, Netherlands, Israel here, they can understand now. They have to understand now to come to India, to be a friend of India, for the people of India and for the people of the global. So hopefully this session can contribute on that point. Thank you.
Thank you, Ms. Kim. Thanks for that. Ambassador, very High Commissioner for Australia.
Thank you very much for the invitation to be here today, and congratulations to the Minister on the inaugural Semicon, because everything I hear is that it's terrific, and certainly Australia is delighted to have been invited. And to answer the question that I think the panel's meant to answer is Australia is also up to cooperating with India. with other countries, whether through the Quad or bilaterally, to ensure that in this area we not only have competition within the world, but we have those secure supply chains that are necessary. The moderator was a bit generous to Australia at the start, saying that we had a critical role. It's a bit hard when there are fewer people in Australia than the number of 9-year-olds in India to suggest that we have a big input into anything. But we do have some niche capabilities around design, research and manufacture, and also silicon irradiation. But where I think we come into our own relates to critical minerals. Most people know Australia as a responsible and reliable resource partner. We've been blessed with critical minerals and rare earths. Most of the world's largest recoverable deposits of those exist within Australia. And our government has prioritised it by 2030. We're taking a leaf out of India's book. We've set ourselves a mission by 2030 to become a global player in relation to the supply of critical minerals that people in this room know are far more critical, not just to semiconductors, but so much of this emerging and critical technology than we could see. So we're already working, and we've worked with the United States on their 100-day review. We're working through the Quad on identifying and mapping supply chains across the Indo-Pacific. We're working bilaterally with India, and we'll continue to do so. The trade agreement signed only a few weeks ago gives India first shelf or top row access to investment in Australia, critical minerals and rare earth mines. And one of the minister's colleagues is expected in Australia in June, along with Kabul, the arm in India that makes investments in these sectors. And at the same time, the Australian government is seeking to de-risk investment for people from overseas and within Australia to develop these mines. The Australian government has put money on the table to accelerate development of this sector because of its importance. Why are we doing this? We're doing this principally because, as has been mentioned before, the world has changed over the last 4 years. We're doing this because of the health and economic lessons that came out of COVID, that supply chains and diversified supply chains and secure supply chains with reliable partners are more important than ever. I'm sorry to say this in front of my Netherlands colleague. We also learned the lesson of diversification. So I'm not suggesting Australia is about to get into the business of building chip manufacturing equipment, but it is one of the lessons that we learnt through that COVID period. So Australia can participate in a number of ways. It's determined to continue to work with India. We're establishing a consulate general here in Bengaluru because of the importance of the tech sector in this part of India. Importantly, we're establishing a joint centre of excellence on critical and emerging technologies policy with India because we want to work together with India and Australia and with other like-minded partners to ensure that the governance and the rules that are set up around these technologies internationally are rules that do what we in this room want, which is to enable people to fulfil their incredible ambition, not to be used for coercion. Australia also wants to continue to cooperate with India in relation to education. I regret that I'm sitting here as part of the second panel, which is all male. We in Australia, and I know in India, are working very hard to get more girls and women into STEM courses and opportunities because you can't lock out half of the potential in your country when it comes to any industry, let alone this industry where so many women have done so well in the past. We want to also ensure that under the national education policy, more Australians come here to be turned on to the opportunities that exist in India. I visited Israel last century, where it was made clear to me that that military service that is part and parcel, regrettably, of Israel's existence had also turned many young people on to the technology that's found within the defence forces of Israel. I'd like more Australians to come here to Bengaluru, to the other tech centres at Pune and the like, to see what is going on in this sector so that more of them will get involved. Australia has a history of good research that in past times has gone to a northern neighbour of India's. We're determined with a new breakthrough in relation to low-cost solar panels that will come here to India because that's the only country that can scale up and provide that competition. I think it does matter. The only thing that matters about whether a country's got complete control of a particular sector is how open and democratic its economy is Taiwan poses no threats, but when autocratic nations get control of these things, they do tend to distort markets, and that's the other lesson out of COVID. So it's terrific to be here, it's terrific to participate. We do have opportunities which we want to pursue with India, with the world more broadly, and we're certainly up to the job of ensuring we have those critical supply chains that will guarantee that India's latest mission, its semiconductor mission, will not only be achieved because of the incredible talent that exists within this industry, within this country, but also the agility and the willingness of industry to get behind government missions to deliver the outcomes. Thank you very much.
Thank you, Barry. Thank you for that stimulating presentation. Drew, this floor is yours.
Let me just say that it's a really incredible pleasure to be here. I would like to thank the Ministry of Electronics and Information Technology and the program organizers for inviting us to join Semicon and for convening this panel of trusted trading partners to discuss semiconductors, a product that I think we'll agree has become central to our lives. Try living your daily life without them, and a common focus, of course, to our countries. But first, I'd like to step back just for a quick second from the tech stuff, and I'd like to use this moment to reflect just a little bit on the US-India partnership itself. This year marks the 75th anniversary of US-India diplomatic relations. And from science and space to new and emerging technologies and protecting against cybercrime, to combating climate change, to finding clean sources of energy and protecting our oceans, and on to expanding our trade. There's no area of human endeavor right now that the United States isn't working on with India. And as the world continues to open, we have multiple engagements that we've held, including just last month, just a few weeks ago, we had the US-India 2+2 ministerial dialogue, where Secretary of State Blinken and Secretary of Defense Austin welcomed Minister of Defense Rajnath Singh and Minister of External Affairs Dr. Jaishankar to Washington, D.C. And that was preceded by a virtual meeting between Prime Minister Modi and President Biden. And these and many more two-way visits show the high level of commitment to our enduring bilateral relationship. And then, of course, there's trade and investment, which has really long been at the heart of the US-India relationship. Due to these ever-expanding ties over the last 2 decades, our bilateral trade in goods and services went from, in 2001, it was $20.7 billion, and last year it was almost $160 billion. So that exceeded the pre-pandemic trade record. In other words, it was a new record. Our bilateral trade has a really wide and lasting impact also on our economies and societies. And that relationship has just continued to expand over time. Most major US firms, and many that you've heard from throughout this conference, of course, have significant investments and operations in India. And they have made the United States the largest source of foreign direct investment in India. And as the world's 2 largest democracies, our countries, the United States and India, also, we share a resolved commitment to protect our citizens, and we've helped to provide security and stability in the Indo-Pacific region that has underpinned our economic prosperity, and we're going to keep right on doing that. Also, just a really quick reference I would like to make, of course, to COVID-19, which has really, it's tested that resolve for all of us. But over the last 2 years and counting, the COVID-19 pandemic has really driven home the reality of our catalyzed reliance on technology and connectivity, and the disastrous effects of global trade disruptions that have been driven by the fallibility of our supply chains. which is another topic which directly bears upon why everyone is gathered here this weekend. And as all nations are seeking to revive economic growth, developing manufacturing and creating jobs, we believe India has a historic opportunity to fully integrate into Indo-Pacific supply chains, including of semiconductors, as investors and manufacturers increasingly seek alternatives to China in the wake of long-term rising costs and pandemic-driven instability. And as India saw in the 1990s, the more open an economy is, the faster it really grows. While we recognize that all countries are working to discern, what are the economic lessons that we've had from the pandemic, and we're all trying to figure out how to implement policies to promote economic recovery. We know that the benefits that U.S. companies have brought to bear in India, and we look forward to their continued participation in the Indian economy. And we were glad that Prime Minister Modi prioritized joining global and regional supply chains in his August 2020 Independence Day speech, and supported achieving this by improving India's business and investment environment. And then, as President Biden said last October at the Summit on Global Supply Chain Resilience, working together across the entire supply chain, from raw materials to warehousing and distribution, is really the best way to reduce delays and build in greater resilience for the future. And so let me just say now, before I wrap this up, that the United States sees 4 fundamental principles that encourage more resilient global supply chains. One is transparency. Improving transparency and information sharing will help all countries mitigate and respond to these global supply chain shocks. And this includes working with businesses to understand their own vulnerabilities. Transparency in supply chains promotes awareness of risks and potential shortages. It identifies bottlenecks and assists organizations in determining where alternative sources of critical inputs are needed. Next is diversity, openness, and predictability. Open global markets are fundamental in supporting resilient supply chains. Countries have to work together to ensure we have multiple reliable sources of raw materials, intermediate goods, and finished goods. Every country represented here today has a role to play in promoting that kind of shared benefit. Next is security. Countries discuss that security needs to be recognized as a high priority for all players with supply chains, especially in technology supply chains, at critical infrastructure nodes, other points within the supply chain that really must not fail to prevent damage or disruptions that interfere with critical systems or infrastructure. It's important that governments work with industry to better understand and manage security risks to supply chains. And then the last is sustainability. Governments, industry, and civil society should work together to promote and accelerate global sustainability goals, including implementation of the Paris Agreement on climate change and international labor and worker conventions where they're applicable. Creating fair, sustainable labor conditions strengthens our supply chains, and it leads to more innovative, productive industry and greater shared prosperity. Finally, multilateral work with many of our partners here today has made supply chain resilience, especially for semiconductors, a very important part of our coordination. And we've seen that. Last year, the Biden administration expanded the reinvigoration of the Quad, which includes, of course, India, Japan, Australia, my country, with 2 leader-level summits. During the first ever in-person Quad Leaders Summit, we put forth ambitious initiatives to deepen our ties and advance practical cooperation on 21st century challenges, including COVID, promoting high standards infrastructure, combating the climate crisis, space and cybersecurity, cultivating next generation talent in our countries, and partnering on emerging technologies. And so with the Quad's Critical and Emerging Technology Working Group, we're using it to actively talk about semiconductor supply chains and how we can maximize the Quad as a partner for these kind of capabilities and resources. So to conclude, as trusted supply chain partners, all of us here have an opportunity to learn from the crisis that we've faced, whether it's working bilaterally, through the Indo-Pacific or through the Quad, building systems that support technology, including semiconductor manufacturing, will help guard us against future vulnerabilities, and it will really help strengthen our bonds. So again, thank you very much.
Thank you. Thank you, Drew. I think our panelists have been very disciplined. They all finished in 35 minutes. It's fantastic to have panelists like this for a moderator. So please think of various questions, short and brief and sharp pointers to the speakers. But before that, I just wanted to ask one short question to each of these speakers. So maybe we can do this like a quick fire round, as they say. Now, I mean, there is the Quad, which our two gentlemen to my right pointed out. But there is talk about another Quad, which Israel, India, US, and the United Arab Emirates want to form. And one of the central ideas was about innovation, where Israel is strong. And UAE and Israel have also worked on the chip production. So can you tell us briefly how that Quad might work on the chip production and what it can do to semiconductor mission here?
Yes, I think that we're witnessing, while the world is changing, also the Middle East is significantly changing. The Abraham Accords was a huge change where for many years, many countries a few countries in the Middle East had very good relations with Israel, but did it under the table, under the radar, as you would say. But now everything is in the open and much more convenient and comfortable to do. I believe that the world is also changing in the sense that countries are looking for regional alliances to promote. And the idea, by the way, of this Western Quad, or whatever name you can give it, the group of four, which is India, US, Israel, and UAE, is to work on infrastructure, but in a very wide definition of infrastructure, with an emphasis on technology. So I think it's a wonderful combination, because these are four countries that are very friendly. India brings in technology and a huge market. UAE brings in finances and ability to transport and build business, and the Americans are bringing the full package. We are the smallest player there, I believe, in many aspects, and we mainly bringing technology. So I believe that such alliances are extremely important for the future of our countries, of our relations, India and Israel, but also with other countries. And we have high hopes from this group, and many to follow later on.
Thank you. Kurt, if I might ask you, I mean, last week we had the European Commission President in town in Delhi. They've announced the Trade and Technology Council. I mean, these two areas were considered different, but today technology is very much part of it. So since we're the only European here, maybe you could tell us, because this is the only council, Europeans have only done it with the United States. So this is only with India that they formed. Can you just tell us in a nutshell to our audience what this Trade and Technology Council means?
Well, Europe is, of course, people are always a little bit confused about Europe, especially Americans have a little bit confusion about Europe, because in North America is about the same size as Europe, about 10 million square kilometers. You only have 3 countries there if you include Mexico, and only 3 languages. And when you go to Europe, you have 51 countries and about as many languages. It's a very confusing place. So we're also one of the cradles of democracy, actually, in Europe. And we're looking forward to build up the cooperation in all fields, not only in technology, but in every field, with other democracies in the world. And India, of course, being the biggest democracy in the world, is a prime player in that whole field. Democracy is under pressure. I mean, there are fewer democratic countries now than there were 20 years ago, and some countries are obviously drifting in the wrong direction. So we, as like-minded countries, we need each other, and we need to cooperate in every possible field, technology as well as politics and economy more in general. We see a lot of investment flowing to each other. My country is the 3rd largest investor in India India is the 4th largest investor in the Netherlands. That's not as impressive as the figures my American colleague just mentioned, but bear in mind that Holland is a small country. We only have 17 million people, not the 320 million of the US or the 1.4 billion that India has. And a lot of that investment flows to one state. When you look at the numbers from the Ministry of Trade in Delhi, you see that over the last quarter that we have information available, was the first quarter of fiscal year 2021-22, 49% of all foreign direct investment flowing into India goes to one state, Karnataka. And my friend Karnatakans, and I'm one of them because I live also here in Karnataka, you're applauding for yourself, because you're doing an excellent job. and within Karnataka, most of that money flows to Bangalore, because when we talk about technology, it's mostly Bangalore, Pune and Hyderabad that are taking the lead in developing this country and making it a hub. And as I said before, it's crucial. We have to extend the technology in the world, and we have to extend the number of producers of semiconductors and other technology products. And of course, India is a prime candidate. A country like India that can build up space technology from scratch in just a few decades and now launches satellites for less than half the price than we do it in Europe or in the United States, well, such a country can also build up a semiconductor technology, and we're happy to cooperate with them.
Thank you. Let's turn to Dong Kyu Kim. I mean, look, Samsung is the key player, right, in the global production. What are Samsung's plans? Is it ready to come into India on this field?
Sorry, I cannot say right away on that answer, but private companies' decision is based on their judgment on the market risk and the opportunity. So that the important thing is how India can approach Samsung or other the Japan or the Taiwan companies to conglomerate of semiconductor business the leaders. How we can the approach, how we can discuss, and then how we can show the this opportunity safely is the important thing, I think. Yeah. Sorry, thank you.
Turning to you, Barry. I mean, I think one of the things Australia has done in the last few years is to develop the concept of resilient supply chains. Because you've been so tied to China, but now I think what's happened in the last 3 years, the lessons learned, the need to diversify, create resilient supply chains. How do we extend that concept, which India, Japan, and Australia talked about, into the Quad framework and more broadly into the coalition of like-minded countries?
I think it is happening, and as you say, post RCEP, Japan initiated an India, Australia, Japan effort on reliable, secure, whatever you want to call it, supply chains in critical areas, and that work is progressing. It's been progressed further by the Quad, but of course what the Quad brings to it is a desire to firstly map where the gaps are, where the risks are, and to start from that position. So that mapping is now being done, and that's where we'll start moving forward. But great opportunity for Australia and India, because we're not competitive economies, we are complementary economies. We have inputs like metallic coal to assist the steel industry here to deliver the infrastructure mission. Equally in this sector, we have the critical minerals and rare earths, thanks to God, available, and as we develop those, as Kabul comes in and invests and we start sending those back to India, we will evolve and practically deliver those secure supply chains to India that can then be replicated across that Indo-Pacific region. And just to show you how serious we are, so critical minerals was one of those matters that Prime Ministers Modi and Morrison discussed in their summit, virtual summit in June of 2020. We put together a report on critical minerals. We identified and mapped the critical minerals we thought that India would need. And only this year we have adapted that to include high purity alumina and silicon, precisely because of what we're seeing happening here in India in terms of the policy announcements around these areas. So, it's not a case of build it and they will come. It's a case of India announcing another mission, and Australia and other countries, frankly, reliable partners working together to deliver the supply chains. Because when India develops an industry, in this case semiconductors, but in other spaces electric vehicles and battery storage, it provides that international competition that delivers better prices for other countries, and delivers also that free trade that Drew was talking about, that basically provides the world with greater certainty. So that's how practically we're trying to do it.
Drew, you talked about the Quad and the technological partnerships that the last two summits talked about, September 2021 and recently the virtual summit. Now we are actually just 3 weeks away from the next summit in Tokyo, where the 4 leaders are going to meet, that is US, India, Japan, and Australia. Can you give us a preview of, I'm not putting you on a spot, but generally the direction on the semiconductor side, where we can go for the next stage in the summit?
Well, that's a great question, and I won't predict or try to prognosticate about the exact items on the agenda. As you know, as a real expert in the international relations sphere, these things often they're finalizing in right up in the run-up to it exactly how much they can accomplish or how much they're going to do. But it's really if we think about the Quad and what the countries in it have been able to do, it's really breathtaking. Like 4 years or so ago, it was meeting for the first time in a while at the assistant secretary level, and now we've had several leader meetings, as you say. But another, with respect specifically to the topics that we're on here, it's amazing how much the Quad has reflected the fact that our strategic competition has become totally economic. The Quad really used to be about some other topics and maybe a little bit this, but if we look, since our new administration in my country, every new leader-level working group that's been introduced in the Quad is 100% about this, strategic economic competition. And so I think you can see a lot in the Quad countries. As you pointed to, each of them really have strengths in the semiconductor area. And so whether it's more work on design or any number of other things, I mean, it's hard to, it's hard for me to be able to predict here exactly. But I'm certain, given the importance of the supply chain resilience that we've talked about, that it's going to be a continued focus, if not an increased focus of the Quad. And let's see what happens in Tokyo in a few weeks.
Thank you. I think we now have about 10 odd minutes for questions. So I saw one hand there. Pranay, is it Pranay? Can you just introduce yourself?
Hello everyone, I am Pranay. I work on semiconductor geopolitics. It's great to talk to you about this. So my question was that, there is a lot of talk about building national capabilities, which is very much required, but as of what I can understand, building a resilient supply chain requires multilateral cooperation, right? That's a necessity and not a choice. So from that angle, are there any collaborations in place or being worked out to, let's say, start a prototyping fab where all the smaller companies can try to reduce their time to market? Or are there plans to set up new center for excellence in materials or new architectures? So that was my question to all the panelists. Thank you.
Thank you. I think hold your thoughts. Are we going to take some? Nivriti wanted to come
India is investing 10 billion already. It would be lovely to see how we can come up with a central partnership engagement model to build self-sustaining semiconductor ecosystem. That would be lovely to see with all of our partnerships.
Anyone else? I can take, yeah. So,
hi.
Please introduce yourself and be brief.
Yeah, my name is Ananta Bhatt. I am in the skilling industry, especially to requesting the US representative. Do you see that in next few years, the US universities can have a presence in India? There are cases of top US universities being in Middle East. With appropriate policy change, can we see Stanfords and Berkeleys and MITs having the branches in India down the lane in next few decades, or next few years preferably?
Okay, so we'll take those 3 questions. You want to start? We'll go this way.
One more comment, maybe one more comment before you answer.
Okay.
My name is Erez Zimmerman. I'm from Tower Semiconductor, Israel.
Okay.
And my question is complementary to Nivriti, and especially for a gentleman from the Netherlands. So we all know that you are holding the supply chain by ASML lead time right now, and this is really interesting to know how ASML will release this bottleneck for the entire industry to getting ramped up. Because right now, as we all know, having an ASML machine is more than a year and a half lead time or so. So this will be very interesting, very important point.
Yeah. Anyone wants to come across, Barry, anything?
Look, I'm simply happy to repeat in relation to the supply chains that, India is putting an enormous amount of money on the table to develop its semiconductor mission. The Australian government is doing likewise to get the mineral supply, the critical minerals and rare earth supply, up to scratch, out of the ground and processed to be able to put in place with other countries those supply chains for those resources. You're right, it involves lots of countries, but I've noticed as a former politician, recovering politician who's playing diplomat in this country, that the more countries that are involved, the larger the multilateral forum, the slower it is. So I'm happy to keep cooperating with India and Japan and within the Quad to get something practical delivered. Politicians and ex-politicians are always transactional rather than simply forums of talking about it.
There was one question on universities. I think you should address the question to the minister and largely outside. I mean, I think it's really, it depends on what we do. I mean, I think we've been talking about this for really 20 years, hoping that at some stage, but I think the new economic policy has provisions for it, of setting up world-class universities in India. And to some extent, there have been collaborations, as you know, between different institutions. And I think as the economies of of India and the US and India and the West more broadly come together, and there is greater collaboration in technology areas, I think it is a question of time. I mean, how you bring in the question of talent has been addressed in this Semiconductor Summit. And it is a question of, the market forces themselves are going to drive. Either you send them all to the US, pay big money to the universities, or get some of the universities here. I mean, either outsource students or get the in-source students. I mean, I think it is going to be inevitable that we're going to create the policy conditions for greater exchanges within the high technology domain. Australia is another major destination. You wanted to come in on that?
Well, I was simply going to say that there is enormous interest amongst Australian universities, which are, again, smaller than US and UK universities and to some degree a bit cheaper, even though the quality is the same. That's just a commercial. As of January, we have 360,000 students from India studying at our universities. And those universities in Australia are also keen to have Australians studying here. And Minister, providing the national education policy regulations match the ambition and the statements in the policy, I think you will see those dual degrees, those institutions looking more closely about and establishing presence here in India.
Any other questions from the floor?
Just a question to the Ambassador of US.
Just introduce yourself.
My name is Murli. We're working in the space of active mobility, cycling, sustainable mobility. So we are collaborating already with MIT and Stanford universities. So basically, what we realized is it's let's say making of a cycle, simple cycle itself, right? So there is a product realization lab in Stanford University where they teach the students how to design the cycle, understand the mathematics of the cycle, and the student will design and take that cycle on a tour. Okay, that is the first semester kind of like things, right? So what I realized is in our universities, there is not much focus on practical things translating immediately. There's no realization of what we're learning, right? So I'm just requesting, is there a possibility that we identify this critical, whether it's semiconductors, where there is actually need for putting your hands and getting some practical insights, right? Identify this very critical professors and kind of have this kind of industries also there and kind of have a stack wherein we can interact with these professors and make that learning curve faster with these direct interactions.
Yes. But I think the question is really about how do we create conditions within ourselves? I mean, that's a task for ourselves, and I would really say, in some senses, I mean, the last few years we've seen, the semiconductor mission is one example, of creating domestic conditions for raising to the next level, raising the Indian economy to the next level. I mean, everyone agrees knowledge economy technologically driven economy, that those are the goals. But the policy environment has not facilitated in that past. That's why you had everyone going out and doing things. But today, as the semiconductor mission points out, to create conditions for producing in India. I mean, that is the meaning of, say, Atmanirbhar Bharat today. This is not the self-reliance of the 1970s. This is one of producing in India and producing for the world through partnerships. In the 70s, we really shut ourselves down completely. Many of you might not born before that time, but we threw out IBM from India to our credit, so that was needed some genius. But there we were. I mean, I think it is our domestic policies that actually pushed ourselves out. But today, I think the conscious pursuit, both on the EV side and on the semiconductor mission, I think it's even more grander in scope, that of creating domestic, because there is international capital, there is technological capability, there is a political will among India's friends to work with India. So I think all that is needed is to really create the conditions for making India a semiconductor hub. I mean, I think all of you have heard in the last few minutes words like trusted partners, resilient supply chains, because as I said, this is not going to be anyone can make anywhere, that it has to be among friends. It has to be among trusted partners, and that we can work this in a way that a globalized way, not in the post-1990s sense, but a globalized structure among trusted partners that can deliver the goods for everyone's benefit. And that is the broad idea. And I think the semiconductor mission is trying to capitalize on that, both by creating conditions at home and by embarking on partnerships with critical countries. And I think that's why, if this is one of the most exciting missions that India has launched, we really wish Minister Rajiv Chandrasekhar great good luck in this, because I think I see the stars are getting aligned, both in terms of India's domestic policy environment, the political context in which India is today much closer to the West and those partners who are today, there is capital available, and there is problems that were created by certain countries have actually created, you couldn't get better circumstances than these to actually take this semiconductor mission off the ground. But I would conclude by saying the governments can facilitate. The government's job is to create a policy environment in which new things can happen, bring in the foreign policy elements into it, bring in the domestic policy aligned with the possibilities that exist. But in the end, this still has to be done by B2B, scientist to scientists. And I think here where we have a lot of strengths, India is already globalized in a way. Indian scientists everywhere in our friends, I mean in North America, in Europe, in Australia. So you have actually a natural talent pool already distributed among the key partners. So therefore I think we're really poised. And here, that's why I would simply say, I want all of you to join me in thanking our panelists for giving us such a wonderful session. And also wishing the Minister and the Semiconductor Mission a grand international success. It's not just, we need foreign policy to make domestic economy succeed. Actually, the domestic economy, if it's going to do well, it's going to change the world as well. So let's stop here and thank the Minister. Thank you all for your patience. Thank you.
Sincere thanks to all the dignitaries for making this a great success. And thank you very much for being here. So they want you to come. Yeah. would request all of you to kindly take your seats. We're all set for the next session, which is on the virtual mode. The next session is about India's role in global semiconductor supply chain. We have Mr. John Newfer, who has already joined us online. He's the President and CEO of the Semiconductor Industry Association, which has been the voice of the chip industry for over 4 decades. He has been the nexus of technology, public policy, and trade. He also serves as a member of the Board of Directors of the Semiconductor Research Corporation, the world's leading non-profit industry government academia microelectronics research consortium. So ladies and gentlemen, please put your hands together for Mr. John Newfer, who is going to take us through this session for the next 15 minutes or so. Hello, sir.
Hello, everyone.
Welcome.
It's a great pleasure to be here.
Yeah.
I would like to thank the Ministry of Electronics and Information Technology for envisioning this unique platform and inviting the Semiconductor Industry Association based in Washington, D.C. to share our perspectives with you. I'm John Newfer, President and CEO of SIA. SIA is the voice of the semiconductor industry, one of America's top export industries and a key driver of America's economic strength, national security, and global competitiveness. The U.S. semiconductor industry directly employs over 250,000 workers in the United States, with sales totaling nearly $260 billion last year. SIA represents 99% of the U.S. semiconductor industry and nearly 2/3 of non-U.S. chip firms. Just a couple weeks ago, I, along with several of my SIA colleagues, had the great pleasure to travel to India for an exploratory visit to learn more about this country's policy ecosystem, your efforts to strengthen your role within the global semiconductor value chain, and learn more about your private sector. In fact, that visit was the very first overseas visit by us in over 2 years. We had the great pleasure to meet on that visit with Minister of Economics and Information Technology, Vaishnaw, Minister of State, Chandrasekhar, Minister of Commerce and Industry, Goyal, as well as secretaries leading the various departments. These meetings in New Delhi and Bengaluru were encouraging and highly informative. We saw the enthusiasm, commitment, and potential India has to contribute more to the global semiconductor supply chain. Then, shortly after returning to the United States, we also had the honor of meeting Finance Minister Sitharaman to discuss the potential of India's IT sector. We welcome the pioneering vision of the government of India and Prime Minister Modi to develop a sustainable semiconductor and display manufacturing ecosystem in this country. The announcement of the $10 billion incentive plan is a visionary step toward making India a key hub within the global semiconductor value chain. The semiconductor industry is both essential to all of us and truly global. The global chip shortage has reminded everyone that semiconductors are now embedded in virtually everything in the modern economy with an electric current flowing through it. And the industry has become so global that in today's interconnected world, no country can or should attempt to fully indigenize our complex semiconductor supply chains within its border. The need for deep technical know-how and expertise has resulted in a highly specialized global value chain where regions and countries perform different roles according to their comparative advantages. All countries, including the US, are interdependent in this integrated global value chain, relying on free trade to move materials, equipment, intellectual property, and products around the world to the optimal location for performing each activity. From the time a chip is developed to the time its manufacturing is complete, it literally crosses dozens of borders. The way forward is to enhance the nation's position within, not outside, the global semiconductor value chain. India has a tremendous opportunity in this regard, and we fully support your endeavor to upgrade your semiconductor ecosystem by more deeply integrating into these global value chains. Global collaboration is the only way forward. Already, India is a critical hub in the semiconductor value chain. Roughly 20% of the world's semiconductor design workforce is located here in India, and many, if not all, of the world's chips include some form of contribution from India. This is a tremendous asset. India and the United States have already collaborate in semiconductor research and development. The Semiconductor Research Corporation, located in the United States, and more than a half a dozen Indian research institutes are collaborating on joint R&D projects. You're all well aware that India has many unique assets, including a skilled workforce, competitive labor costs, and abundant innovation. And SIA would like to help build on those assets to further India's goal of creating a robust semiconductor manufacturing sector. Today, India accounts for 1% of global trade in semiconductors and 0.5% of global semiconductor sales. While admittedly starting at a low base, India's role in trade and sales of semiconductors has grown impressively. Integrated circuit imports into India from 2015 to 2018 jumped by a whopping 218% to $8 billion. In 2021, India's integrated circuit imports grew to $12 billion. And today, the broader Indian ICT market is burgeoning, accounting for nearly $150 billion in total sales, with growth projected to accelerate over the next decade. For example, in 2021, India accounted for 12% of global smartphone sales. As a result, an increasing amount of original design manufacturer electronics assembly is happening in India, which will provide a stronger incentive for more upstream electronics investment. Many countries are seeking to invest more in manufacturing semiconductors domestically and are offering significant incentives to achieve this objective. We welcome India's goal of becoming both a more powerful digital economy and a hub for electronics and semiconductor innovation within the global value chain. We really think India has an opportunity here to make targeted investments to enhance the competitiveness of its domestic semiconductor ecosystem across all segments: research, design, manufacturing, and assembly test. I'll add that a semiconductor ecosystem within India that is welcoming to all firms and forms of business models and partnerships is likely to be the most successful. In the US, SIA has long advocated for and will continue to promote the importance of maintaining and strengthening global supply chains. Our goals within our own country are to invest further into developing chip design and manufacturing capabilities, and to help our allies and partners also increase their capabilities. SIA plans to continue our dialogue here and would welcome the opportunity to help our companies better understand the government's incentive schemes. India's Semicon program, with an outlay of $10 billion US, has various initiatives that have been introduced for strengthening the semiconductor and display ecosystem in this country and have the potential to position India as a more important player on the semiconductor map of the world. SI looks forward to collaborating more with India to promote a healthy global semiconductor value chain that embraces open competition, protection of intellectual property, and strong global trade rules. We look forward to India's commitment to further economic development and the opportunities it would bring for both US and Indian firms alike. Platforms such as this, India's first Semicon conference that touches upon the nuances and complexities of the semiconductor ecosystem, put under one big, wonderful tent the key stakeholders from government, industry, and academia. This event helps light the pathway to a bright and comprehensive Semicon ecosystem in India. We very much look forward to witnessing and supporting the next phase in India's great semiconductor journey. Thank you.
Now move on to the penultimate deliberation from Prabhu Raja, Applied Materials, about semi-equipment perspective in mission mode. Mr. Prabhu Raja, as you can see on your screens, leads Applied Materials Semiconductor Process Equipment Business and Global Field Organization. And without much ado, straight away over to Dr. Prabhu Raja, Senior Vice President, Semiconductor Products Group, Applied Materials. Over to you, Dr. Prabhu Raja. Are you there? Yeah, can you hear me?
Yes, I can hear you.
Yeah, please go ahead, sir.
Thank you for the kind introduction. Today I'm going to talk about semiconductor manufacturing from equipment perspective. And just a brief introduction about Applied Materials. We are world's #1 in semiconductor and display equipment, and with the $23 billion in 2021, and we spend around more than $2.5 billion in R&Ds. We are over 19,000 countries, and particularly we have 15,000 patents more than and 12,000 process. Every single day, even including weekend, we generate 4 different patents every day we generate. And with that, the key messages I want to give, how you heard about this AI semiconductor manufacturing, what challenges it's bringing for semiconductor manufacturing, how equipment and process innovation, what we do, are enabling those semi-manufacturing. And we are expanding in Applied Materials in India, particularly on product innovation commercialization. I want to talk about 3 topics. Particularly the first one, remember many devices you guys have seen, the clocks and what's video cameras, all have gone into one smartphone, replace all of them. Today's big devices, you look at this computers and the cars and phones and many small devices, all have become AI-centric world. And human and AI are very closely connected right now. And in fact, in the future, this AI will be enabling the human even more. And really look at those semi-industry. We saw the 4 big waves of growth, starting from mainframe to PC era to mobilities. Today, we are at AI era, the early stage of AI era. By far the biggest one. It would go up to $1 trillion semi-revenue by 2030. And the billions of devices are connected through this. You must have heard many times, and again, this AI happens both in cloud and also on edge. It's enabled by wide range of semiconductor, not just logic devices. You can logic, memory, DRAM, NAND, packaging, power semi, compound semi, and image sensor. All the wide range of devices are enabling this artificial intelligence. You must have seen this. This transformed the entire industry, health industry, transportation, entertainment. You see it day in, day out, how AI is transforming today. It comes with a lot of challenges. You can see one of the biggest challenges what we see, the power consumption challenges, both in edge as well as the cloud. If you really look at the edge alone, even if you take this camera, smart cameras you see all over, in some countries, you can see more than 500 million units, and the power it consumes, even the cameras alone, equivalent to 1 US nuclear power plant, power energy generated by this nuclear plant. If you go to this AI data centers, you can see that training plus interference combined together, 15 to 20% of global electricity by 2025 would be consumed by AI alone. This is absolutely not sustainable. Today's way of doing semiconductor is not going to address these challenges. So you need new semiconductors with a lower power consumption, higher performance, smaller areas, lower cost, and more importantly, speed, faster time to market. So industry is a playbook, what we call it, PPACT, power, performance, area, cost, and time to market. This is the industry new playbook. this is enabled by, you can see multiple inflection happening in the semi industry, new architectures, new structures, everything's going 3Ds, new materials, new ways of strength, advanced packaging. You must have heard all about this. These are all enabling this PPACT strategy. The foundation for all those things is materials engineering. And I want to give one example in advanced packaging. Multiple chips are connected together as one chip. They're very closely connected. The processors and also the memories are closely connected. They have huge performance gain and lower power. I just want to run a video how it looks.
Here is an advanced package integrating logic and memory chips. A substrate connects the package to the external motherboard. Further up, a silicon interposer serves as a foundational connector with spherical bumps, long copper columns known as through-silicon vias, and multi-tier copper wiring, or redistribution layers. Moving higher, we see the vertical stacking of individual memory chips with through-silicon vias and micro-bump connections. Switching to the logic side, we see chiplets connected to the interposer by through-oxide copper vias and microbumps. Further inside, SRAM chiplets are connected to the AI logic die on top with copper hybrid bonding. Redistribution layers and through-silicon vias connect the SRAM die back to the interposer, completing the package connections. In summary, logic chiplets and towering DRAM memory stacks are connected as a system.
Assume packaging is simple. It's not that simple. It's complex. Imagine the complexity is what we see. It is semiconductor manufacturing. And next section, I want to talk about how our equipment and process innovations are enabling the semi-manufacturing. Really look at you take an iPhone, you really look at the processor which is driving A15 phone. You'll see, if you cross-section those one, you'll see multiple layers of materials in the different shapes. You can see that. What it has is more than 15 billion transistors and more than 90 kilometers of wiring it has got inside right now. Why I'm talking about? I'll talk about those challenges it brings. And what does it take to do this process? You need more than 1,000 process steps. It takes 2 months long. The wafer keeps running to the 2 months long. It requires multiple equipment capabilities. These materials need to be deposited. Materials need to be shaped. Materials need to be removed. Materials need to be modified and treated many times. And also you need a lot of analysis. At the top of it, also lithography. In applied materials, we have a 60 product families to address this. And one of those equipment, I have it here, this is a state-of-art equipment. We call it Endura deposition product. And it's a pretty complex and which done atomic layer level. It can do multiple steps under vacuum. And I can tell you that every advanced chip today, it runs through this machine at least once, in most cases multiple times. So what are the complexity we see in our equipment? The simple example, if you take one transistor, which is 20 nanometers dimension, the gate is 20 nanometers. What is 20 nanometer? How small is 20 nanometer? You can see human hair is 60,000 nanometers. And you can see the red blood cell is almost 7,000, and even human DNA with is 3 nanometers. So within these 20 nanometers, we put 6 to 7 different materials. A lot of them are nanomaterials. They're 1 or 2 nanometers thickness into the small dimension. It requires atomic level processing. Every atom matters. It's extremely complex, atomic level processing. Imagine you do atomic level processing on an industry scale. We talked about single transistor complexity. You have 15 billion transistor. Imagine you have 400 chips in a wafer. You have 100,000 wafers per month in 1 giga fab. You can imagine how many fabs we have, gigafabs, or multiple fabs we have in this world. So we got to do this atomic level processing in industry scale day in, day out. Every atom matters. What it requires to develop equipment, lot of innovations and commercialization. Innovations. You need lots and lots of expertise, foundation science, university partnership, concept and feasibility labs. In terms of commercialization, multidisciplinary engineering. You start any electrical, mechanical, software, data science, think about anything you need. Manufacturing capabilities, supply chain ecosystems, and also customer support. You need a really commercialization. That's the foundation. I just want to give an example of applied equipment process innovations. What do we do? Two good examples. One, the biggest problem industry is facing is wiring resistance. Why? The huge power loss from wiring resistance when you go to smaller and smaller dimensions. 1/3 of chips power is consumed in wire. On the left-hand side, you can see those. One layer, if you take a one layer, one single metal layer, you can see that is 30 nanometer in size. On the right-hand side, you can see the node over node, what is the wiring resistance, it increases exponentially. That means a huge power loss is not sustainable. I want to show that one of the applied innovation is helping. You'll see on the left-hand side, the equipment, you see the animation, how the wafer is moving through from one process to other process. Just to deposit one metal layer, it has to go through multiple layers, multiple process, interface engineering, selective ALD depositions. Look through metrology, make sure it's okay. You want to treat the materials. Liner depositions. You can imagine what kind of complexity it does, and all has to be done under ultra vacuum. These wafers from one step to other step cannot be taken out of the vacuum. Imagine you have 1 nanometer. The material is not the same when it comes out exposed to air. So you can see the innovation. What does it do? The same plot what I showed that. 50% lower resistance by doing this. Again, imagine 50% lower resistance, the billions of VR connections. And even if you take 5 critical layers, it's a huge power saving. These innovations can make a big difference. Another example is in the transistor side. The transistor leakage. You all know that your phone, the powers don't last for a longer time, few hours. You can see that, and the phone gets hot. It's all coming from the transistor leakage. On the right-hand side, I put transistor leakage versus gate dielectric dimension. When you go to smaller nodes, you are on the right-hand side. In this plot, you can see your lower is good, upper is bad. You can go more. Industry has seen this problem once. The leakage kept increasing, made a big changes in the materials innovation, high-k metal gate, again starting to go up in a smaller node. Industry is struggling today. So what we have in applied, the process and materials innovation. We can have up to 1000x leakage reduction by modifying one layer, one atomic layer by modifying. We can see that is a huge innovation, big innovation. Imagine these leakages in one single transistor times 15 billion transistors. It's a huge power saving, or you can call it transistor speed increases by 20%. These are some of the big innovation I want to share with you. With that, I want to move on to what are the opportunities we have in India and why we are expanding in applied materials in India for product development. A brief introduction, Applied Materials India, we have 6,000 employees and 5 different locations. We have very, very strong partnership with the premier universities in India. A lot of capabilities in science and engineering. I think we are creating around 450 patents overall we developed so far, US patents. And also, you know that I announced that what we are investing in India, 340 crores for new infrastructure, also 1,500 crores for product development, innovation, commercialization next 5 years. What does it take for process developments and developing a product? Multidisciplinary science and engineering, data science, labs and plasmas, lots and lots of capabilities. Where you see the green circles are the places we already developed the capabilities. We have a capability today. India is helping us for product development here right now. The white or the circles are the places where we are focusing. That's where I was talking about expanding in India, investing in India to develop those capabilities, product development capabilities out of India. If you really look at those for India, it's a time of big opportunities in India. The conventional manufacturing today is growing. Demand is high. All logic, memory, everything is growing. On the top of it, there's a new manufacturing needs in legacy node, IoTs, compound semi. I think we talked about multiple times, image sensor, packaging, the new manufacturing needs. If you really go and summarize everything, the market is growing, the demand is there. And also a lot of new manufacturing opportunities are opening up. AI is bringing lots and lots of challenges, and it needs a deep technical talent that India has plenty. And with the government supports on right now on policies, I think it's truly India's time to shine. Thank you.
Thank you, sir. A couple of questions? I think we can take a couple of questions, if any. Anyone? Yeah. Yeah. Straight away come to the question, please. Yeah.
Hi, I'm Manoj from SCL, Chandigarh. I think we have been discussing about the equipment lead times recently. So can you now comment what will the lead time for Endura systems now?
See, they all depend how we prioritize. The demand is huge, high, I can tell you, very high demand. And everyone has supply chain challenges, and we are going through those supply chain challenges. We are learning a lot, and we are solving a lot of those problems. So you can see one of our biggest challenges is even the chips. We need a chips to manufacture the equipments, and one of the bottlenecks for our customer is our own equipments to make chips, right? Our customers are helping us with the chips. I think today doesn't matter based on priority. I think we always think that we should be able to do it within a year. Yeah.
Thank you.
Any other questions? No? Yeah. Thank you, Mr. Prabharaja, for taking time off and being amongst us. Thank you very much for joining us on the virtual mode. Well, we now move on to the final conclusion stage, and it's my privilege and pleasure to request the chairman of the steering committee of Semicon India 2022, the Honorable Minister of State for Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India. In a short while from now, he would be addressing us, and yeah, it's on demand, madam. Yes, Ms. Mai Jagdish to kindly come over. And yes, it's a suspense. Yeah, it's a different welcome suspense. So put your hands together for her.
Well, I was thinking the conversation that happened between our minister and Raja Koduri would be forgotten on day one, but it's not. By the way, it was my privilege to inaugurate, to start this event, this wonderful event, by lighting the lamp. And today, as with the Indian custom and culture, we typically start with something very auspicious by seeking the blessings of Almighty. And ending also has to be something very auspicious. So I'm a trained classical music vocalist, and I'm here to sing a few auspicious verses. These are called Mangala Shlokas, taken from Srimad Bhagavatam, which is a scripture written in glory of Lord Krishna. These verses are very special to me because these were actually composed by my grandfather, Subramanya Shastri, who was a Sanskrit scholar. So I'll make an attempt to sing these verses and seek the blessings of Almighty again, so this auspicious ending can lead to many other auspicious beginnings. Sorry, I just need to turn on my Shruti. Just give me a sec. सत्यज्ञानस्वरूपाय विश्वोत्पत्त्यादिहेतवे तापत्रयविनाशाय श्रीकृष्णायास्तु मङ्गलम्। दुष्टकंसभयच्छेत्रे शिशुपालादिध्वंसिने जरासन्ध विमोक्षाय श्रीकृष्णायास्तु मङ्गलम्। योगिज्ञानवरेण्याय निर्मलज्ञानमूर्तये देवहूति सुपुत्राय कपिलायास्तु मङ्गलम्। कर्दमज्ञानबोधाय नित्यज्ञानस्वरूपिणे भक्तहार्दतमश्चेत्रे कपिलायास्तु मङ्गलम्। नारायणस्वरूपाय साङ्ख्याचार्याय योगिने संसारभयहर्त्रे च कपिलायास्तु मङ्गलम्। दयामयो हरिः साक्षात् मातुः प्रियचिकीर्षया अजन्मापि भवं भेजे कपिलायास्तु मङ्गलम्। Thank you.
Well, ladies and gentlemen, we all know Sanskrit is the bhasha of devatas. So by remembering all the devatas on behalf of all of us, it's indeed a very special moment for all of us. I think we should give a huge round of applause for Madam there. Thank you very much. And with such a great backdrop for the concluding remarks, we are all set to welcome the Honorable Minister of State and also importantly the Chairman of the Steering Committee. Ladies and gentlemen, put your hands together and welcome Shri Rajiv Johnson.
Namaskara and good afternoon. On that beautiful note, I think it is time to draw the curtain on what has been 3 days of very inspiring, very energetic, and very illuminating conversations about our mission to catalyze India's semiconductor ecosystem. I will not speak for too long. It's been 3 days, and I'm sure that most of you who have traveled from far have to get back. Tomorrow is a Monday. I'll just quickly say a few points. One of the best ways to characterize a success or failure of a conference is the intensity or the interest or the freshness of each day. And Vindham, I think he's not here anymore, he was telling me that he has never attended a 3-day conference like this where every day he was looking forward to every session. And I think that is in itself a testimony to the quality of this Semicon India 2022, the inaugural Semicon India 2022. And let me start by just thanking each and every member of the steering committee, my colleagues in the ministry, and indeed every one of the industry stakeholders who worked very hard to make this inaugural Semicon India a success. Again, let me just quote, 2 young engineers walked up to me at the end of day 1 as we were moving to dinner, and they said to me that this, according to them, actually it was the second day, yesterday, and they said to me that this is the best collection of high-tech leaders that they have ever been part of. So I think that is again a testimony to the very high quality of conversations around compute, around AI, semiconductors, the future of systems, systems architecture, talent, fab, that characterize these 3 days. The MOUs you also have heard of and read about. Those MOUs also summarize many of the leading foundational elements of this conference on manufacturing, talent, design and manufacturing, and partnerships. I can assure you that on behalf of our Honorable Prime Minister and the government, and he made that very inspiring speech on day 1, and he set the bar for all of us in government, which is that the government is an AND gate and not a NOT gate. I can assure you that we will play the role of an AND gate for this ecosystem. Our mission is our Honorable Prime Minister's vision. We are very, very determined as a team, as a nation, as a people, to ensure that his vision of making India a player, a significant player in the global supply chains for semiconductor is actualized and realized in the coming months and years. I will say what I said in yesterday's press conference to end this whole 3-day Semicon India conference. It used to be that the world used to say, my system is powered by AMD, my system is powered by Intel, my system is powered by NXP, my system is powered by TI, Infineon, NVIDIA, as the case may be. And Microtech, I noticed Microtech is there. But what I think the vision now for us, the mission for all of us is that regardless of which platform, regardless of which brand, which company, regardless of whether it's a global company or an Indian startup, whether it is a DIR5 product or an ARM product or an x86 ISA, that we should be in the coming years be able to say that my system is being powered by India inside. And I think that is the goal. That is a thought I will leave you. That is a thought I want to leave in all of your minds, that our mission is to make sure that India is inside all of our future systems. Thank you all again for participating, for engaging, for conversing, and contributing today, and I hope you will continue to do this in realizing and actualizing our Honorable Prime Minister's vision and India's vision to make India's ecosystem, semiconductor ecosystem, a significant partner to the global supply chains. Thank you. Jai Hind.
The team of I call them. The team of mighty all the members kindly come over for a photograph with the Honorable Minister.
I'll also request ISA, VLSI Society members to come over who have supported in this program. Without their help, it was not possible to conduct this. Please come over.
Mr. Amitesh ji.
Amitesh ji, can you come up here?